he was wrong about one thing. Is that a true
all
statement?
Of the history claims are just so tough to validate just in general. Like, for example, let's say right now, like, okay, a lot of people question 9/11, the moon landing, shape of the earth, right? All that stuff, right? Right now, there's obviously millions in total if you combine everyone that questions those things, you know, et cetera. Now, if there was like some World War III right now, just some insane world war, and there was a complete, you know, change of society, and there was all that, you know, 50 years from now, they might be able to weave a story and say, everyone back in the year 2026, they all believed it was a globe. They all believed that, you know, we went to the moon, you know, and that would just be a lie. It would just be false, you know, because right now that's not the case. So the way that you can rewrite history and that you can kind of like manipulate narratives, that for us to be sitting here and be like what men thought 2,500 years ago, it's just a huge leap of faith and requires a massive leap to think that somebody, you know, in the thousands of years of humanity, someone looked at the sky and went, oh, look, there's a round thing on the moon that must mean we're on a ball, and somehow blew everyone's mind. We're supposed to think that that was some authoritative. I know it goes into the whole thing of like the validity of history, but I'm just saying when you really think about it empirically, it just takes huge leaps to consider any of these history.
You know, do you know how long that would last? That would last as long as it took for people to invent two things: the digital camera and reinvent rocket propulsion, which would happen even if Earth was half destroyed and all the scientists were gone. People would just claw it all back, and they would create rockets again, and they would create cameras again, and then the cycle would begin again. People would believe Earth is flat, and then rockets would go up like the V2, and they would show pictures. Okay, Earth isn't flat, and then it would go. So it would maybe 50 years, 2 generations, so to say, 50, 60, 70 years.
Well, there were writings. There's writings about what these people said. It's not like we just believe it blindly.
There's not original writings from nothing from Eratosthenes, zilch, nothing. Shit's all made up.
Aristotle?
Writing from
That's
him.
not made up.
Eratosthenes. Eratosthenes is 100% made up. There's no original documentation for it whatsoever.
There's actually no original documentation for a lot of stuff that we have from history. That's true. No, we have no extant documents. That's completely true. The Bible actually has
there's also no there's also no handwritten manuscripts from Aristotle. So Robert, you're wrong on that one too.
There is.
There's no original writings of Aristotle either.
No,
is this really the most like important part of this of you know, like going back and being like, who knew what when? Like, I mean, it's just we can do all these observations today. Like, it doesn't matter to me if Aristophanes was a real person or not. Like, if it turned out like, oh, the whole story about him was made up, like whatever. Like, I'll just go do the thing, you know, myself right now.
Yeah, I got a camera and a rocket.
Yeah, it's not, you could do it now.
Exactly. Stick in the sun, you know.
Yeah,
or
just uses assumptions.
Well,
it doesn't.
So we get together, we build a rocket and put a camera on it. What assumptions are we going to make once we send the camera attached to the rocket? What assumptions are going to be made then?
Can you do it?
Two things. First,
the question is, can you do it? Can you have a rocket and camera attached to it behind, and it's recording the Earth and going out of the Earth, right? Can you do it?
Give me some students from Arizona and some money. Better believe it.
Okay, answer me. How high you can go? What altitude you can reach?
Unlimited.
No. Okay.
People do it all the time.
Do you think like
there's no? What do you mean?
The hell you're talking about? Okay. So the next question is, what do you think? Like, what altitude you need to reach to see the Earth as a globe with a camera?
That's easy. 5,000 miles.
5,000 miles. Okay, I agree. So, do you have a rocket that can reach 5,000 miles?
Oh,
there's only been 20. They claim there's only like 28 human beings that have even been past low Earth orbit, even in the mainstream deal, to even see the Earth as a ball. So you're kind of, for that one, 28 people. Is what
and only because of moon landing missions.
Did you add in? Did you count Artemis?
I think that does include Artemis, but
okay. There's not many.
It only includes moon missions like Apollo and Artemis and nothing else.
But do you think that number is going to go down, or do you think that number is going to continually increase? Well, that number can't go down. So do you think that number is not going to continually increase?
Yeah,
That's my question.
it is 28 because I guess there was 24 of the
Original Apollo.
missions, and then these 4 Astro Clowns that claim to have gone recently. Had to call them Astro Clowns.
You just
I just
can't. You've
had
got
to.
that little
There's
knife.
no clown, you just-
Astro clowns.
It's a little paring knife. It's a little paring knife. You just stick it in just like 2 inches. There you gotcha.
No, but
it's not like a saw. You chop someone's head off. It's just this little paring knife.
no, but that and I so rarely use the word clown, but I just had to right there because I thought it'd be funny.
trying to bait us.
No, but zzpop, I hear you. Like, I mean, to debate about what Eratosthenes knew or thought or whatever, I hear you. I mean, that was part of like the history, though, like the claim of someone saying, "Well, we've known the Earth is a XYZ for this long," so that's why we got into that. But I do hear you. Like, even if we don't go off anyone in the past, well, what can we do today to validate any sphericity to Earth? And the thing is, like, we can go through all of these, but like sticks in the ground does not validate the shape of the Earth because there's assumptions about how the light is traveling from the sun. The way anyways, we could go through all of these. You can go do long distance observations any day of the week and validate there's a lack of curvature. The boats over the curve completely breaks down when you actually look at all of the facets of it. Like they're now talking about rockets to space or whatever. I mean, that one nobody can validate other than these 28 government agents that claim to have been past low Earth orbit. So when you start to break down to what you actually empirically validate, because yeah, that'd be great if we could right now confirm Earth was a sphere. That would be one thing, but
there's something there's something so kind of fundamental I've never gotten a great answer from flat earthers, which is the question of, do we know the distances between cities or not, right? Because like this is pretty easy information to look up and go check. Like, what is the distance between New York and Boston and Toronto and Philly and DC and whatever? Like, just go through the whole world.
Bro,
And
how
I'd
do you
like
do that?
What do you
By
mean,
highway?
No, wait, hold on. Let me jump in. There's only one
How do I
country
confirm
that is
that?
really.
I hop
Hold
on,
on.
what,
There's
84?
only one country.
Fly a
There's
drone.
one country that is really suitable.
Buy a drone and drive to New York from Boston?
One
Yeah.
country that's suitable to
That's
do
not
this.
how it works, bro.
One country, and that is the country of Australia. It has almost not dead straight, but go to what is it, Perth to Brisbane? That drive is as straight as on any continent you'll ever find anywhere.
Okay, well, my response, zzpop, yes, another angle you're taking, I hear you. Distances could be very revealing, but when you really break down how difficult it is. Now, when you're driving on roads have elevation changes. Roads are obviously twisty and turny. You're also going to have some maybe slippage in the wheels and so on. But the way, like the roads have their own twisty, turny, and elevation components to them, so it's not a straight line distance. So it's definitely more complex, but I mean, you can measure distances. Yeah, you can get in a car, or you could even use something a little bit more accurate than a car if you want to, use like a wheel that you would roll on the road or whatever. But that's just road distance. So, there could be a different road distance versus a straight line distance, just based on like what they're telling us the elevation. You get into like the geoid and ellipsoid and the elevation profiles and so on. So I hear you though. The thing is, to decipher between planar or curved over with distances requires a significantly large amount of distance, like thousands of miles. So that's the other thing that makes it more complex. Like we've talked about, like if you go to the 4 corners of the United States, like southern tip of Florida, northeast in Vermont, northwest up in Oregon, and then southwest, let's say down in LA or whatever. If you had those 4 points, but I mean, how are you going to get a straight line distance? That'd be a huge project, but that's about what would be needed.
I get that it's not trivial for like an individual and to do this, and it would take a lot of time. But I just mean, between all of the public information that exists about road lengths and power line lengths and how many miles of undersea cable they laid across the Atlantic and flight times, which, yes, it's time. There's other variables that go into it. It's not a perfect proxy for distance. But what I'm getting at is, for the Earth to be flat, just a tremendous amount of things would need to be very different from what they officially are claimed to be about like the distances between locations on Earth, in ways that would have all sorts of ramifications for now. Like, okay, well then, are they lying about how many miles of power lines, were stretched across, this part of the US. Um, and what then explains how planes are getting this quickly from this city to that city this consistently, or is the flight log data um, forged? I'm trying to point out the kind of the ripple effects of um, remapping distances that do work on a globe Earth onto a flat plane, and all the things of our own infrastructure that would have to be deformed to accommodate that.
I do hear you. Yeah, so the distance thing is its own entire topic, and I do hear what you're saying. I think the thing is, the difference between planar and globe is actually less than one might think, because that's why I was saying you need like thousands of miles, and even at that
It's less
thousands of
than
miles,
10%. 10% less
we've
than.
crunched the numbers. We've crunched the numbers, yeah. So I mean, the amount that you'd be off in the like, let's say you made like a rectangle or a square on the Earth, the amount that you'd be off between globe and planar is an amount that the modern civilian person is definitely not going out there to check. And I don't know of anyone to this day that's actually independently checked it. We have this whole kind of matrix, if you want to call it that, the system we're in of surveying and claims and governmental USGA and all these different, geodetic surveying and calculations. And, they also use the sky for a lot of those. They use the positions in the sky. It's what's called the deflection of the vertical, and what they use in geodetic surveying. So now we get the sky involved in the sky physics. So it's actually more difficult than one might think. This is another thing that would take an entire research team and a lot of money and quite a bit of time to actually do a project like this. And I have many, many ways of how to go about that. But I'm saying if it were done, it would take that research team and all of that money and resources to do it, to then say, hey, here's the actual answer. Otherwise, we all we really have is what's given to us without being able to validate it. So I do hear you, but I don't know that it's just a trivial, easy thing, or I don't know that anyone can make an argument that's a really easy, trivial thing to validate. But I do hear you, like your kind of sentiment of like, shouldn't we be able to find this discrepancy if it really is a discrepancy that's right there?
Let me just rephrase for a sec how I want to make this point, because you're right that you could do a mapping from globe to flat that would leave distances pretty much the same between the two cases across a large part of the Earth, maybe where the majority of the Earth's population lives. Like, I was looking at some of the flat dual pole maps that you and New Perspective have presented, and as far as like most of the world's population between on the continent side of the world, Americas, Africa, Eurasia, like if you're only ever going back and forth across the Atlantic, yeah, maybe you could say these distances are pretty similar. But somewhere when you go from sphere to flat, some part of the map becomes dramatically different, by necessity, by kind of the geometric inequivalency between a sphere and a flat Earth. So let's say you do one of these maps in which basically most of the continents, most of the world, the distances look pretty similar between the globe and a flat map. What happens is that there will be some island chains, like off in the Pacific, where those island chains cross the equator. And we know people live on these islands and they take relatively short boat rides back and forth between these islands. But on the flat map, because of how it like splays the Earth out into these two pieces, the islands in these chains, they're called the line islands, it's just one example, that are just above the equator, end up at the tippy top of the dual pole map, above the Arctic. And the ones that are just below the equator end up at the absolute bottom of the map, way below Antarctica. So like there's no way to do a cut of a globe that maps to a flat Earth that doesn't somewhere take two things that would be close together on the globe and put them to opposite sides of the flat map. And you could move where you do the cut, right? You could try to make the cut in a strategic place that it wouldn't make a difference to most of the world's population. I get that. But somewhere in the world, the difference between the Earth being a globe versus flat is the difference of two towns or two islands somewhere, wherever you do the cut to like open up the globe map and press it down onto a flat surface, that on a globe are right next to each other and on a flat Earth are on opposite sides of the flat plane. So you can
And if
maneuver
you
it.
look at the distances, actually, I was looking up. I did a whole thing since you brought that point up. All those western islands, that they're all together, and they do cross the equator, which isn't against the dual pole map. You have to figure out. I'll have to explain it, or E1 will have to explain exactly how it fits together. But you can go across the equator as long as you stay on the west side, right? You can go across the equator as long as you stay on the east side, because those are just going to be on the east and west side of the dual pole map, right? It's where the international date line comes together, and then the make believe idea that the celestial equator actually goes around a ball and then connects to the back. So you can't, there's a certain crossing you can't do, but then there's crossings you can do. You can go across the top and across the bottom and across the side and across the side, but you can't go like as an X through the middle. And that's where you find the big discrepancies. And these distances between those islands, man, you won't believe it. I wrote down a whole list of them, and the ones that they put right next to each other, and then they're listed like 3,000 miles apart. I mean, that's definitely where they stitched the ball. You can tell. Just look at the distances. I'll put the list in.
What are you talking about?
8,000 miles. I don't think that's. I mean,
take a beach ball new perspective and try and make it flat. Good luck.
Right. The point is, where are you going to
That's such a good point.
Right. Where are you going to hide the cut? Is somewhere when mapping between the two is the cut. And wherever you put it, that is a place on Earth. I guess you could, if you don't do it straight at the equator, maybe you could finagle it into somewhere in like one of the deadest, most uninhabited areas of the Pacific.
Yeah, that's what they did. In the middle of the blue side of the ball. That's where the most uninhabited area is where they stitched it together. It's exactly what they did.
Well, at the very least, then all we need to do is send a ship there, to a place that on a flat map is split between opposite edges of the map, and on a globe
I think I sent you the E1 video talking about the armadas of ships that would block you. I sent it to you like 3 times when we were going over this, and you didn't watch it. It's armadas of ships sitting there. There's like a whole line of them, and he goes into specific detail showing the ships that are like sitting there. No, you can see it on dude. I'm not going to respond to Robert. We're actually having a conversation about something real. Oh, yeah, sure, yeah. Just be the negator and be like, oh yeah, what are you talking about?
Just say things
that doesn't contribute to anything. Just being a naysayer doesn't help the conversation.
Wait a minute.
No,
wait a minute.
You're the one that's not. You don't even know what I'm talking about, dude.
Wait. But on a flat map, an armada of ships enforcing a boundary would replace what used to be the Antarctic ice wall on the single pole map. Those ships would have to ring around all of the continents.
No, that's not the claim. He's just saying that he's noticed there's this armada of ships that's like a string of ships, and he tracks them over the year, and they move from the north to the south, depending on the weather. So for the north, when it's summertime in the north, they'll be up in the northern area, and then they'll move from the northwest down to the southwest. Or maybe there's armadas on the other area too. There's lots of details when you look at that. You couldn't just go like willy-nilly in a ship going across those areas. You wouldn't be able to. And there's buoys.
Wait.
I'm not making this claim. I'll put the video in the chat. Everyone can look at it and be like, "Oh, it's bullshit." It's not bullshit. It's actually what he's showing. Whether it's accurate or not is another question. That's what he's showing from a ship tracker actual app, not his app. It's not. He didn't make up the information. He's just saying what he saw. You have no idea what I'm talking about, dude. Don't just come in and be like, in the middle of a conversation between zzpop and I. You're not helping, dude. You have no idea. I'll put the video.
But
someone's going to take care of Robert. He's just going to ruin the conversation.
So I just posted into the live stream what the dual pole map looks like, right? And the point for me is that however you massage this, that boundary that we see on the dual pole flat map is all supposed to be a singular place. on the globe. Like that's where the cut is that opens up the globe to flatten it down. So on the globe, it should be that if you hit that edge at any point along that edge, you immediately come to the other side. That like
Right.
what it
You're
looks
right.
like to
You get it.
right.
You get
But
that
then
part
that
of it.
means
Yeah.
but then that means that your armada needs to be surrounding the entirety of all the continents to stop
No.
anyone from
No, he's not saying that. You have to actually watch. I sent it to you like 3 times, so I mean it's not that long. You just have to watch what he's saying in the video. He's not saying that there's an armada of ships that surrounds all the continents, or that's the only way that they contain anything. He's just saying he noticed that this armada of ships sits right there, in one spot. You know, it's kind of along the spot where you could like cross that area, you know, and prove that whatever it is, like where they stitched it basically. And there's also another thing I found out where there's like it's an illegal zone. Like there's another place where they stitched it where it's like illegal to go there, and it's between these two little islands, and they made up some reason for that. I'll post that. Don't just
Yeah,
be like,
sure.
what, dude? I have all the information. I'm not just
It's all
making shit
bullshit,
up, dude.
dude.
Hold on.
You can just say that, dude. Can someone
Just
take care of
say
Robert?
shit.
I'm gonna mute him
You
otherwise.
just say
You just
shit.
wait, no, but,
Dude,
but the point I'm making
not
is
helping
that
the conversation.
okay, when I look at the flat map, according to the globe, every single point on the boundary of the flat map is supposed to be the same as the point exactly opposite it, right? If you stitch the whole thing together, that would mean if any single ship went away from the continents on the flat map in any direction, it's going to hit this boundary that is supposed to be where the Earth connects around. But on the flat map, it doesn't. So if we're being prevented
Yeah.
from ever reaching the boundary and discovering that it is a boundary, rather than a looping path that comes back around, then that does mean that the controls that stop us from going out there have to completely surround everything. They have to make sure nobody goes in
No.
any direction out that far.
Well, that's maybe that is the case. I don't know if that's the case or not. But the thing is that people follow their compass and their the compass heading. And so if you're just going around the North Pole or around the South Pole, you don't think that there's an area that exists outside of the globe, right? If you could totally be on a ship and following the map and going around the North Pole or going around the South Pole like your mark you just made, and you wouldn't have any reason to go outside of it or try to go to the other side because you're just going to either the northern area that you're headed for or the southern area you're headed for, right? If you're a flat earther and you're out there trying to prove something, that's another thing. But these people just think they're on a globe and they're following their compass heading, and there's no area outside of that, boundary other than going into the northern hemisphere, or that's it, right? You're just going to think you're going in the northern hemisphere. So they have buoys, according to what he says as well. There's buoys that will direct you, and it's not like to keep you away from finding out the Earth is flat. It's just a direction heading to help the ships get to where they're going to go. Now they could have those placed very conveniently, so nobody, is going to possibly cross over into those waters. But once you get outside the field, the compasses go crazy too, is what he says. There's like anomalies that they actually report with certain areas where the compasses just freak out. And it would make sense because if you're going up from north, in quotes, up, up from the North Pole, and your compass is going to be going, be aiming still at the north because the compass always points north, but you're trying to follow your declination to the south. So the way that a magnetic field works is it splits off, and that's where you're going to get those, freaky compass readings if you go too far out that direction. And so people wouldn't be tempted to go somewhere where their compass isn't heading them, especially in those waters. You're not just like out there like exploring. You're in the middle of the ocean and you're just following the track that you're supposed to go, especially the shipping routes, because they're not like exploring anything. They're just taking things from one place to another, and they're very strict about where they go. And they're probably directed to be a certain path that will work with this model. If the Earth is a dual pole flat Earth, then it's all worked out and it's the perfect place to stitch it because the reason they're going to crash the ISS into the Point Nemo is because no one's out there, right? whether the ISS exists in the way they do or not, it's perfect to like, that's like, they say you would be further away from Point Nemo right now than you are from the ISS in the air. That's how remote it is, right? So that whole area is very hard to get any kind of like confirmed data about, and it definitely seems like when you see the list of distances from island to island, it just gives it away, bro.
I mean, this is fascinating to follow down the sort of stream of thought here, and like, okay, like I'm interested in this idea of like this magnetic misdirection that's happening, that like no one following most means of navigation around Antarctica or the Arctic does anything other than getting redirected back, within this sort of central area. Okay, but what about someone who's just going straight east or west along the equator? That's also supposed to loop around, right? So, like, if I'm
Yeah,
on a
but
ship and I'm
no one
leaving,
dead reckons. They always follow their compass, right? So your compass is gonna either take you north or south. There's no dead reckoning with the compass heading.
no, but does no one ever just try to follow the equator exactly on the equator?
Well, there's claims, but if you were like just north of the 0 degree, right? You could think that you're actually on the equator or close enough to it, whether you're in the south or the north, right? But then crossing over it, like Osco had an idea, like not that this would even be possible. I mean, there's speculation about tests that could be done to prove this one way or the other, like a plane in the air that's like on one side of the celestial equator and the plane on the other side of the celestial equator, and as they go west or east, are they forced to split off from each other one direction or another? Those kind of like hard um, you know physical tests that you could possibly do to prove this one way or another. But
Okay, but
it's also where the stars converge and diverge, and you could possibly even see a literal split in the stars going one way and the other if you got up far enough
I,
east or west
that's
or east, and you can see the stars splitting apart. They converge and
Stars
diverge
don't split
no matter
apart.
what you
Why do
think.
we have
That's
to
what they
keep
do.
saying this again? The
they don't.
stars do not split apart. They're in a fixed field.
And we're not going to get into that tonight, Jake. Come on, I can
Well,
hardly hear you, by the way.
let me then make kind of a related point here, which is like, okay, so let's say I'm basically on the equator, but I'm just slightly north of the equator, right?
Mm-hmm.
And I am going dead east, and I get to the point of 180 degrees on this of the blue lines here. I'm sorry for what are those, the longitude lines? Um, yeah. Anyway, so I get there, right? Like I
Yeah,
am
the
coming
blue
to
lines are the longitude.
yeah.
The
I'm coming to
other ones are
longitude of
latitude.
180, right, on the east side, right? And let's say I'm slightly above the equator. I think, if I believe I'm on a globe, that I am just about to end up like right on the other side of this map. That if I just go a little bit further to the east, I am going to be on the dead other side, like opposite side of the map immediately. But what you're saying has to happen here is that in following the magnetic field from being at 180-degree longitude line all the way to the east to end up um, on the equator at the west, I'm going to have to take one of these arcs now that's going to go around the entirety of Eurasia and North America in a loop that is like way out beyond all of the major continents, just to end up on
Yeah,
the
I just reposted, by the way, the one I sent you. So actually watch that. I know you just don't watch anything I send you, but watch that video and you'll explain a lot of what we're talking about. But yeah, he's showing the ships, and there's certain areas that you couldn't actually cross where they may make a flight route. Like I showed you with the flight route, the way they make the it look really like bunched up there, and it's actually the whole blue, like half the globe is just all water, right? But they make it look like you could just go straight from LA to Hawaii, like a little dip, when it's actually across the whole blue side of the half of the earth, basically, to get down to Australia from Los Angeles, and that's easily explainable with the route that goes right on the water, exact same way, and it would be west, southwest, exactly the same. It just goes up and around on a dual pole, and it's still had west southwest, just the way it would be with the globe interpretation. But it's the whole blue side of the ball, which is how they get away with it. The
Yeah, but
whole half the Earth is all water. You know,
yeah.
if you're out there on a ship or if you're out there, you can totally think you're on a globe. You're not going to like, oh, there's that island and there's that island. And wait, am I not on a globe? You're never going to even think that. Nobody would even question it unless
So
you're
no,
one of us trying to prove one thing or another.
but what I'm saying is that on the globe, the easternmost point of the equator and the westernmost point of the equator are the same point here. They're connected. So if I am on this flat Earth map and I am holding as close to the equator as possible, and I am heading to the easternmost point of the equator, according to the globe, I am miles, feet, like basically there already to be at now what the westernmost point of the equator is on this map.
Oh, you think of Pac-Man type stuff. No, it doesn't work that way. You still have to go all the way across the blue side of the ball.
No, but that's my point. Is that if it was a Pac-Man teleport from one side to the other, then that would be what I would expect from the globe. But if it
No,
isn't,
well, wait, hold on. I just said the whole half of the Earth is water. So you're thinking that if you went far enough west, you're not going to have to go across that whole side of the blue side of the ball before you would end up on the east side? You have to go across the whole ocean before you would end up on the other side for the globe, right?
no,
It's not
what
like
I'm
you just get
No.
far enough west
no,
and then all of a sudden you appear on the other side. So going across that whole side of the water, that whole blue side of the ball is represented on the outside, either the north or the south. So the trick is that you either have a north heading or a south heading, or you're just along the equator and you don't think about it that way. You just think you're going along the equator and going, wherever you need to go. But who the hell goes out in the middle of the ocean and worries about anything but their compass heading because you're in the middle of the ocean? And you would be in the middle of the blue side of the ball. And it's exactly the same point for point, no difference whatsoever in coordinates, no difference in distances whatsoever. It's just that split in where they hit it, and that international date line goes halfway, in quotes, down from the South Pole, and halfway up from the North Pole. And then when you look at the international date line and the way they have depicted, I mean, these images are crazy. But just the distances between the islands will tell you all you need to know.
yeah, but what I'm saying is that if I am basically on the equator, then what that means is happening on your map is that I have crossed half of what the official distance of the Pacific Ocean is, and then have to take a semicircular arc that will, at a huge distance, circumnavigate all of Asia, the Arctic, and North America before I even get to the western part of the equator on this map, and then cross the next half of the Pacific
You just
Ocean.
don't get it. No, the whole blue side of the ball is represented either north of north or south of south or down from south. So it's the same amount of water, it's the same amount of distances, and nothing different. It's
No,
point for
it's
point
not the
exactly
same
the same.
amount of distance. Like this is just
It is.
like it
It
isn't.
is.
We're
You just don't
like
see it. You don't want it to be that way, but if you actually consider what I'm saying, you will see that it is just exactly the same. There's no arguing that. Especially because it's latitude, longitude, the grid system, right? It's going to be point for point the same. It's not a transform of the globe, but it does use the same coordinates, right, for the globe. And it's same. If you're going from one latitude, longitude to another latitude, longitude, it's going to be the exact same distance by default.
no, these
And just look at you just think it's bigger because you're not used to the idea yet.
I posted something in chat. I tagged you both. I think it's going to explain zzpop's.
I've looked at all of this, bro. There's nothing new.
Oh,
You
I
can't show
posted
me anything new about the globe distances compared to. I'm the one that's actually talking about this more than E1 is, even though it's not my model. I've got the videos. I'll put the videos. I'll send them to you personally if you want to look at them. However you want. You just be like, yeah, it's stupid. So you're not really contributing.
Well, new perspective. What ZZ was saying.
I understand what you're saying.
I'll just say one thing.
Understand what he's saying.
I don't want to interrupt ZZ
Okay.
Pop. I just want to say one thing. If you look at what I posted, 180 east and 180 west on your dual pole map are basically touching on the globe, and that's what ZZ is saying.
Yeah.
Yeah, I know. And I even point this out myself. It's one of the first things I point out. I have a little graph that shows where the international date line would actually have to meet up for a globe. That's where, you could prove it one way or another. If you trusted somebody enough to say, go along all along the international date line and show us exactly your trip where you went all the way from pole to pole. But that's the circumpolar navigation. That's what they would have done a long time ago when they claimed to do these
And
circumpolar navigation routes with the planes. They just dip down into Antarctica. But that's the real circumpolar navigation they would have done a long time ago if they could have, and would have proved it's a globe, to whoever believes that. I mean, they could probably fake that pretty easily now, but you would have to go all along that international date line continuously from pole to pole and then down the prime meridian. Like, so it'd be pole to pole to pole to pole, right? That would be the true trick to show that it's actually a globe. Hasn't been done. I know why. I think I know why. I mean, they would have done it already if they could, and they can't because that's where they split it and they stitch the ball together. And that's, I mean, I don't care if you agree with me or not. I just think that's exactly what it is.
Well, then let me say this: the on the globe, every line of longitude is the exact same distance, and here they're not. The closer you get to the prime meridian, the shorter the lines of longitude are, and the further out you get from them, the more dramatically larger they are. Like if you were to go from North Pole to South Pole on the 180-degree line of longitude, that is many times longer on this map than going from North to South Pole on the 30 degree
No,
line
it's
of
still
longitude.
15 degrees. It's still separated by the same amount. The visual, we see the visual, the stars actually represented that way. They do the electromagnetic field thing where they straighten out when they meet, and then they converge and diverge on the sides. That's what the stars actually do visually. They get to be like more perfect circles in the uh, towards each pole. It's more perfect circles. That's how they actually manifest. And if you get the wings and Plath, Star Wheels, it's a go-to nautical company. They have those correction overlays that you use for each latitude you're at to do your celestial navigation, right? That's how you do it. And they have those corrective overlays based on the fact that you have to count everything starting from the prime meridian, and then you go around and then you figure out your spot for your fix on your star. But those overlays mimic the oblateness that they tell us the globe is, and they're correcting for that. That oblateness that you're talking about with it looking thinner and those things, it's not to scale, by the way, but that's the way the stars manifest, and that's the way the latitude longitude lines would actually look lined up with the actual stars. And
Honestly,
I know the globe makes it look like they're perfect squares, and they also claim straight lines but there's no straight lines on the globe, right? They can claim a lot of these things that are never actually the case, because if you're going around in a circle, you're going around in a circle. Whether you think it's a straight line circle on a globe, or whether you think it's a circling around the North Pole, it's still a circle.
I mean, the only way I can really make sense of anything you're saying is to take it that you don't actually think that the lengths of the lines of latitude and longitude, as presented visually here on this flat Earth map, are accurate to reality. That like I
No,
shouldn't
that's
take the lengths here
that
and
is
one to
reality.
one.
That's the reality, bro. That's the
So
reality. It's the same for the
okay,
globe too, though. The latitude longitude lines are not more separate or further apart. It's by degrees.
no,
It's not. Don't let the picture fool you. It's a mathematical thing. That's
no.
exactly the same.
I'm
no,
asking this. Take these white lines of latitude on your map. Does every millimeter of white line in the picture I am looking at on my screen correspond to the same amount of distance in miles on the actual Earth?
Hold on a sec. I get a message here.
Like just for anyone else who's listening,
What were you saying?
well, do you know how most maps have like a little legend thing in the bottom where it's like, okay, every inch on this map corresponds to 50 miles on the actual Earth? Like most maps have a distance translator that
Yeah,
tells
that's
you,
not.
and
It's not. It's not an accurate two-scale map. You realize that, right?
okay, so that's what I was saying. Is it that that's what I
It's
was
just.
saying? Is
It's
it
just show the concept, but it's exactly the same. It wouldn't be any different in distances. Latitude to latitude, one latitude longitude crossing is the exact same distance to another latitude longitude, unless you're crossing over that area where they stitched it and claiming that you went across the 0 degrees on the back side of the blue side of the ball. That'd be the only way to really debunk it, because otherwise it's mathematically the same.
No, it's
I
not
mean,
mathematically the same because it's not a one-to-one
Yeah,
in
it is.
terms of distance. It's topologically the same. Actually, no, that's not even true. It's not even topologically the same. I mean, it's a stereographic projection. So I get that there's a
No,
point by
it's
point
not a projection of the globe. It's not a projection. That's why I sent you all the summary of the AI summary of what E1 put together. He did not do it. He did not take the globe and then transform it to make
Whatever.
his map.
I
So it's
I
not a
get what
transform. So
you're
he didn't
saying.
start with a globe, which is why Ruhif's map and stuff makes it all look weird with where the islands end up and stuff.
No, no, I get what you're saying of it's one-to-one in terms of points. Like any point on the globe has a corresponding point on this map, but it's not the same distance lengths if I am to take the map in any way seriously, and I guess I'm not supposed to take it
What do you
seriously. I
mean?
guess I'm not.
What do you mean? It's a representation of the latitude and longitude lines. And the
well,
latitude and longitude lines are the same as the globe, except for the fact that on this map, the international date line doesn't connect to the other half of the international date line, and the other and the primary the celestial equator doesn't continue on around the ball. It continues either north or south, but exact same distances. There's no difference.
Well, they're not the same because on the globe are circles, and here they're not circles. You know, they're squashed oval shapes.
That's a whole other issue that I just explained. That's the way the stars actually manifest, like a electromagnetic field.
I'm
And
not talking
the
about
distances,
I'm
even though they look squashed,
talking about
they're still
distances.
representing the same distance that the globe represents them at.
new
It's
perspective,
15 degrees in between each.
you could
I
very
put the actual
easily
degrees on there. I took a lot of time to number each position, right? So you can actually look at the map, zoom in on it, and see that it's 15 degrees incrementally across each way and up and down, right? So just like the globe has it, 15 degrees in between every little point. Maybe it's visually not satisfying. I understand that because we're used to looking at a globe, but
Yeah, it's not
it's
amazing.
represented mathematically. It's exactly the
I one thing real quick, zzpop. New perspective, you could very easily prove your model if you'd like to. You could charter a boat with a captain and
I
go
don't need to.
sail.
Just
You
look at the
do.
distances between the islands as
And
if they are right
you
next
could
to each
take
other.
that and you could charter a boat for yourself, hire a boat captain and charter a boat and go out there and prove your map if you really were inclined to. But I guarantee you wouldn't
You could
prove your map
disprove it.
with the globe.
I don't need to prove it to anybody because it's
I just
already
want to
it is
know.
flat. We have a flat dual pole Earth. That's like a given for anybody
No.
paying attention, right?
So,
Anybody
new
paying attention,
perspective.
Robert, for the flat Earth conversation, you haven't been a part of very long. Neither of you, ZZ Top. But if you're really paying attention, at this point, you know that it's not a globe because there's no curvature, there's no movement, right? So
Of
it's a
course it's a
flat Earth,
globe.
and we have two poles, right?
Can I just
So
bring up?
it works this way. This is how it has to work.
So I just posted a map of a random map from the internet. It's a map of Los Angeles, and you see the thing that's in the lower left corner of this map. There's a bar there, and that bar represents 20 kilometers. So what that means is that if you take a little measuring tape and you line it up to that bar and you put it somewhere over this map, it is telling
I know
you
what that
the
means.
distance between those 2 points is 20
Yeah.
kilometers. One of the functions of a map typically is to tell you the distances between points. And so it's not just me
Well, the
being
latitude
like,
longitude does that for you.
no, but you've vastly stretched and squished what the latitude and longitude lines are here.
No, that's why the electromagnetic field in the stars actually manifests, so it's represented visually that way. But the distances are still the same. I just explained this. Look at the numbers on the
So,
map.
so
Just zoom into the
so then
actual map instead of saying, "Oh, it would have to be different because I'm a glober." Just look at the actual numbers on there. The numbers are the same.
No, but
Latitude,
longitude,
it's
latitude
15 degrees
are
increments, just like the globe has it. So it's no
no,
different.
those are not distances. Those are angles. I get that you have a bunch of lines that are labeled 30 degrees,
Still the
50
same.
degrees, 60 degrees.
Yeah, but
No,
those can translate into distances.
then do it. Then
15
put
degrees.
the
Well,
distance
yeah. Oh
measure
man.
on the
Oh,
map.
there's so much to be done. You're right. A 2-scale map would be great. You know, that would be awesome. Yeah. But this is a
It's
representation of
impossible.
how it works, and conceptually, would be try to get it conceptually first, and then worry about like, oh, this map looks squished. That's not a good critique at this point because it was made that way on purpose, and it's still the same distance.
So
The
on your
reason-
map, if I wanted to go from like Los Angeles
But
to
a totally a
Sydney,
scale.
what direction would what direction would I go if I want to go from Los Angeles to Sydney on your map?
Oh, I think I had you turned down. Sorry, I couldn't hear you, Jake, because I had you turned down.
That's okay. So what
Let's see.
direction would we depart if we're going to go Los Angeles to Sydney? Which way would we depart from Los Angeles?
I have some. You want Los Angeles to Australia? Something like
Sydney,
that?
yeah.
Sydney? Okay, I got that.
And according to your map, it would be twice as long a distance as Los Angeles to Perth.
No, no difference in distances. That's not an actual critique because it's the same.
We'll show
Well,
it.
you're saying that, but you
The
haven't
way it
shown
works, the way it works is
the same.
you have to wrap your head around it. I understand that. It's not like it's going to come naturally to anybody. It took me a while to get it too.
Well, where do you go? Show it.
I'm looking for my image here. Hold on.
I mean, if the defense of this is that, oh, it's a mapping of the latitude and longitude lines, but the distances aren't proportional on this map, then the question is, okay, well, where's the map where the distances are meant to be proportional to reality?
Oh, the globe representation doesn't even claim to be proportional, and that they're
Yeah.
always talking about the difference in continent size and how the globe it's distorted. None of them even try to claim that it's exactly to scale. None of them.
No,
No,
it
you
is.
can take any globe. You can take
You
any
just do it by
globe,
the
and
latitude
you can take
longitude line.
and you can take a string, and you can apply the scale to the string, and you can get a very accurate distance between any 2 points anywhere on that globe using that little string and applying the scale.
Okay.
It will also show
I'm
you
not trying to claim. I'm not trying to claim this
it'll
is
also
this is
show you your
a
flight route,
graphic
your
I made
shortest
from
flight
a
route.
hand-drawn map.
It'll also show
E1 does all his maps hand-drawn, right, to begin with. And then I'm making a graphic based on exactly what he drew, right? So it's not at all, it's not perfect. It's not supposed to be scaled. It's not like this is exactly what everything looks like perfectly. It's about the concept and the way that it has to look. And if you could make a very detailed, more accurate, very precise version of it, for sure. That should be done. I agree.
I'm still waiting for the LA to Sydney.
Yeah.
Coming up. I got a lot more than that coming up too.
Well, it only takes me 1 minute to show you on the globe. 1 second.
No, I have it stored in a folder and a bunch of stuff here.
Like the thing is, if you take a globe and you do the thing with the string, not only will it show you the accurate distance, it will also show you like what path you would fly, like what cardinal directions you would fly along your route, and it would show you what like if you're flying over land, what land you'd fly over. If you're flying over islands, what island you would fly over. If you have to get overflight permits, like when you're flying from South Africa to Asia, right? You have to get a bunch of overflight permits for every country that you fly over. It'll tell you exactly which country you're going to be flying over.
Yeah, and it's the exact same path that the globe. The globe, it's actually represented pretty much. There's your image in the chat. It
So you
works
fly
just
north?
the same way because
You fly north?
you go west, southwest, right? You have to understand if you zoom in on that map, if you're going clockwise around the North Pole, that's west, the same way the globe represents it. There's true west, right?
No, you're going
True
north.
east, true north, and true south. But if you're going around it clockwise, it's west in the north. If you're going around it
You're going
clockwise,
north.
it's east in the south. And that's the way the globe does it, right? This is what they started with, and then they made the globe from this, guys. So this is why the directions work this way.
It shows you going north from LA.
Yeah, I mean,
No, it's not north. That's not just explained. That's west because it goes around the North Pole. That's how the globe depicts it too. Whether you think you're on a ball or not, it's the same direction.
No.
Yeah, I know it looks
No.
like it's north because it's up. We're used to thinking of up from
now-
north as it's
says
just the
NW.
it's just the blue side of the ball. It's that whole blue
now
side of the
show me the
ball
path.
that you would think that you're going across, but it's not. It's just the water on the outside of where all the continents are, and then the Earth is stationary and level. Duh.
No.
Because you haven't figured that
That's
out
not
by now. It's going to make it a lot harder for you this. I understand
That's
that.
not what it looks like when you fly there. It doesn't go around like that.
Yeah, so what you're
I
saying
know
is
you
you
don't
would
think it
first
does,
take
but
off.
that's the way. It's the same thing as
Because-
going across the blue side of the ball, dude.
So you take off because you were looking at your cardinal direction that you have labeled on your map. So you would take off flying northeast from Los Angeles. You take off flying northeast, and
No,
for
it's not
some
east.
reason,
You're thinking of the map as the right side of the map is east and the left side of the map is west.
It
That's
says
not it.
northeast.
No,
It's your
Yeah.
map.
no, it's going west, right? If you're going around the top of the North Pole, you're actually headed west.
Well, your map says northeast.
That is how.
Northeast.
yeah, your arrow is pointing to the label that you have as northeast. That first arrow from Los Angeles, it says northeast, and it's pointed towards northeast.
I mean, and also the
What do
first
you mean
arrow.
northeast? That doesn't. I didn't have northeast on there.
Okay,
What are you talking about?
So let me ask you
Wait,
Says
wait.
it in the
What does
top
that
corner.
claim? I don't
on the
have. I
corner
don't
of
have
the
it
map.
mislabeled. I don't have northeast labeled on there. What
Yes,
are you
you
talking
do.
about?
It's in the top corner. NE.
No, that says that doesn't say northeast. Can you
It says
see?
NE. NE. It says it right there.
Oh, okay, yeah. The corners of the four corners. Okay, yeah, that's what I'm saying. There's nuances to the way this works, and that's the way the globe represents it too. Because every time you do any with a globe, right, they'd use the same four corners that you're seeing right here. That's how the globe depicts it always anyway. But then there's a nuance if you're going around the poles on a globe where you're actually going west or east, depending on the clockwise or counterclockwise direction. That's exactly the same way the globe represents it.
Wait,
I understand it's hard to wrap your mind around because it's not like no matter what, if you're going right of the map, you're going to be going east because there's a true east and a true west, and then there's a clockwise east and a clockwise west.
That's fine. That's fine. We
And a
can label
counterclockwise
it whatever
That's
we
the way the
want.
globe. That's the way the globe works,
Yeah,
even though
it's
you don't realize it.
Listen,
Doesn't.
we can label. I'm not concerned with what we label it, though. That was very funny. But here's the physical fact that matters. This flight from LA to Sydney initially is going towards Alaska. Like if a plane takes off in LA one goes to Sydney and one goes to Alaska, like they're headed kind of in the same direction here at first, rather than
And it's the
being
same on the globe,
immediate.
actually.
No, not
You
at
just
all.
don't. You
They're
don't think about it
immediately
that
headed
way.
in opposite
You don't think about it that way. You have to go along where Alaska is, right? You're going about that different.
No.
The path
No,
is pretty much the
definitely.
same.
I just
It
posted
is
what it is
not.
on the globe. Like a plane
zzpop posted the link.
a plane that's leaving LA to go to Alaska and one that's leaving LA to go to Australia are immediately diverging from each other instantaneously on a globe. But here they're following each other for at least the
Yeah,
first
I
part
already
of the
told you about
journey.
this. Remember, this is a 2D version, right? Now I'll take the same. I'll take that 2D version. I'll save it, and I'll put it next to the 3D version. That's why I sent you the link, so you can click on the 3D version and see how they represent it on a globe. So that's not a globe. That's just a 2D representation that makes it look like you're going down in that direction and so easily, so close. But on a globe, it's much different. Hold on. Let me just show you.
So I'm curious
They're
also.
on the water anyway.
So that first arrow that's pointing up and to the right, that's west. What about the last arrow that's kind of that's pointed kind of down and to the left? Is that also west?
Hold on, I'm getting this website up.
I don't know. It looks like it's east. I don't know. It's the most strangest thing I've ever seen.
I'm just curious
Doesn't
why
make
anybody
sense.
why would a navigator imagine we're back in World War II days. We don't have any electronic aids. It's all paper maps. Like, why would a navigator choose to use? I mean, this is the flat Earth, right? So navigating on a flat Earth is a hell of a lot simpler than a globe, right? Because on a globe, we got to worry about ampersand, we got to worry about great circles. But on a flat map, it's like super easy for a navigator, right? He just takes out his compass, he sets it to the width, applies his scale, and he can figure out, how far everything is from wherever he is, right? So why would anybody use a map like that? Like if we go back to World War II, they got to do bombing runs from, I don't know, from America to Germany or something. Like, why would anybody use this map where it's completely illogical what route you would fly, right? It's not the shortest distance between 2 points. It's like, oh no, you got to go all the way around this way. Where first the arrow is going from the bottom to the top right, and then from the bottom to the left, and that's actually the same cardinal direction the whole time. Like why would anybody use that map?
I mean, even if you say that you're following the compass needle then is having you do this gigantic arc that circumnavigates most of the continents of the Earth.
No, it's just the way it actually works because we live on a two-pole flat Earth, and the way they represented the globe, we all think, oh, it wouldn't work because we're on a globe. But actually, here's the two flight paths on a globe for LA to Sydney. And you can see the globe represents it totally different. It's the same path that you would take essentially, except that it's a flat map, and that water you're going across is actually just water over the flat Earth, like we know it is, and it's not around a ball. The ball is the illusion, guys. That's the concept
But
that makes it hard to see. But you see how that flight has to go all the way across half of the Earth. Half
Yeah, but it
of
doesn't go.
the
It
Earth
doesn't go towards
is
Alaska though.
water.
It goes the
Yeah,
opposite direction of Alaska.
The Earth is all water.
But it doesn't go towards
right?
Alaska.
yeah. Yours goes
It
towards
doesn't show
Alaska
it
and
going
then
as close to
around
Alaska as
Russia.
the path I showed. I agree, but it goes in coordinates with. In fact, it might go. This might be further down than it should be, but maybe the flight path that they take goes farther out from Alaska. I was just drawing those arrows as the direction it would have to go to match going across half of the Earth. That's all water.
Was that Sydney to where?
That way, because you see the 3D representation is totally different than that 2D one you put in there, ZZ.
Well, the point being was what other lands are you going towards? And if you make your arc even bigger so that you're not kind of going up towards Alaska at all, then now instead of crossing a distance that's half the distance of the Earth, you're taking like a semicircle that is way larger than any distance of the part of the Earth where all the people live and all the continents live. I mean,
You know what?
I'm looking at the arc that you've drawn here, and I'm thinking about if I straighten that out, that line, that arc of the white arrows, if straightened out, is now way longer than the straight line distance.
You know that flight
It wouldn't
Sydney
be.
to
It wouldn't. I know you can visually trick yourself, or if you don't want to think it's true, it's easy to say, "Oh, it would be way longer," but it wouldn't be. It's exactly the same. It's the same
you know
point for
that
point
flight
coordinates.
I mean, look,
So
it's just the flat Earth is supposed to be obviously empirically flat, right? And so, why do we have this super complicated map that you have? Why don't we just have a simple map where we just set our compass and apply a scale to it and know every distance between every point, and also just be able to draw a line between 2 points, and that's going to be our shortest flight route.
it's not. It's not a flat Earth attempt. It's not like E1's like, "Oh, I'm just trying to make it work." No, he just used the nautical almanac, right? Used EPs for the stars and plotted it out that way, and then corrected the prime meridian back to where it was, so everything would work out with the amount of distances, the amount of sunlight, direct sunlight for each continent, which wouldn't have worked with the regular dual pole transform. And that's why a lot of people with the dual pole idea give up, because they think that it doesn't work, because they move the prime meridian 33 degrees to Greenwich back in the day, and that's not a made up thing. That's what they actually did, and it throws everything off, especially if you're trying to make a new map. So this is just what it works out to be, and in fact, it's what they use practically for everything. They don't give you a globe. They don't look at a globe when they're plotting things out and be like, okay, here's the globe. It's just the concept that they give to us normies, so we think that it's a globe. But in practicality, they use the northwest, northeast, southwest. They use the four corners and everything. Like if you're in America, you're in the northwest coordinates. On a globe, it's kind of arbitrary, but you're actually in that corner if you're in America. That's why it is that way. There's the actual west and actual east. That's why they call it the east and the west. It's not just like, let's pick a line and call this part west. If you're on a globe, it would be completely arbitrary, but it's not.
Yeah.
Have you ever been to the Pacific, New Perspective, either South or North Pacific, or the on the other side of the date line, closer to Australia?
Hold on a sec. I'm getting an image here to show you what I was just talking about.
I told him he could charter his own boat.
Look, we gotta cut
I
new
don't-
perspective some
There's
slack
people
here,
that
though.
are
He's one of the
people that would do. I don't think it's. I already know it's a dual pole flat Earth, so I wouldn't go to that effort. But if somebody wants to prove it wrong or right, they're welcome to.
Oh, it's
We
been
gotta
proved.
give-
You just
You wouldn't accept it.
we gotta give new perspective
care.
some
It doesn't
slack
matter
here,
what
though.
I accept or what you accept. Why would that even matter? It either is what it is or it isn't. It doesn't matter what people believe.
You don't know anything because you've never experienced it.
And that's okay if you believe that.
No, that's your
I don't
line.
care. It
No,
makes no difference. I'm not lying, that's for sure.
No,
But
that's
it
your
makes no
line.
difference
That's what
whether you
say.
get what I'm talking about or not. That makes no
No,
difference
but
at all
that's
to me.
what you say. You say, how do you know if you've never done it? That's what you guys say.
But you don't put you guys on me. That's for sure.
New perspective. I do want to give you credit for how far you're taking this. In
Well, it's E1's concept. I'll give him the credit.
all right, well, whatever that. Yeah, then you know, a lot of people don't try to explore how anything would work on any map whatsoever.
Yeah, he just said I'm going to go with the raw data, all the raw data I can get. Forget the globe, forget the flat Earth map, forget the globe concept, and just go from there and build from scratch. And this is
I've
what he
seen
came
what
up
he's
with.
done. He's cracked open like this dual pole thing. You've split open the globe like a clamshell, and that's what you're trying to do with it. It's so silly.
Well, the thing is if it is an electromagnetic field that the stars are meant, and then everything circuits around instead of orbiting, which we have all these kind of problems with anyway. With orbits don't work anyway with a 3-body problem, no matter what you say. Sorry, it just doesn't work, right? So we
I'd
have
like
to
to
have
hear
things
more about
circuiting.
that.
The only way things can have their path on their own is to circuit around an electromagnetic field. And if it's an electromagnetic field, exactly the way the stars manifest, visually exactly the same as an electromagnetic field, then that's what we started with. And they realized, wow, this kind of looks like a ball. Then they made the globe from that. So you see it the other
That's
way
not
around.
true.
And I know it's hard to think that this dual pole wasn't what we started with. But I understand that. But that seems to be the case, guys.
You know that electromagnetic field uses the same equation as the equation for gravity, which also has a 3-body problem. So if gravity doesn't work,
Yeah,
then
but there's
yeah,
no
the
orbiting.
fields don't work either.
No, but the difference there is it doesn't depend on the mass of any other body. These planets and stars, they're circuiting, right? The planets and the sun and the moon, they have their own circuit. They're not orbiting around each other. So there's no 3-body
mean by
problem involved
What
in
do you
this.
mean? Electrostatic
It's a circuit,
orbiting.
not an orbit. So therefore, no
Electrostatic
3-body
orbiting
problem.
has been demonstrated. Electromagnetic orbiting has
Right,
been
but it's not
demonstrated.
orbiting in this model. There's no orbiting in this model. It's
What do you
just
mean
a
by
circuit of
circuit?
its own. It's
What's the-
individual circuits. So there's
do
no
you mean-
depending on
It's
another
not
body.
anything.
Wait, do you mean wires? What do you mean by circuit?
It's running the field, right? It has its own, and this is all debatable and speculative, of course. But E1 thinks there's an actual mass to the sun and the moon. They're made of different materials, which causes a different periodicity, and that they charge up in the south and go to the north. I mean, it's a it's a machine. Whether it came about naturally or not, he doesn't try to say God made it or anything, but it's an amazing clockwork machine, which we all agree on. The stars work like clockwork. Whether you think you're spinning or the stars are spinning, it's perfect. And it's predictable. And you guys think it's because the globe predicts things, but it's just because the things have their circuit, right? Their patterns that they keep they keep repeating, and they have variations, but they keep coming back to the same spot. And that only works if we're on a stationary Earth, guys. If we were flying through space with all that randomness, do you think we'd have the perfect clockwork above us? No, it wouldn't really work that way.
I don't know. I mean, it's just the Earth's rotation. I don't know what you mean by perfect clockwork, but
But you don't think there's predictability?
Well, I just mean like the Earth rotating, us seeing the stars as rotating because we're rotating. Like, is that the clockwork that you're?
Yeah, but think about the distances and you think about it. You're supposed to be traveling along the sun that's flying through the galaxy,
at 500,000 miles an hour, that'd be 12 million miles of displacement every single day. Add that to a year, and then
Yeah.
we talk about years and years and years and years, and you're like, oh, it's because the stars are so far away, you could never
Yeah, we could do
tell.
the math.
It's so
We could do
stupid.
the math and
You think that
calculate it.
because the stars are infinitely, in quotes, far away, we don't see
We
any
could do the
parallax? No, we know how far away it's because of the parallax. Because of the smidgen of parallax, that's how we know how far away it is. It's
do the
actually
math
the
and
parallax
calculate
you would see, the distances between these stars that are supposed to be suns of other galaxies would vary greatly, not only from our movement, but from their movement from each other. But you get
We
away
could-
with that by saying it's infinitely far away, and they're definitely doing all that, but it's so minuscule by the time
We
that
could do
you'd ever be able to add it up, it just looks perfect year after year. And the
I'm-
constellations stay perfect, and all the stars stay the perfect
God.
distance from each other, even though they're suns from other galaxies, and we're supposed to be going through the galaxy. It's so stupid,
I'm-
you guys. Think about it.
I'm
There would be
sorry.
so many variations you would notice after 1 minute, let alone 1 day or 1 year.
Oh my
You
God.
wouldn't
We could
have
do
these.
the math.
The Big Dipper would not look the same
Take a
every
breath.
single day,
Take a breath.
every year. It never changes. Do you know why the Big Dipper doesn't change? Because
Take a
we're not
breath.
spinning.
It has
We're
changed.
stationary. It's going
It has
around us,
changed.
and they're
Excuse
fixed
has
to each
changed.
other's position. There's nothing
Excuse
random
me.
about it. It's like perfect clockwork. And
perspective.
if you don't get that, that's fine. But
New
I mean, I
perspective.
didn't get it either for a long time.
New perspective. First of all, it has changed. We could do the math and calculate it. But
Yeah,
I'm
yeah,
sorry.
yeah.
Excuse me. I'm sorry if the astronomical changes don't apply to your lifetime. Excuse me.
That was such a good rebuttal.
Well, just because it doesn't apply to your lifespan doesn't mean it's not true.
I'm not saying it's not true. I'm saying it's stupid, dude.
And we
Think
can
about
do
it.
the math
You're
and calculate
displaced
it.
in space and time by 12 million miles a day, and you
So
see
what?
no change in the way the stars manifest. Come on, think about it.
Well, they're moving in the same direction around us. I mean,
Oh yeah,
Jesus
yeah,
Christ.
I'm sure, right? But they're supposed to be different suns with their own little galaxies and other trillions of light years away, and the light wouldn't even reach us. You have to believe that there's actually areas where there's no thing, right? Nothing can't exist. You have to claim that there's like a dispersion, and that's why the light can travel so far away and get to us, because they go through vast amounts of nothingness, essentially.
well, that's not my
Which is
position at
also
all.
stupid. It's just make believe. It's all
Well,
it's totally conceptual
Bonkers.
at best.
Well, that's not
It's
that's not what
bonkers,
I think
baby.
about space time at all. But anyway, regarding the galaxy, the model of the galaxy is it's a disk of gas, and the stars form out of that gas. So, like stars that are relatively near each other within the galaxy are moving at approximately the same speed in the same direction. It's like a hurricane. Like adjacent areas in the whirlpool are all moving in tandem together. Like they're not just all moving in chaotic, random, high speed directions opposite to each other. Like they're all of our neighboring stars are more or less moving at the same speed as us in the same direction. There's
What a
slight
coincidence.
variations. It's not a coincidence because it's how it formed. It formed out of like a whirlpool of gas.
So you don't get the point that I'm saying. You know that you have to have the stars infinitely far away to make the claims that there's no difference in the way that the constellations manifest. That is the globe. Whether it's true or not, that's what the globe has to say. That's what the globe says.
Is there a problem? Is there a problem with the stars being a long way away? Is that a problem?
Yeah,
If so,
there's a
why?
big problem. There's lots of problems.
Why?
Not for you, for who just wants to believe it. There's no problem. You can
Why is it a
believe it if you
problem?
want.
There is
Dude, I just said it all. You weren't listening?
No. What's the problem with that stuff being far away?
I didn't say there was a problem. I'm saying it's ridiculous and stupid.
Then it's a
That's a
problem.
problem.
Well,
I
that's
think
not for
you're
you.
stupid.
You like it. If you like it, you have
What do
no
you mean,
problem.
like
I don't
it?
have a problem with you not having a problem.
So
I just think it's ridiculous because you would have
Why
all
is it
kinds of shifting.
ridiculous?
You would
Well,
have
it's
all
ridiculous.
kinds of
I'm sorry
shifting
you feel
going on.
that
Is
way.
my point. If
Oh.
we're going
I'm-
along the sun that's booking through the galaxy at 500,000
That's-
miles an hour, right? Then
Why
there's
do
no
you say
change in
speed?
there's no change in the
Relative
way
to
that the
what?
stars are in position to each other. They're
Relative to
perfect.
what?
That's perfect. Maybe not in my lifetime and all those excuses. I was a Glober.
Not an
I was a
excuse.
true believer. I was a
Oh
Stephen
gosh, you're
Hawking
preaching.
fan, man. I loved
Dude,
Stephen
you
Hawking.
were a sinner.
I
You
loved
were a
all the
sinner.
theoretical physics. I loved it
You
all,
were a
right?
sinner like the rest of us before you found God.
I was, but before I
What's
realized how
Jesus
relative
is
stupid it
to
is.
what is
gospel.
Yeah, that's
moving,
true.
Steve?
The flat Earth
Uh,
gospel.
The sun's
I
moving.
do.
What'd you say? How fast? Relative to what?
I was gonna say I really like the idea of what I'm envisioning now of a plane leaving LA and it goes down to the Pacific and then it's just like swept into this electromagnetic like hurricane that whips it around, this gigantic arcing distance. So it's not the wiser. It doesn't realize how far it's gone because it just like hit the boost area of this electromagnetic cyclone. That's what I'm picturing in my mind here.
Like
And he could take that flight. Why don't you fly to LA to Sydney and see if it
I don't need
travels that
to. I
fast?
already know it's a dual pole flat Earth. I don't need to do anything.
Take the
I already
flight. You'll
showed
see
you
if
the
it
map.
happens
If
or
you want to prove it wrong, you're welcome
how
to,
do you
but
know
I don't
that?
need to. There's no need for me to do anything.
Yeah, there is.
I'm
Well,
just
You can see
offering.
if you're
I
right
don't
or
care. I
wrong.
don't care who.
No, I
E1
agree
doesn't
with him.
care who agrees with him. That's why it hasn't been pushed in any way. It's just here's what he figured out. It actually works, and it makes way more sense. Whether you think
No,
it's
it
true or
doesn't.
not, you want to go prove it,
It
right or
doesn't make
wrong.
any
That's all up
sense.
to you. I don't care to.
Oh, the
It's
respective.
obvious that that's what it is.
You're not going to like this, but the way to make the dual pole map work is extremely warped space time to compensate for
Um,
these,
There's
otherwise
no
incredibly.
compensation. That's the way the stars manifest. It's exactly the way that the stars appear. There's no compensation needed. It's actually the way that the continents are too. So
well, you're not
no
gonna map it,
compensation.
so I guess we'll never know.
If you think you're on a ball, you think there has to be compensation.
But okay, so you got the whole heliocentric model, right? And so, okay, this idea with these parallaxing, it implies actually that if you just to think about what's up, the stars are on a layer all of their own, a completely discrete layer separate to the stars. Maybe the planets are all on their own one as well, or maybe you could say all the planets are on like a
Called the
particular
ecliptic.
layer. And then that would start making more sense as opposed to this idea of, I mean, if you've ever seen those galactic models, right, where they say this is all the galaxies or this is what the Milky Way looks like, and then you're trying to like basically state that there should be no parallax within that model because you're dealing with infinite distances constantly. That's where it starts getting a little bit difficult to try to imagine what's going on. That makes sense to you, Globes?
Well, there is drift of the constellations. It's just slight. And by the way, it's not a coincidence that us and all of the neighboring stars that you can see with the naked eye are moving at, in astronomical terms, the same velocity in the same direction, down to a rounding error, because that's how they formed. Like that's the whole
That's
the
how
model
you were
is
told.
coherent.
That's what you were
It,
told. How you were told. That's not exactly. It's not a fact. It's just what we were told.
It is a fact.
Well, I'm just
There's
saying
no
that the
proving that.
model. Well, I mean, you could say it's not a fact, but I'm pointing out that the model is like internally coherent. Like there is an
No, it's
internally
not.
coherent explanation for
It's
this.
a
Yeah.
stretch. It's a stretch in all kinds of ways. Come on.
I
No,
bet you've never
because
even seen the Milky Way galaxy with your naked eye. New perspective.
the model of galaxy formation is that a gas cloud collapses and spins due to its angular momentum, and then within bands of dense gas, stars form. So stars don't form randomly in isolation with random velocities and random directions. They form in large populations within gas streams that are all like moving in the same direction in the vortex of the galaxy. So, say what you want about saying that this isn't true or whatnot. My only point is that this is the a perfectly like coherent internal explanation for why the nighttime stars are not all whizzing around in random directions relative to us.
Are those filaments that are connecting those strings that you're referring to, are they considered to be electrically charged values?
The filaments are between galaxy clusters. I was saying these are um, like streamers of gas inside a galaxy. But yeah, I mean, things are electrically charged. Yes, the filaments are.
It's just that like gravity is given so much of the credit for the the formation of what the cosmos or of the material world, and very little of attention seems to be paid to electrical or the electrical potential and charge and its contribution
I
to it,
wonder why.
which always seems a little bit obscure to me.
I wonder
Yeah, look,
why.
there's people who speak about this. You know, there's like the field of cosmology, the formation of the structure of the universe, the galaxy clusters and filaments. I think is really fairly up for debate. And I wouldn't be surprised if there was a major overhaul of the paradigm within our lifetime.
Yeah, but who was that? Who was wondering why? He's going to be wondering why there's going to be a need for an overhaul.
I mean, this stuff is complicated, and it's like, yeah, people primarily considered gravitational effects, but the plasma that exists within the filaments is electrically charged, and the magnetic dynamics on those scales are not really that well understood. And there's arguments as to why that they might be insignificant to the formation of the filaments, and maybe those fall apart, and it turns out, oh, we need to completely revise the entire timeline and evolution history of how we think the filaments formed, because we were just totally blind to some important physical process that actually we're now realizing plays a major role. Like, yeah, that definitely could happen.
None of this has anything to do with the shape of the Earth.
Right. Or these amazing flight paths that we're looking at here on the dual pole model.
But electrical universe and that sort of paradigm is far more amenable to something considered to be the flat Earth, and then your gravity is not then absolutely attributed to mass attracting mass. It's an electrical phenomenon, which someone mentioned before. That isn't it so curious that the formulas happen to be very sort of similar, if not exactly the same.
I mean, it's all with taking place within our universe. It's like there are deeper principles at play here. There are deeper governing principles behind the existence of all forces. So, like, in that sense, no, it's not a surprise. I do think it's probably pointing the way towards a better, deeper, unified understanding of things. But if you, let's say, rework gravity, like totally rework our modern understanding of gravity into some sort of new conception of what the fundamental force is that drives things within the universe, I don't see why that lands you flat. Like, why does this, electric universe not produce spheres as well? We need to see what happens in it.
Like, because you don't need orbits, which was a discussion just before. Sorry, go ahead.
Well, risky. I mean, it's like you go down this rabbit hole. I mean, the bottom line is, I'll say it, but you guys don't believe it. We've been to space. We're orbiting the Earth. We see the Earth. We know it's a sphere. There's no ambiguity. I mean, whether you guys want to believe it or not, I'm sorry.
I mean, if you'd been to space and you could make your own personal testament on that, I'd find it far more kind of compelling. But at the moment, you're just deferring to a bunch of people and a government institution, which I consider to be like the source of all major lies in the world. So,
there's more government
I mean,
institutions
you've got to wonder.
Yeah,
what's that?
It's not just NASA.
Define we.
There's not just NASA. There's the Indians. There's the Chinese.
Define we. How did you get in that barrel of people?
Rigor, humankind, Rigor.
All these countries are all being run by democracy in a similar institution, which is all basically born out of the greatest the British Empire, Russia.
Does that include North Korea too? Does that include North Korea?
Does that include China?
Yeah. I didn't realize China was part of
That's what I said. China.
I'm going to say we don't agree.
China signed on to our economic policy when they gave up on communism and they came over to capitalism. Hong Kong has been in control for a very long time now.
Hong Kong's in control. Right.
And
for
risky. Sure. There's people that have shot private rockets up into space and have video of it.
True.
You could shoot your own rocket.
Shot it up into space and sent it into orbit, or did it come back down?
No, they shot it up, and then they have a camera. You can see the curvature of the Earth, and then it came back down.
Are they the same ones where you can see the curvature of the Earth from about 5 meters above the ground? Those same ones with the those cameras?
No, you can look at the horizon in the first few seconds of launch, and then you can see it at apogee, and you can compare the horizon through the same exact lens.
I need to get a comment in about orbits, though. Electric forces also produce orbits, just like gravity.
Yeah, I posted that video from the ISS where they electrostatically orbit that droplet or over that piece of plastic.
Like
it works for short distances, and but it doesn't work for like big things.
They love to complain about the three-body problem, but that same three-body problem is there with the electrostatic orbits as well, and they all agree that electrostatic is real.
On the dual pole, it's just a circuit. They're not dependent on each other's mass. I just told you this. There's no three-body problem. If it's an electromagnetic field that they're circuiting within, then there's no three-body problem.
So I just want to point out that
three-body problem is mostly incredulity on flat earthers' parts.
On your part, I agree 100%. To reject
spectrum.
mainstream and claim mainstream doesn't acknowledge the three-body problem because you don't like it.
Mainstream acknowledges
that is definitely incredulous.
The mainstream acknowledges the three-body problem.
The mainstream identified the problem.
When you talk about satellites around the Earth, the three-body problem doesn't apply. Sorry.
The mainstream identified it, acknowledged it, addressed it, and then found greatness from it and expanded upon the idea that it cannot be solved.
Yeah, except that you can ignore it for things like satellites around the Earth because
wait.
No, we're talking about reality. We're not talking about satellites. We're talking about the nature of. We're talking about the nature of reality. We're not talking about satellites.
Nature reality is that you don't have to worry about Jupiter when you have a satellite going around Earth. You don't have to worry about the gravitational pull of Jupiter on the satellite because it's insignificant.
Okay, we're not talking. I know you're hung up on a satellite.
NASA.
We're talking about what is going on with the bodies.
All that the three-body problem is that you cannot simplify it into a symbol, into a symbol.
Yeah,
well, that's incredulous as well.
Even if that, you can ignore basically. For a satellite going around the Earth, you can ignore Jupiter. You can ignore the pull of the moon because it's.
Yeah, you keep talking about satellites, dude. You're missing the point. You're talking about a complete non sequitur. We're talking about the planetary bodies, and you're like, but look at the satellite.
Yeah, for planetary bodies.
Planetary bodies.
Yeah, for planetary bodies, you can pretty much ignore everything except the sun. That's okay.
Yeah. Well, then guess what? Guess what? You're ignoring the sun.
No, the sun's got like what 90% of the mass of the sun.
We're trying to figure out what is going on in reality, and you're like, well, this is wrong, but it's definitely realistic.
Relative.
I'm saying no, it's provably wrong. We know this is not accurate, and you're like, no, it is accurate. Like, just admit it, guys.
Oh, I'm sorry.
Like, how hard is that?
The sun contains 99.
No, it's not about how far off. It's either right or it's wrong. Does this depict reality?
Well, NASA, you know better than this.
I have a question for you. When you took a test and you got...
Why are you getting mad, dude? Why can't you be honest?
Listen to me again. If you took a test and you got 99 of them right and one wrong, would you say that your whole test is invalid now because you only got 99 right?
Complete straw man. I would say I did not get that whole test completely right.
Did you pass though? Was it good enough?
Depends on what passing means, dude. This is all non sequitur nonsense, red herring. Your misunderstanding of the combo.
Yeah, no, you have to throw it out because it's such a great, it's an analogy, and you hate analogies to show that how stupid your idea is.
It's not analogous, is my point,
guy. It is totally analogous.
We're talking celestial bodies. We're saying what is actually going on. What can we make a truth claim about nature and the universe?
Yeah, I said something wrong.
This is absolutely true. And you're like, well,
do you think it's
close enough?
Do you think?
I'll say I said something wrong. The sun is 99.86% of the total mass in the entire solar system. So
I don't know if he gets why that matters, but yeah,
because
three-body
basically, when you're talking about planets orbiting the sun, you can basically ignore the rest of the masses in the solar system.
Yeah. Ignore that we said this is real and it's not real.
Yeah, again, we only get 99%.
But just keep pretending this is real.
It's like it's 99. You get you're at 1% off, like you did again. You got
No, I don't care. I'm looking for the truth, and you're like, well, I got kind of a close idea of what's the truth.
Oh, see, that's the thing.
But I'm definitely definitely wrong, but I'm going to
That's
keep
why-
pretending it's
That's
the
why you're a
truth.
pseudoscientist. That's why you're a pseudoscientist, because
No, that's what
science
you're
does-
doing. You're saying this is
science does
true when
not
it's
demand
not.
perfection. Science does not demand perfection. Sorry.
These are all straw
Rigor, do
mans
you
on my
also
position.
not believe? Do
Science
you also
does not demand perfection. Sorry.
I'm
Rigor,
not
do you
demanding perfection from
Yes, you
science.
are.
I'm saying I want to know the truth of reality.
And we got something that's
And
like
you
pretty
say
damn
this
close.
is the
in
truth. I say
99.86%.
no, that's actually wrong. And you're like, no, it's
pretty
not
fucking
wrong.
close.
It's like, no, it's
pretty fucking
definitely
close.
wrong.
It's 99%, like you getting one question wrong out of 100.
Well,
and saying
guess
you
what? It's
passed.
not. It's not 100% true.
It doesn't have to be 100%
It's
true. We
definitely
don't
not
demand
true.
perfection. We don't
For
demand perfection from
utility,
science.
maybe not.
We
But
don't
when
demand
we're talking
perfection
about
from
what
science.
is the nature of reality, yeah, it has to be.
We do
Otherwise,
not
it's not
demand perfection
reality.
from science. Only pseudoscientists demand perfection from science.
It's like a concept. You're stuck in a concept and you put the
I'm
concept
stuck in a
before
concept.
reality. I put reality before the concept and you
No, you
spiral.
put perfection ahead of
Can I make an
reality.
observation, please? Mr. New Perspective just came up with a concept, and we asked him if he's going to map it by sailing it, and he said, nope, I'm not going to do that. So all he has is a concept. And
Yeah,
that's,
just like the globe.
that's the main
Just like
competitor
the
to
globe,
the
it's
AE
just a
map,
concept,
is the
right?
dual pole.
Yeah,
All maps are conceptual. All
he's
maps
not
are conceptual.
he's not imposing it upon anyone else. Red Cloud.
I also
Well,
want
he
to
shouted
point
to
out.
us for half an hour about it.
I also
Well,
want
no,
to point
Well,
out.
you guys
it's the
challenged
way
him
I
on it,
think it
right?
is.
Well,
It's the way I
yeah.
think it is. It works out perfectly, in fact. And it's way better because it's stationary and level like we know it is. If you pay
See, that's-
attention and not be in denial like you
Yeah.
are.
What are the circuits made of? I mean, that's such a audacious claim that the stars are not even moving on some type of force, but are moving in a circuit.
Electromagnetic force. That gives it a mechanism.
No.
Perfect.
No. But if you have loose electromagnetic forces, that's not a circuit. A circuit is a manufactured thing that corrals charged things down a wire.
Well, that's the way we see it, yeah. But circuit.
That's a concept.
A lightning strike is not a
We should
circuit.
make a circuit like a man-made version of it. Yeah, that's why it would have to, like, it's circuiting between you based on all kinds of things that we can't prove or disprove. You can speculate about it, but if it's an electromagnetic field, then it's totally possible that it could be going. So in fact, that's what they use for the satellite. Did you ever watch the satellite one that I sent you? That E1 showing his satellites and how they deploy the satellites either in the north or the south, and that's the same pattern they make for the ISS and everything. They're running this pattern. It's part of the electromagnetic field, the way it manifests.
What sort of electromagnetic field would it take to have the
Is my audio shit, by the way, right now?
Yeah, it's a bit off.
It's pretty bad, bro.
The electromagnetic force
Definitely
has
sucks.
the
It was good
exact
before.
same three-body problem as gravity. Exact same three-body problem as gravity.
Oh, now there's a three-body problem.
You didn't. In
You didn't
response
say
to
there
that,
wasn't a three-body problem.
I said if it's
NASA was
I
saying that.
think most people know what
okay.
the three-body problem is. The three-body problem
No.
is the statement.
I know
it's not
exactly what
orbiting.
it
There's
is.
no
Don't
orbit.
pull that shit.
There's no
I'll just
orbit.
pull the same
They're
shit. I
circuiting
don't think you
independent
really
of each other.
understand what the three-body problem is. What kind of opening is that, dude?
I didn't say you. I said I think a lot of people don't. You volunteered.
Yeah,
to
but
think I
there's
would
no
say
orbit. It's because the
Well, you're
three-body
addressing the
problem.
room
The three-body problem is
in a
based on the fact that they're
patronizing way.
dependent on each other's masses, right? The circuits are independent of each other. That's why it doesn't have the same problem. I just explained this to Jake 3 times.
So the circuit is not a natural phenomenon. It's a manufactured loop of conducting material that moves
Well, who
things
knows what's
around in a
natural?
ring.
Who knows?
As we know it, right? If we try to, we create a circuit here on Earth, yeah. But whatever's going on in the sky, we don't know how it was manufactured or if it was manufactured or if it's just the way things work. You know, we can't prove
how do you know
one
it's
thing or another.
electromagnetic?
We think
How
we
do you
can
know
prove things about the sky. We see it manifest like an electromagnetic field. It looks just like an electromagnetic field. We know that, but we can't say it is one for sure. It's all speculation. You guys think you know what happened fucking millions of years ago and the stars and all this. No one's claiming to know any of that, but it seems like it's an electromagnetic field and it gives it the mechanism, right? That's the actual mechanism.
These lines do not look like an electromagnetic field. Like I know what you're comparing it to. You're kind of like squinting there and you're like, these shapes are kind of similar, but
No, it's exactly the way they look. I mean, I do this all the time. I put the comparisons of the star fields compared to the way that the lines of latitude are. on the globe. They exactly this.
It's not a one-to-one to the electromagnetic field images you post. I get why they look similar, but it's not really the same thing.
Yeah, they just look similar.
I don't know. They look pretty much identical. That's hard to. I don't know that you'd have much luck in denying that. Really.
More to the point, actual magnetic things do not move through magnetic fields along the lines in that way.
How do you know that?
Because we know how magnets work. Like
no, it's an electromagnetic field.
It's an electric.
I'm not saying it's magnets in an electromagnetic field. Whatever the bodies are made of is a totally separate thing. The electromagnetic field, not magnet. You're trying to straw man it with magnets.
So magnets aren't electromagnetism now?
Not saying that either. It's not a straw man.
Well, to be fair, I don't really know how it's supposed to work in this model to begin with. But it's not obvious to me what type of electromagnetic phenomenon would have the stars moving in this particular way.
What do you mean?
I mean, where has this ever been demonstrated? Like go get some magnets, get some electrons, get some charged things, and
show me balls. Show me balls orbiting other balls. Go get your balls and show us the balls. Do we have to go all Demach with this? We know that you can't make a representation of the whole in a model on Earth the way that they say the ball is, right? You can't do that. It's just conceptual. It's all conceptual. At least this manifests exactly like it is. The stars are right there, and they look like an electromagnetic field. You can't say you have any kind of scaling or any kind of orbiting, and you can use your models. Say you have your simulation, but those are all fixed to make it seem like you're on a globe. And they take out the masses. You haven't even looked into this. Aries failure shows there's no movement, so let's just go from there.
That's not what Aries failure proved.
You were talking, we were talking earlier.
Right. I got deja
we were
vu
talking
in a
earlier
bad way
about
right now.
electric orbits. Like we have demonstrated one thing orbiting another using electrical forces.
Yeah, but there's no orbiting in this model. Do I need to say it a 10th time? There's no orbiting.
That's sort of my point, and I don't know what it's supposed to be.
They're independent of each other. They're not orbiting each other.
Okay.
They have their own path, independent of all the other masses of everything else. So there's no orbits. It's circling above us.
Then the connection between this and electromagnetism is very tenuous to me, right?
It would be to anybody. I mean, how that works, we don't know, but it manifests just like an electromagnetic field. That's for sure.
What manifests like? That's what I'm sort of asking. What about stars circulating in this orientation is anything like an electromagnetic field?
What? You're just gonna totally deny the similarities?
No, I see the images that you've brought up, and it's like ovals that are kind of the same shape, but it's just such a wildly different context because in electromagnetic fields, there's no material that's circulating along those lines. That's not what the lines mean.
Not to you. How do you know there's no material?
How do you know?
What do you mean? What do you mean? I do stuff with magnets all the time.
I'm not talking about magnets.
You're saying that the star fields are related to a magnetic field.
An electromagnetic field. Yeah, just the way that electromagnetic fields are depicted when you look up electromagnetic fields.
Right. But the thing is that those textbook diagrams of the electromagnetic field lines, there's nothing physically circulating there. Like there's no actual material of matter that is circulating around those lines. Like a magnet.
Well, of course not. That's not what they're just talking about the field. They're not talking about what's in the field.
Well, but the field is invisible, right? Like the diagram is useful.
Exactly.
The diagram is useful, but the actual electromagnetic field around an actual electromagnet is invisible, to the eye. It's not made of physical material circulating. The diagram is useful, but it is an abstraction. It is force lines. But you're saying that this is the same thing as the stars, which are things that we can see, like whatever they are, they're physical things that we can see that are circulating.
Sure.
And sure, like the diagrams and textbooks of electromagnetic fields have the same kind of shape, but
Yep,
we
exactly
don't
the same shape, in fact.
right, but they don't make things move in those patterns.
How do you know that?
Because it's never been demonstrated.
It doesn't mean like that. Just because it hasn't been demonstrated to you doesn't mean it can't work that way.
What I'm saying is that there's no known material that if you sprinkled it into an electromagnetic field would move in the same way that the stars move on your dual pole map.
Well, the stars, E at least thinks that they're like mercury nodules within the lattice structure, and that when the daylight comes around, the sun comes around, they might actually dissipate, and then kind of like a fluorescent bulb has that little ball of mercury, and then when you turn the bulb on, it actually disperses, and that's what creates the light. And then when you turn it off, it actually coagulates back down to the little ball of mercury. So like they would be like the nodule points between the crossing of the lattice structure that's above us, speculatively.
The point I'm making is that like I could put a magnet down on a table and spray droplets of mercury all around it, and they're not going to move in the way that the stars move. So like that's where beyond
Well,
simply saying
that's a rough straw man of how it would work. It is spray mercury on it. It doesn't look like it can't work that way. I mean, it sounds like you're just trying to find fault with it rather than actually see how it would work.
But I just posted 2 demonstrations that show with little metallic flakes that will form that same pattern. So
no, but they don't. But they don't circulate. Wait, let me see this here.
Yeah, they do.
So like that's where beyond
Well,
simply saying
that's a rough straw man of how it would work. It is spray mercury on it. It doesn't look like it can't work that way. I mean, it sounds like you're just trying to find fault with it rather than actually see how it would work.
But I just posted 2 demonstrations that show with little metallic flakes that will form that same pattern. So
no, but they don't. But they don't circulate. Wait, let me see this here.
Yeah, they do. They circulate.
This video.
Yep. Actual demonstration right there for you.
This one's a little better, the actual video I'm uploading right now of the first one, because the other one's like a GIF and it's a little choppy. This one that's a little 14-second video is a little more smooth and it shows a little bit more.
Yeah, let me see it more smoothly because they move around when you first turn on the power, but they don't form sustained constant velocity circles. So let's see what's going on.
It's just creating a vortex. Multiple things can create. Like, there's so many different things can create that vortex through electromagnetic interference or influence with the influence of electromagnetism.
I'm not sure what the flakes themselves are, but I appreciate that you showed this because that is interesting.
Yeah,
I think it's probably like a magnetic cycle, just like the center of a ferrocell image of a magnet. It's just completely black. It's actually just pure inertia in the center of the ferrocell image of a magnet. Sorry, I'm just going to.
I mean, now I want it. Well, now I want.
Yeah, I was just looking up. It says charged particles. Charged particles.
It's magnetohydrodynamics.
That exists, so that explains it.
That's not what I said.
Yeah, it doesn't.
They hate it. They say it doesn't exist when it comes to the core of the Earth producing the Earth's magnetic field.
Yeah, straw man and all you like. I would straw man it too if I were
I will say that maybe I stand corrected here on this point about the saying that you wouldn't be able to make a physical demonstration of observable physical objects circulating around the wire in this way. I've never seen anything like this before, but so now I'm very interested in what these flicks are. So that's cool.
Again, new perspective is ignoring the fact that these are just a wide camera angle lens.
Yeah, you can't show a non-wide camera. You can't show them not converging and diverging with whatever lens you use. It doesn't matter what lens you use. You're always going to get them converging and diverging. It has nothing to do with
converge and diverge.
You can't show it with a non-wide angle lens. That's where they don't converge and diverge. If you're going to make that point, you should show the alternative to it. It has nothing to do with the lens.
I posted it at 1026, a wide angle lens showing that the stars are in a static field.
In your
They
perspective,
are
have
in
you
a
ever
static field,
observed stars
but
like
you'll never
this?
be able to get one at the equator showing north and south with them not converging and diverging. That's just what they apparently do, no matter what.
They don't
Have
apparently
you ever
do that.
observed this yourself?
That's the observation.
It's not observed
Oh,
It
well,
is.
then
No.
why is it
Just denying that makes you
documented?
sound so stupid.
because he's using a wide-angle
Okay,
lens.
so
Has
go
nothing to
record
do
it
with a
in a
wide-angle
time
lens.
lapse without getting that observation. You can't.
Robert did exactly that.
That's the way they
Yeah.
always come out. It has nothing to do with wide-angle lens. You repeating that just makes it seem like you're in denial more so than you already are.
So
I'm
I've
in
got a
denial of
question
your
for you.
concept. I'm in denial of your concept because you haven't proven it. You just say it, but then when you
No,
photograph,
it's what every star trail north and south does, no
no
matter
star
what.
trail, no
Show me
star
star
trail
trails that
converges and
don't converge
diverges.
and diverge when they show the north and the south.
They
Show
don't
me any
diverge or
that don't.
converge.
They're parallel at the equator, and on either side they converge and diverge undeniably. And that's the
They would
last thing to
have
say
to.
about it. You can say they
I'm
don't,
denying it.
but it just makes you sound stupid because they do, no matter what.
So in your perspective, can I ask you
Simply
a
due to
question?
perspective, they would do that. That would be your default observation. Just
It's
due to
perspective,
perspective, that
exactly.
would have to happen.
Exactly.
It's like train
It's
tracks
pers-
in the distance. It's the same exact
it's
thing.
yeah.
Are the train tracks
It's
parallel? Sure. Do they
yep.
do they appear to converge and diverge? Yeah. Yeah, that's going to be a thing. And you're
Right,
saying
right, but
Yeah,
that's
it's
not
supposed
an
to be.
but they
observation.
only
It's like,
appear to
well, how did
diverge and
perspective
converge in
change?
images, right? They only appear to diverge and converge when you make an image. If you actually measure the angle between the train tracks, they are parallel. If you measure the angular spacing between the stars, they are constant. So if you get a equatorial mount and film the stars during the night, their relative positions do not change.
That is what
So
Jake posted or Robert posted. He posted
yeah. So
exactly that.
you know
But wait
that
up.
these photographs of star trails are a consequence of perspective and the lens geometry.
How can they be a consequence of perspective when the train tracks are like going away from you and the stars are considered to all be an infinite distance?
So
There's no.
perspective
Robert, if you're here, post that video again.
yeah. So risky, right? When I say perspective, I should say projection rather than perspective, right? So anytime you project a three-dimensional view onto a two-dimensional surface, you get some consequence of the lens is involved, right? And
Yeah, but you can't show it without that lens. It has nothing to do with the lens, right? You can't show it with a
It
normal
does.
lens that doesn't do that. You can't show star trails from the north and south at the equator that don't converge and diverge, no matter what lens you use. It does
So
that.
can you explain if you have a lens that tracks the stars during the night, including a wide-angle lens, that the stars do not move relative to each other?
They don't. In the north and the south, they don't.
No, anywhere. This happens anywhere in your perspective.
No,
You
they
can
converge and diverge no matter what, dude.
no,
Using an
if you
equatorial
have
mount doesn't make your point. Equatorial mounts are beside the point. It has nothing
no,
to
they're
do with
not.
it.
I
We're
think this
talking
They
falls.
about the north and
show.
the south converging and diverging as
I
they
think this
apparently do.
falls.
No matter
I
what you
think this.
do, that's what they do.
I think this falls into the broad category of axiomatic. They
Whatever you want to call
axiomatically do not diverge.
Yeah, right. You can say it, but obviously they do. So
They don't,
next,
which
you
means
just in
you're
denial.
right.
Show me northern and southern star trails at the equator, looking east or west, that don't converge and diverge. That's your challenge if you want to make that claim.
Robert already posted a video showing just that.
No, he didn't. Was it an equatorial mount video? Has nothing to do with this.
So if in the equatorial mount video
Okay.
the stars did not
All
move
right, mate.
relative to each other, why did they converge and converge in the star trail?
That's a bit of a contradiction there, mate. A bit of a contradiction.
What?
He doesn't understand.
No, I didn't
Did you
even hear
say
what he was
star
saying. You were
trails?
talking over him.
Did someone mention star trails?
Yes, he thinks the star trails converge and diverge. I don't know.
Always do that.
Over which land? Because you don't even know where anything is.
The map shows you where everything is. E1 made the map by using the nautical almanac. What do you mean I don't know where
You're
Have
not
you
everything is?
giving that
seen
The
man
map
any
shows
money.
Have you
what
seen
everything
the
is.
shape of
What do you mean?
Australia? And that if I head west from Western Australia, I hit the South Pole.
What are you
So the
talking
South
about? You
Pole's
don't even
below
understand it. You haven't
Australia,
even
isn't it?
watched one video I've sent you, Trouble. So you coming in here with criticisms when you refuse to watch any of the videos, it doesn't even make sense. Like, oh, I'm just going to straw man it, blatantly deny what I haven't even taken the time to watch 1 second of that I've been sent
I have watched.
multiple times, right?
I've watched them quite a bit the first time you sent them
Oh,
to me. I
really?
don't need to see
Oh,
them
okay. So
three.
then you wouldn't be straw manning it right now. You'd actually understand. And you wouldn't be making the claims you're making because it goes exactly against what was explained in the videos. So why claim you've seen them if you haven't really actually seen them?
So you explained where Australia is located
What do you mean?
using the globe model.
Australia is where they show it on the dual pole that they use. This is the map that they use for everything practical, right? They have the four corners. That's what they use for everything. They don't use a globe.
No one,
They don't use a
no
globe
one
to
can
figure
recognise
anything
the
out.
shape of
They have a flat
Australia.
representation of it, and they have the four corners, and that's the actual map they use for everything, right? It's the dual pole flat Earth map that they use for everything practical. Here it is, right here. This is what they use.
Yeah,
That's
but
why
that's
there's an
just
actual east, an
navigation.
actual west, an actual north, and an actual south. On the ball, it's all random, but they just happen to designate these areas. No, there's an actual east and an actual west. That's why the United States is in the Northwest. That doesn't change. You can't just like spin the ball and put the line somewhere else and make it. I mean, you could conceptually, but that's why it's represented this way, because that's how everything's practically used.
Wow, look at Antarctica. Even Australia's out of shape.
That's just a regular map representation. That's nothing I made.
Yeah, from the globe map model.
Yeah, that's what they
Just
use for
globe.
just coordinate stuff, like just to designate things. That's how they practically divide things. That's just a conceptual thing too. Nothing's perfect with a map. No globe is perfect, that's for sure, because obviously we're not on a globe to begin with.
Well, the
That
map
makes it
will
imperfect
Well,
from the
obviously it is
start.
perfect because you can find Australia quite easily when you're flying using that map.
The globe has been traveled, it's been
Yeah,
traversed.
Australia's right where it should be. Australia's right there where you are. You're not upside
Yeah, but
down.
look, you
Sorry
go
to tell
right
you,
and
you're
what?
not hanging upside down relative to me right now. I know you like to believe that all of a sudden again, but
That's
you used to
irrelevant to the
joke about
map.
how silly it is. You've like ignored all the silly things about the
So
globe you used to make fun of.
if I go
You're
east from
hanging upside
Australia, I hit
down,
the
and
ice
you
wall,
even
do
put
I?
your picture upside down to make fun of the idea that people think that you're upside down, and it is. It's stupid to think you're upside down relative to me right now.
It's not stupid.
That's
By the way, I do need
Yeah,
I
it's
do need to say
dumb.
irrelevant.
It's dumb because there's no evidence for that whatsoever.
So no one can
Everything
fly.
works. Everything works stationary and level.
No
so
one can fly east from Australia because then we hit the edge of the dome.
yeah, that's what
It's
we were
total
talking
straw
about.
man. Total
I
straw
love that you
man.
put America in the middle. It's great.
America's not in the middle. What are you talking about? I didn't put America
Oh,
in the
you're over
middle.
on the other side. Wow, look at you. You're a long way away. So
What are you talking about?
I fly east from
Who
Australia
puts
and I
America in the
Pac-Man over
middle?
the other side
Why
of
is this
Earth.
lady
And
so angry?
What are you even talking about, Trouble?
not angry.
You're saying things that
I'm
make
looking at
your
your map.
case worse. My
I'm
map's
looking at
not.
your map.
America's not in the middle for the dual pole flat
All
Earth
right,
map.
wrong chunk of land. So Australia's on the side, and I can't fly east ever because I'll hit the dome.
So then obviously you haven't watched one bit of the videos because you don't even understand the concept. So why claim that you saw any of it?
Because the concept
She's
doesn't make
talking
sense.
about. She's
You
talking
just
about
want
dead,
it not to work.
She's talking about Dead Reckoning, maybe versus going around the pole. East.
Yeah, and she would understand if she watched the videos. That's not how it works. So why claim you watched the videos if you didn't?
Well, why show me a map that isn't real then?
The globe is not real. The globe is not real. They based it on this, in my opinion. You can have your own opinion, but the globe is obviously the concept. There's no curvature. We're not moving. Trouble. That's a problem for your globe.
It's irrelevant where Australia is, and then if I go east, I'm going to hit the dome wall.
Who said there was a dome? I never claimed a dome.
Oh,
Why
I'm
do you
going to hit
strawman that?
container?
You just try to
Well,
throw
holding
all the
water
flat
in.
Earth
Can we have
bad
gas
ideas
pressure without
into
a
one
container?
thing. I'm not claiming anything. I'm saying that this is the way the map works practically. This is what they use for everything. They use this map.
But you're claiming a lot. You're claiming a lot.
Yeah.
I just want to get
that's what they do. I'm just saying what they do.
What,
I don't. It's not really a claim. You can look it into yourself. It's just what
what's
they
holding
have
all
the four
what's holding the
corners for
water in if
regular
it's not the
practical use.
dome? What's holding
I'm
the
not talking
water
about a dome.
on the
Why?
side of
Why even
Australia
try
if
to
it's
pin
not a
a
dome?
dome claim on me? It doesn't make any sense. I think about a dome. Why would you do
What's
that?
holding the water in
Desperate.
then? If
Sounds
it's not the
desperate
ice
on
wall,
your
if it's
part.
not a dome,
It sounds like
why
you're
doesn't
just
the ocean
desperate.
just keep spreading? Because,
You're just
the
desperately
water wants
strawmanning.
to seek
There's no
its
reason to
level, so
even
why wouldn't it keep spreading?
justify a response. You're just like, oh, it wouldn't work because of the dome. That's so trouble. Don't do this to
Well, tell
yourself.
me
I
what's
love you.
holding the water in.
What do you mean what's holding? I didn't say there wasn't a containment for the water.
Okay, there is a containment.
How am I supposed to know? I'm not trying to make claims of things that we can't disprove, but there would be like a beach shore somewhere where the
You're
water
absolutely,
ends, obviously. Water ends
you're
at the beach
absolutely
shore, right?
claiming shit
Somewhere.
you
You're a
can't prove.
But I
non-stop
can't get
stream of
out there where the
claims.
water ends. The water goes way further than the areas we're allowed to go, it seems.
Yeah, the navies are patrolling the whole outer area to make sure we never go out there.
Why are you strawmanning it when I already said when the first time you brought that up? I never said they were patrolling the whole outer area. Why bring it
Then it
up as
should
if that's a point when I already said there's armadas of ship on one side that Ewan was pointing out in that video that would block you from going to a certain area.
Armadas of
But I
ships.
didn't say they were surrounding us like I already said when you brought it up the first time. That wasn't my claim. But now you're saying, oh, yeah, well, they would have to be completely surrounding us. Armies of boats. And that's why strawman it? It makes you sound desperate.
Well, then it should be easy to get out there then.
Well, that's what I said. The compasses don't even direct you that way. Who goes out in the middle of the blue side of the ball, other than a flat earther, and try to prove that you can cross those lines that wouldn't be
Okay,
crossable?
you're saying
Lots
you're
of
not making any
Australians
claims.
have.
You're saying you're not making any claims while you make a bunch of claims.
Yes.
Whatever, dude. You don't have any. That's a really good argument. I'm telling you
It
how it
is.
would work.
You're saying you are
I'm
making
telling you
claims,
how
but
it
then
would
saying you're
work.
not making
If it's a
claims.
dual pole, this is the way it would work. You can say if it's a globe, but you never say if it's a globe. You say it's a globe, and this is how it works. When you
Yes.
have no idea, it's just a conceptual model, and it doesn't
But
even
did you
work.
say
It's so
yours was a
stupid.
conceptual
The
model?
the spinning ball is the stupidest thing
You
ever.
you said
It's the dumbest
the
thing
dual
ever. I can
pole.
understand
You
why you're
said the dual
desperate.
pole was a conceptual model.
Yeah, it is. Every
Right.
model is conceptual. Every model is conceptual. The menu is not the food. You can eat the menu all day and say it
All right.
tastes
I've
just
had
like the
enough of
food.
that.
You can do that. To eat the menu all day long and
That
tell
is
us
just
it's real food and try to convince others that the menu tastes just like the food.
none of this
But I
makes
don't
any
want to eat
sense.
your menu. I'm not interested in the picture of the burger that you're trying to feed me.
I do want to just say thank you to those who shared the magnetic hydro vortice thing. That was pretty cool. I'd never seen that demo before. I'd really like to do that myself. So that's awesome. Thanks for sharing it. But back to this whole ocean thing. Like, okay, so let's go do this. Like, let's get a boat and let's go out there.
There's no way he's going to get a boat. What are you talking about?
And we'll get an accelerometer for the plane too at the same time.
But this seems even more important. Like, rather than debating like minor accelerometer data from a plane, like let's steer a ship towards the edge of this map.
We have
Welcome to flat Earth.
we
This
have
has been brought up ever since we've been talking about this in 2015.
We have a proposed alternative to the now defunct AE map.
Yeah.
That's very exciting.
Yeah, I want to see this done. I mean, people went to Antarctica, and I want to see people try to go off the edge of the map in the Pacific.
Do you see where Antarctica is from Australia? It's
What are the chances someone will charter a boat and plot
the
it?
interesting part about the dual pole model is when the sun is on the southern circuit, what would the sun look like from, say, California or China? The sun would like rise southeast and set southwest in California, and that doesn't happen. It would do the opposite in China. There's a few billion people that live in China and California that can tell you that that's not how the sun works. I mean, so you've basically taken the problems from Antarctica, where nobody lives, and puts huge problems on where a couple billion people live.
Yeah.
I don't know what that straw man is, but it
No, it's
works
not
just
straw
like
man.
just the
Not straw man,
GPs of
sir.
the sun work exactly
Not a
like
straw
this
man.
GIF
No,
I'm putting into the chat right now. That's the way it
they
works.
wouldn't though.
24-hour
There's no
sun in both areas. Of course, NASA sure is going to come up with some kind of
the
real
California.
critique that's really thought out, other than to say, "Nuh-uh."
I'm not saying nothing at all. What I'm saying is, imagine yourself on this dual pole model located in California. There are a few 100,000 people who live there, right? Million people.
Right.
And then look at where the sun would rise and set when it's on the so-called southern circuit during the
Yeah,
winter.
I've gone through those issues before.
Yeah, yeah.
And I need
So
to
how
make my
the
I need
sun
to
would,
make my GIF a lot wider, in fact. But
the sun,
it
the
works
sun
just
would
like that. We've actually had
no,
some
it
people
doesn't.
bring up points like that, and it's an
Mhm.
electromagnetic field, which also affects the light. By the
Yeah,
way,
no, the
that
light.
we know that
Wait a minute, hold
electromagnetic
on.
fields
Wait a
affect
minute.
light.
How does an electromagnetic field affect light? Please tell me that one.
Just look it up. Google it. You're
It
good at
doesn't.
that. Just Google it.
Doesn't.
It's like
Yeah, I did.
a
Light is not affected by
Ramaham and
electromagnetic
bomb,
fields.
whatever it was, experiment. Japan pulled it off. They caught
Light,
deflection off. Yeah, dude.
light is
Yeah,
not
they use
affected
an
by electromagnetic fields.
electromagnet, right? And then they wrapped it up so they could not measure the electromagnet. Like there's no reading on the best instrument they could come up with, right? Yet the potential of that field influenced the light.
Incorrect. Show me that data. Show me the paper. Because
Bro,
light is not affected by
this is you.
electromagnetic
This
fields.
is why I hate talking to you. It's like you will be incredulous to the fucking extreme, and then
I'm not
call
incredulous.
other
I want the
people
data.
constantly incredulous, bro.
I want the data. You made something up because light is not affected by electromagnetic fields.
Yeah, electromagnetic potentials.
What's that
Not
mean?
the field, not the field, just the potential.
What's the
just
potential
the potential of the influence being there.
What does that mean?
Will affect light.
In words. What does that word?
He's talking about something called the Avram effect. It's highly technical into the deeper workings of electromagnetism. I don't think this is super relevant for anything that's been discussed so far, but there's some cool.
We're talking about light.
You can see a
light is not
ferrocell with a
affected
magnet
by the
that totally-
electromagnetic potential or the field. That's what he said, and I said, no, actually, science has proven it is.
No, you're thinking
where?
of
The data. Show me the data. Because the light is not affected by electromagnetism. Sorry.
Yeah, it is. Protons.
That's just
yeah,
dumb.
protons are.
Just Google it, bro.
I did. It's not affected by light's not affected by electromagnetic fields.
Yeah.
Why do you keep repeating it when you're so wrong, dude?
That's what Google says.
That's what Google says. Okay,
That's what Google says.
sure,
Yeah,
buddy.
let's see that.
Okay, hold
Well,
on.
you
Want to see it?
you said to
So
Google it.
Japan made the whole thing up. They lied.
No,
okay.
you're
show me the
just
data.
mixing a few things up. You're mixing up electrons with photons.
They shot both. They shot photons as well. Dude, just read the fucking papers. Like I tell you guys
Show me
about
the paper.
Hey,
Yeah,
go
I'll
fuck
check it
yourself.
out.
You suck. Like I'm serious, zzpop. Like you know what I'm talking about. Just research it. There's plenty of videos
did.
on it and what they did.
I did. There's no.
Except
Light is not affected by
I know what you're
electromagnetic
talking
fields.
about. The double slit with the coil tube,
Essentially.
and there's no magnetic field outside of the tube. There's only magnetic field inside the tube, but the magnetic
donut.
potential. Yeah,
Just look at
extends
the
outside.
ferrocell pictures I just put in the chat. Ferrocell shows that light's totally affected.
That's the medium.
No, ferrocells polarize light.
That's the medium. It's not. It's you're shining through a medium. Yeah, medium's effect. But the
medium?
electromagnetic field. The electromagnetic
The
field.
light within the medium is
A
affected. Yeah.
potential field is a medium now.
Well, no,
No, he's
that's
talking
what
about
the
the ferrocell.
ferrocell is. The ferrocell is not just the field; it's the medium being affected by the field, and light's being refracted in the field.
That's all we're saying, dude. So that's light being affected by the field.
In the material.
No. Different.
Without material, without detectable material, the light is still influenced.
Incorrect. In a vacuum, it is not.
Well,
affected.
then you just denying what fucking Japan did. I don't care.
Show me the
idiot.
paper. I've looked for this paper. I
You
can't
go
find
look it up. Go look it up.
I did. I can't find
Your
it.
lack of knowledge, not my problem.
No.
Your
You're
honesty
making a
level
claim.
is not worth my effort
making a
to
claim.
do anything, guy. You'll
Claim,
come in tomorrow. You'll read it. We'll go through the whole thing. We'll hash it out. You come in tomorrow, reset, and lie about everything.
There is a paper means you should provide your claiming evidence.
Yes, but you are not worth my time because you are
I see.
a
So you can
liar.
lie. You can lie your ass off and say there is a paper and not give it to me because I can't find this paper because I don't think it exists. I think you have
Well,
made
it
something
sucks
up.
for you, dude. It sucks for you
I
that
know.
you
You
can't
lied.
figure out how
I
to
know it
find this.
lied. I know.
But
I know.
hey,
It
ZZ
sucks
Pop
to me
found
that
it,
you are
so there's
lying ass.
that.
Did he post it?
No, I didn't
Or,
post it, but I know what he was
You do
you're
your
referencing.
own
But
work, bro.
I think this is
so
not.
I have to prove your claims now. You get to make claims, and I have to find them.
No,
Excellent.
I'm
That's
just
what I'm
telling you,
applying
I'm
for.
disregarding you. I don't
Of course you
care
are.
if you want to
Because
claim a citation or whatever. I'm telling you, this is
so I
real.
have to find your citations now.
If you choose not to believe it, you can continue to do so.
Citation, please.
But if you
Citation,
want to
please.
educate yourself, go research it, and you'll
Please
realize you're
don't talk
wrong.
about education. Don't talk to me
You
about
think
it.
this is like some kind of formal debate where you're gonna
No, I
force
think it's
me
like
into a
somewhere where you
debate?
make a claim, you need to back it up.
No,
If
I'm
you
not
say
gonna
there's a
sit here
paper,
and debate you. You're one
of
of the
course
most
not, because
dishonest
you
people
get
I've
your
ever
ass handed to
spoken
you
to
if you
on here.
try. Because I smoke you every time because you may
I
lie.
do want to.
Smoke what, guy? You're spinning your
Lie.
wheels.
You lie your ass off. You say
gonna-
there's a paper, and you can't post it. You post it through
Okay, doesn't mean it
Periscope,
doesn't
which is
exist.
a medium. Yeah, light is
This
affected
isn't a
by mediums.
debate,
I will
kid.
agree with you.
This isn't a debate, buddy. Get
What
over
isn't a
yourself.
debate? You can lie.
Get
I see.
over your. You're
This isn't
not
a
that
debate. We
important.
don't need evidence. You can
All
just
right,
lie your ass
guys.
off. Then.
Natsa, he is referring to a real paper, but I think there's some things being lost in
Well, did you have
communication.
this
But I
paper?
do need to double check what it is. There was a YouTube video on it not that long ago. There is this experiment, but I'm pretty sure it was done with electrons, which is expected
and
here.
photons.
And photons. Okay, I'll double check that part of it.
Just give me
Just
the paper.
ChatGPT it real quick. You'll figure it out.
I'll throw
Ask the AI.
Wikipedia.
It'll probably tell you. Be like, during this experiment, yada yada yada. Did they use photons? They'll be like, well, yes, actually they did. But if you talk about the experiment, it'll probably just tell you about electrons. Just press it. Be like, well, Japan used a donut and photons, and then it will be like, yes, they did.
I gotta get to sleep soon, but I want to take a moment to appreciate the GIF from New Perspective of how light moves around the dual pole Earth.
I've sent it to you like 3 times already.
I know. It's not the first time I'm seeing it. I am giving you a shout out because you've actually produced something here. It's
All right,
instead
thank you.
of being a vague gesture, it's a testable model.
It's just where the GPs of the sun actually are.
What's that? But I saw it like lighting up Antarctica. Is this meant to be a day cycle, or I definitely need some more context to
It's a year
understand?
cycle.
I need to make a better GIF. I'll tell you that. It's not accurate to the, but that's the concept.
It's a year cycle.
It's a year cycle.
It'll be always a
I just made it
challenge
go
to make
twice
one that's
around the
accurate,
north
right?
and twice around the south.
So it's a 2-year cycle.
But before you can make one that's accurate, you're going to need to know what the properties of the surface are, right? Because to plot out the position of the sun on the ground, you need to know where the ground is in reality, and you can't do
Yeah,
that.
it's definitely not a ball. I'll start with that because we know it's not a ball. So we'll go from there.
It is a ball. Sorry.
You can pretend that if you want. There's nothing to show you that's the case. You could. I'm not gonna accept your fantasy as fact.
Yeah. If you look at your model here, supposedly,
Yeah.
how would the sun look when it's on the southern circuit from California? Would it work? Would it rise and set in the same place?
Exactly the way it looks in reality because it's a dual pole flat Earth.
Incorrect. It doesn't. When the sun's down south, it
No,
would.
we're not on a
from
ball, bro.
California,
It looks
it would
just like it
rise.
does on a dual pole flat Earth.
It does, but not on this
That's
model
reality.
of yours. On this model of yours, it can't do that because the sun is south of Antarctica. It would rise in the north, rise in the
What are you talking about?
southeast, and set in the southwest. Not even southwest. It would.
What?
It doesn't work the way it would not look. The sun
You
would not.
you don't want it to work. I know. I can tell you really don't want it. You're just trying to.
I
You're
don't want.
fishing for a straw
I would
man.
love it to work. It's not working. Your model
Oh
doesn't
yeah,
work.
you would love it. You would love it to work. Sure.
Yeah. Well, get it to work.
Yeah,
It
you would
doesn't.
love it, wouldn't you? Your ball would be debunked.
You've explained
You love
Antarctica
the
now,
ball
but
to be debunked. We can tell you would love to have your ball debunked.
you've explained
You always give that
Antarctica
impression.
now. In fact, it doesn't. It looks like when it's over the equator.
Whatever, dude. You're not even worth responding to. You just don't. You
I
don't
know,
even try to get it.
I know, because your model's full
Yeah,
of shit.
because
I
no.
told you
Dude, you're
full of
so
shit. I
old,
know.
man. I
Go
mean,
ahead.
it's
Go
just
ahead,
so
say that.
bad.
I know it's really bad when you have shitty.
Yeah, I know
When I
it's really
call you
bad,
on
but
it,
you don't want to
shitty
hear what
evidence.
I'm going to say, man. Dude, you're
No,
such a
you need
broken
evidence.
record.
You don't
You're
need
not
shitty.
worth
No
it, man.
shitty
You're
evidence.
just like why would you
I
even
know.
be
I
here
know.
if you were so confident you're on a ball? Why would you be here every day talking to
I'm
flat
here to
earthers?
laugh at you and to see your shitty evidence.
Oh yeah, you're
But
not
you're not
laughing. You're just
laughing.
crying.
You're
All you do is
getting
I am
cry. You
laughing.
don't laugh.
I
You
am
just
laughing.
whine.
Your
All
blood
you do is
pressure's going
whine.
through
Oh,
the
I'm
roof,
laughing.
guy.
No, my
What are
blood
you
pressure's
on about? You
perfect.
don't come.
And
You never
I'm
laugh
sitting
when you're in
watching
here.
morons like
It's
you.
always like some bitter
It's an inward.
response, like
It's
you're
an
just
inward laugh.
seething the entire time,
It's an inward laugh.
and you're like, "Oh, I come
Idiocy.
in here for entertainment. What? You
I
come
do.
in here to what? Raise your blood pressure?
No, I don't raise my blood pressure. It's fine. I get entertainment
Yeah,
here.
okay, guy.
Oh
You're on
yeah.
Shit
meds
like
because you come in here. You ain't fooling anybody. This place
speaking of
makes you
meds, have you
fucking.
taken yours today? You've
This
taken
place
your meds.
makes you visit the doctor and get blood pressure
You should take
meds.
your meds. You should take your meds. It might help.
I truly would not be able to come up with a lot of this stuff myself.
Just use the Nautical Almanac and the Weems and Plath Star Wheels. You should they're about $100 on. Anybody can get the Weems and Plath official Star Wheels, and they work just like this. That's what he used. Just go to Amazon, type in
Then how
the
come there's no
Weems and Plath
separation
Star
and
Wheels.
conversion
Use
zone on those
use the
wheels?
pick I just put in there. It's called the Starfinder 2102-D, and it's about $100 on Amazon. It'll show you
And
the
you have to have
converging and
different ones for the
stars.
northern
It'll
hemisphere and
show
the
you
southern
exactly
hemisphere.
what this map shows. And you just have to
Why
get
you
the
have
Star
different
Wheels
wheels?
and see if that's right. If you care that much. But
Why isn't there
I
just
know that
one
these Star
star
Why do
Wheels
you
are
have
wheel?
different
actually
wheels for
official
different
Star
latitudes?
Wheels. This is how
Why
it
do you have
actually
different
works.
wheels for different latitudes? Why do you have different wheels for different latitudes?
There's no different wheels for different latitudes. Those are correct.
Each
Those
one
are
of those is for a different
overlays.
latitude.
Yeah, those are overlays, so you can plot your position in relation to a star. That's how the wheels work. Weems and Plath is no
There's one for
joke.
each latitude,
Weems
though.
and Plath is
Every,
not a flat Earth company.
Each one of
They're
those
a
has a
globe
latitude.
Earth nautical supplier that's very valued and highly sought
Each
after
one of those is for a
material.
different latitude. For some reason, you need different ones for different latitudes.
Why do you keep strawmanning? I said those are overlays. They correct
You have
for
one
the
star finder for the
oblateness
entire Earth?
of the field. They're correcting for the oblateness of the field, which you call an oblate spheroid for that reason.
Oh, for latitudes, right. You have different ones for different latitudes, like I said.
Well, you're trying to make fun of the official Weems and Plath Star Wheels. Take it up with them. They're the official
I'm saying that
nautical almanac company.
correct.
It's not like
And
a
almanac,
flat earth. They're trying to make it work.
right,
It's the
because
actual
they're based on the
stars,
globe.
the
Yeah, they're based on
actual
the globe.
stars in
Based
positions
on the
to each
globe.
other.
Almanac is
Weems and
the
Plath.
globe.
No,
Yeah,
if you put the Weems and Plath next to each other, that's the only way they work is side by side. But they
Do the
make it so
stars
the north on one side
converge
and the south is on
and
the other.
Why would they have
diverge?
to do that? Huh? If the
Do
Earth was
you,
flat, you should be able to see all the stars are the same. You should be able to see the North Pole from the South Pole. If the Earth was flat.
You're just babbling, dude. You make no
I'm
sense.
babbling.
I'm just coming here
Wait,
for
hold
fun
on.
and whining
But
and
here you are.
whining and whining
Here you are
for
using
fun, but I whine.
using
I
a
don't
tool
take
that
my
you say
ball
is made
away.
by.
Don't take my ball away, but
But
I'm
here
here to make
you
fun
are
of you.
using a tool made by a company you admit is a globe company and saying that it supports
I'll
the
take
flat Earth.
my ball
No,
away.
you say the Nautical Almanac.
How
You think the
dare
Nautical
you?
Almanac supports the flat
Sounds like
Earth?
you're having a lot of fun, NASA.
You think the Nautical Almanac supports a flat Earth?
Sounds like you're having a lot of fun, bro.
You think the Nautical Almanac supports the
This
flat
must be
Earth?
great entertainment for you.
You think the Nautical Almanac supports the flat Earth?
Yes, he does, but he won't
I know
admit
he
it.
does.
we need a blood
Oh
pressure
God,
check.
you're gonna jump in with NASA shill. You're aligning with NASA shill trouble. I really
Here he
can't
is.
even
Yeah,
stand to see.
I'm
I
aligning with the
can't think of
truth.
you that
in
way.
this conversation?
You're an
Yes.
anti-flat earther now. Come on, I don't do that. Don't do
I
yourself
align with the
like that.
truth
Don't do
instead of what I
yourself
want it
like
to be.
that.
So here he is
You really are
using a
you're gonna be
tool
sorry.
made for the
You're
globe.
gonna be sorry that you
The
aligned with
flat
NASA
earthers.
shill someday. You're gonna be like,
This
oh my God,
is like Kuhn's law
oh my
again. We have
Well,
God.
for the
we have
moment,
a
I'm
Why
tool
did
not.
I
made
ever
But
for
agree
the
with that
globe.
bozo?
We have a tool made for the globe that some flat earther thinks supports the flat Earth. I love it.
Sounds like entertainment you're having there. Sounds like you're having
I
a
am. It's
blast.
great. I am
Yeah,
having a
it's so
blast.
fun. You're
Having
having
a
so much
blast.
fun
This
because you're so
morning
mad people are
talking.
taking your ball away.
I'm not angry at you. You're just a dumb fuck.
Yeah, well, that's pretty fun for you, I guess. Talk to dumb fucks all the time, I guess. That's what you like.
I just love it when people use tools made for the globe and
Oh
then say,
yeah,
"Hey,
you
this
love it,
supports
don't
the
you?
flat
You
Earth."
just love it.
If the Nautical Almanac supports the flat Earth, why didn't you get MC Tune's $10,000 for a simple 3-star fix?
Yeah, MC Tune, blah blah blah. It's your broken record, dude. You're just a broken record.
I know, but it works because you never have any answer to it other than
I'm having fun. I'm just complaining. I'm just whining and desperately having. Don't you MC Tune and mama. Dude, it's so old. I'm not even interested. I have to go, man. I have to go because you're just
fine,
so
run
bad.
away. Run away.
Yeah, run away. Yeah, run away. No, I just can't, dude. If it's going to be a conversation with you, I'm not interested because you just don't do anything but whine and act, and then say you're having fun.
Run away.
You would love if I run away, wouldn't you?
Oh, he's
No, I'm
already
staying
done
right
that.
here. I'm staying right here.
Oh, look, I'm leaving. Oh, damn. That's keep.
I
That goes
on
in
something. Phil, can you take 5, please? Because you're just kind of like, I don't know what you're doing, but it's not productive. It's just bickering. Was there some content here?
Geo, are you not entertained?
By NASA shills,
His bitterness.
I'm gonna say the best comment of the back and forth bickering was, "You're just mad that it took away your ball."
I just love the fact that he's using tools made by a company that, he's using globe tools and saying, "Hey, look, this shows that the Earth is flat."
Yeah, the source data. Yeah, the source data is
SAR
the globe model there, right? Though, and they just project it onto a surface. You can turn the globe model into one of those things in about 10 lines of code. They're not very complicated.
Too bad our reality is a stationary plane, like everybody should realize by now.
Not though. Sorry.
Can we backpedal half an hour or so? There was some discussion a little while ago about the n-body problem, and Pure Rigor brought that up.
You're
in
gonna
good
get
faith,
cooked.
apparently.
Oh,
So
please.
I'm interested to see what the issue is with the n-body problem. Why it's such an issue?
Because flat
Why
earthers
is
don't
such an-
understand simple.
Yeah, NASA, can you just like hold your
mechanics.
breath for like 10 hours?
That's why I said take 5. He's just in this like insult mode. There's just looping. So can
I'm
you
in
just take 5
insult mode?
without having to be muted? Yeah, just chill. We're gonna have a real combo.
I'm in insult mode. Got it.
Okay, thanks.
So if
Yeah,
you have
pretty sure he asked me the question. So settle down.
I didn't hear who it was
So
asked to.
if you take, it was towards me. If you take the any simulation, right, and you take all the values that we have, all the measurements we have of the cosmos, and we say, well, according to this math, according to that math, blah blah blah, right, and you apply Newton to it, you end up with a couple things going on here, right? Two bodies, it can keep like a cycle. It can become cyclical and it can stay in lockstep with each other. You add that third body, it's either going to be collision or expulsion. It's either going to just like slingshot it around. It's going to build up so much momentum, it's just going to get shot right out of the system, or they're just going to continue to crash. The only way that they can counter this through the simulations is either change independently each body's gravity, or just pulse the gravity. Pulsing the gravity seems to be a little bit more accurate from what I've seen on all the websites that
Pulse the gravity? What do you mean pulse the gravity?
Like it's
Turn it
on
on and off.
it's at like 100%, it's at 50%, it's at 75%, it's at 100%, like that, like pulsing, not constant.
I don't think that's true, right? So first of all, we don't need to try and do an n-body simulation of the entire universe. We can start with a much smaller number of bodies, like Earth, Moon, satellite, or even the solar system, right, where the number of bodies is less than 10. And there are stable solutions to that n-body problem. They're not analytic solutions, but you can solve and have a very stable solution to that n-body problem without any kind of weird ass things at all, basically.
Now you talk about something completely different. We're talking past each other.
Nope.
You talk about what, a mathematic solution?
Yeah, you've gone very quiet, Pure Rigor. I can't hear you.
Oh, I said, yeah, we're talking about two different things now. You talk about what, the mathematical solution? Like with an open formula? I'm talking about a closed formula solution where it's like plug in these numbers, here's the formula,
That doesn't
and now
matter.
it works and it represents reality. That's not a thing.
Yeah, there's only closed form solution to the 3-body problem for very specific cases, I believe. But we don't need a closed form solution to solve the n-body system.
No, you can't.
Yeah,
It's not that you
kinematically
don't
you can do
need it.
anything.
What I'm saying is you
Dynamics
cannot
don't work.
do it with a closed form solution. That doesn't
Yeah.
exist.
Yeah, no,
So what
that's not a
that
problem.
means,
Not a
what
problem.
that means, if we're being clear, is you have variables within your formula that you claim is solved. It's like, no, these are just variables and averages to like minimize the damage of it.
No, I
It's
mean,
not
literally,
solved
like
in
the
the
period
sense
of a
of like we
pendulum.
figured this out.
The period of a
So I think
pendulum you can solve with a simple equation, but when you put a pendulum on a pendulum, there's no longer a simple equation to solve the period of a pendulum. Then it becomes a chaotic system, like the three-body problem, and then
Yeah,
you
a
have to.
double pendulum. Yeah.
Yeah.
Yeah, you end up with
But
the same
double
problem.
pendulums
You end up
exist.
in
Yeah,
chaos.
double pendulums exist in reality.
Who said they didn't? We're talking about, is
But you can
this
apply the
truth?
same.
Is this math truth?
Yeah, but you
That's
can
what we're
apply the
talking
same
about.
solution
Is
and
this
find.
concept truth? And I'm
Yeah, but
saying,
you can
obviously
apply.
not, if it can't
You
even
can build.
represent the cosmos.
You can build simulations just like you can build simulations of a double pendulum where the system is stable.
No, you actually
The
can't.
double
You can't
the double
build a
pendulum won't stay on an
one-for-one.
orbit
You can't
or a
build like
circuit.
a one-for-one simulation for a double the three body, like the
you
cosmos,
can.
and you can't do it for a double pendulum.
You can. You can actually, I posted a video a while ago, and the guy has an inverted double pendulum. So you've got a double pendulum and it's standing on itself. There's actually a solution to make that stable. You can actually build a control system to keep all three links in the double pendulum in line with each other. So turn it from a chaotic to a stable system. But the end body problem is and zzpop, please correct me if I'm wrong here. Closed form solution is talking about providing a mathematical analytic solution to the problem. And that is
Yeah.
where we can't do it.
Yeah, other than very special cases. There's some special case solutions, analytic solutions to the three body problem, but in general, the three body problem doesn't have an analytic solution. An analytic solution is a simple math formula where now it's just like number in, number out. So when you can't do an analytic solution, you can still do a simulation. And the simulation could show chaos. And chaos means that the simulation will become less and less reliable the further and further out you look into the future. And like, I don't know, this is just a fact of life. We do this. We simulate chaotic systems and be aware of the chaos, that puts a limit of how accurate the simulation
Yeah, it's highly
is.
misleading. It's just highly
But
misleading.
it
We
can be
simulate
accurate. It
chaotic
can be.
systems. No, you
No,
you
we
don't
do. Yeah, we
actually
do.
simulate it. You don't. You work on a presupposition, right? And you build this simulation in your ideal environment, right? But when you have all the factors, like even going down to the double pendulum, right? You can say, I can simulate the motion of a double pendulum. You can make
Yep.
all those claims. You can say the math is solved. I can simulate it, yada, yada. And then I'll let you like spend as much time as you need measuring everything as precise as you want, and then let it swing. And you won't be able to predict the first rotation of the bottom pendulum. But then
That's not true.
you'll sit here and talk like it's 100% true. You just got to get caught
You could
up.
definitely make a simulation that could track a real physical double pendulum for a while. Eventually, the simulation failed to
Not
track it.
even the first. Not
You're not
even the
talking about a
first
pendulum,
rotation.
right?
You can't predict
Double
when
pendulum.
that first rotation will happen on a double pendulum.
But we're talking about a much more stable system than a double pendulum here, right? We're talking about the solar system.
So
We can.
You think that's more stable? You
No,
think
no,
you have
it
more
is.
variables than that figured out?
It's because the sun is so massive. So, like with the double pendulum, if you make one of the weights of one of the two pendulums a million times heavier than the other one, it suddenly
It's not going to
becomes a
rotate.
very predictable system. Yeah, that simplifies
Well, it's not going to
things.
rotate, and it's not a double pendulum.
No, it's still a
At
double
that
It still
pendulum.
is. Yeah.
It's just a double pendulum whose behavior, there's still a little bit of chaos. There's still a little bit of chaos, but the chaos has been dramatically clamped down. The behavior has been dramatically simplified to something that isn't perfectly predictable, but
Yeah,
is
you stopped its
very
motion.
predictable.
That's all you're saying. You're saying,
No,
well,
you
if I
haven't stopped the
prevent it
motion.
from moving, I can prevent I can
No, I didn't
predict
prevent it
its
from
lack of
moving.
movement. It's like, well,
No, I didn't
congratulations.
prevent No, I didn't prevent
Yeah,
it
you
from
did. You
moving.
added more weight to the bottom pendulum. How does that not restrict its movement?
It restricts
So
it. It
did
doesn't prevent it.
Exactly.
And
That's what I said. You said you didn't.
right,
Why?
and there's still no, but there's still some, like, it's still a double pendulum. There's still the joint, right? You know, there's still two separate bars. There's the joint in between them. I'm just making the lower mass way heavier than the one above it, and
Yeah,
that
you're
does,
restricting its movement. I get it. Yeah,
yeah,
I get it.
exactly.
You're
But
restricting its movement, and you're saying,
it's
"Look, I can predict its restricted movement to a certain
That
point,
was
to
the
a certain
analogy for the
yeah,
degree."
solar
exactly.
system,
Yeah,
right?
that's the perfect analogy for the solar system because the sun
But
is
it's
that much
not,
more
though.
massive than all the
It
planets.
is.
Yeah, that's why I use this analogy. The
So
solar
pure rigor.
system.
When we, oh,
That
you go,
doesn't.
Susan.
You're saying the size of the sun restricts everything's movement?
Yes, yes. The fact
Yep.
that the
No,
sun
it just
is
causes it. It just locks it in and causes it to travel around the sun. You still have every planetary body moving.
Yep. But so that's the
And they're
dynamics,
all
right? That,
affecting each other, right?
yeah.
well, not only if
But
they get close enough. I mean, all the planets are far enough away
Oh,
from
gravity
each
has a
other.
limit?
I mean, it dies off pretty quickly with distance, yeah. So yeah, if you keep all the planets far enough away from each other, then their effects on each other become tiny compared to the effect of the sun on them. So then the sun becomes so dominant that it becomes really analogous to not just a double pendulum. You could make it, a quintuple pendulum, but with all of the masses on the pendulum absolutely tiny and then one giant mass at the bottom. That's a perfect analogy for the solar
No,
system.
that's a horrible analogy. We're talking rotations, and you're like, I'm going to cripple the pendulum so it can't rotate, and then say that's analogous to a sun where everything rotates around. What are
Well,
you
it's
on
not
can you
about,
the
guy?
see?
rotation, it's about the chaos.
What are you
It's about
on
that.
about?
No,
We're
no, no. It's
talking
not
about
about.
free movement rotation that in the solar system, every planetary body is rotating. That is the thing.
Can you,
And then you tell me I'm going to put weight on the end of this pendulum so it can't rotate, so I can
Okay, the
predict it. It's like, what are you?
relevancy of the
How is
double
that analogous,
pendulum.
guy? Come on.
No, the relevancy of the double pendulum was not literal circular motion. I thought that was clear. Maybe it's not. At no point did I say that the motion of the pendulum looks like the same motion of the solar system. It was just an analogy about chaotic motion in one case, chaotic motion in a different case, and
Dude, what do you
how
mean by chaotic motion when you say that? What do you think that means?
unpredictability of where the masses
Why?
are going
Why
to
is it
go.
unpredictable?
Because there's no closed form solution to the double pendulum.
Okay, so now you have a chaotic environment that you call space, and you say I can predict these movements, but you tell me chaos means unpredictable.
Well, so chaos means unpredictable in the long term.
Okay, so how are
Yeah,
you predicting the movement of the planetary bodies?
because the amount of chaos is tiny. So it takes an incredibly long period of time for it to build up.
So unpredictable but predictable.
Nope. So you could release two double pendulums and they will follow each other for a good long period of time before they split and do completely different things.
That's not true.
It is true.
No, it wouldn't be true.
So
Even under
there's
the best conditions, you're not going to predict
no,
the first rotation.
that's what you're missing is there's an entire middle ground here, which is that, like, you can quantify the degree of chaos of a double pendulum. The degree of
How do
chaos
you
is
do that? How do you
it's how
quantify the
long,
chaos?
because it's how long it has to go for before you can no longer predict what condition it's in.
Yeah, you're just saying
So
eventually it's going to break. That's what you're saying. You're saying I
I,
took every measurement I could. I accounted for every single factor I could, but eventually I figure out I'm wrong if I just let it run long enough. Okay, well, I'm
right.
going
So
to say then you're
I take
wrong.
every measurement I can.
And
I
you're
make
just
a
saying it's
simulation.
chaos. Like this word chaos means absolutely nothing. It
Okay,
just
right,
means
sorry.
all it's
The
going
word
to come down to is you're going to say there's measurements I need to obtain that I can't physically obtain.
no,
That's what chaos
you're right.
really means.
Okay, yeah. Let me
Because you're saying these precise measurements are the tiniest minute bit of variable that causes long-term deflection.
Yes.
Right.
So
I know.
right.
So
So
you have a burden. You either admit that there's variables you didn't account for, or you just claim that you need measurements that are so precise that you can't actually obtain them. And I would err towards the side of there's probably something you're missing.
so so to be clear on what I mean by chaos and how it's quantified, I posted some videos of double pendulums. And what they show is that at first, all the double pendulums are exactly identical to each other. You don't even see that there's multiple ones within the video because they're all tracking exactly on top of each other within the video. And then at a certain point, if you let it run for long enough,
Oh,
they
dude, is
all
this a simulation or actual pendulums?
it's multiple ones in the
Is it
same
actual
simulation.
pendulums,
Okay,
or
I'll
is
find
it
a
just a
physical one then.
simulation?
Okay, I'll find a physical one. It'll demonstrate the exact same principle here.
I get what you're saying. Where eventually there'll be like a pattern, and they'll use the averages to create a similar behavior. And they'll say, well, the majority of the time we expect this, we expect that, yada yada, and it's all based on averages. I understand that, and they can simulate the typical behavior of it, but it not to the level of predictability.
No,
That's my
that's
whole point. And if you can't
But
predict
nobody's
it,
claiming we can
well,
do this forever, right? That we can't say that we can predict the
you
motion of the
can't do it
solar
for the
system
first
forever.
flip.
We can for solar system we can predict it for 3,000 years easy, right?
yeah.
Well, you have time gaps. You have time gaps in it.
No, you don't.
It
No,
drifts
it's
off, you
continuous.
stop it, and then you restart it.
But they have a continuous model of the solar system. There's no gaps in it. It's a continuous model.
Where's this one? For 1,000 years?
Yeah, VSOP 87 is good for several thousand years in both directions, and the newer solar system ephemeris are equally as good, but more precise at the same time.
And that's based on Newtonian mechanics.
As Newtonian and
No, you bet your ass it's not.
Newtonian and general relativity are involved in those simulations.
Well, then we're talking about different things here, guy.
No.
Why would you invoke relativity when we're talking about Newtonian mechanics and the three-body or
it's the n-body problem
is
still the
specific
n-body
to
problem.
Newtonian? The
No, it's
n-body
not.
is specific to Newtonian.
No, it's
Well,
a general
then you're just
problem
wrong.
for any physical system with multiple.
Yeah, based on Newtonian mechanics, guy.
So
no, there's more. No, you go.
Okay, all right. We'll
So
just pretend it's based on general
posted,
relativity.
I posted a simulation. I just posted a real physical video. So you said that you can't predict what's going to happen to the first flip. That's not always true. Sometimes you can.
No. You can't predict when the first flip is going to happen.
That is not true. In some cases you can't. In some cases you can. You can set it
That's
up.
what
so
I'm
that
saying. You can't. You can't do that. You can't say I can predict when the first flip's going to happen, and then say half the time I get it wrong. That's like saying, "Yo, I can predict. I can predict where this coin's going to flip, heads or tail," and then I'm right 50% of the time. It's like, come on, guy.
That's not what I meant. That's not what I meant. You're not understanding what I'm saying. What I mean is, if you adjust the lengths and masses of the double pendulum, you can adjust the degree of chaos of it. The degree of chaos of it.
Well, yeah, if you
is
modify it, I
how-
get it. If you make
right,
it, if
it's
you
how
change
many
the
swings
fulcrum
back and
or you
forth.
change the pivot point, yeah, you can make it so it can't even flip to begin with. Then you could predict it just won't flip.
That's not true. No, that's it. You're focused too much on the flip here. Okay. You release two double pendulums that are identical to each other side by side. They will swing back and forth together a certain number of times, doing all the same actions until at some point they desync from each other.
Yeah, that flip.
Right. It's not necessarily the first
that
flip.
first flip. That
It's
first
not
flip is where they
necessarily the first flip.
desync.
Nope.
Well,
it's not
typically it's
always
the first flip.
No, you're just thinking of some specific examples. What I'm saying is that if you play with the masses and the lengths of the pendulums, you can control how many swings they will have, how many flips they will have on average before they
Yeah, on
desync from each
average,
other.
dude. We're not talking about averages here. We're talking about, can you predict what this thing's going to do when you release it from this point at this time? Can you predict when its entirety, its movement for like what? Till the first time it does a little flip. Can you do that? The answer is no.
What I'm saying is that if you adjust what the masses are and what the lengths are, you can find combinations of masses and lengths in which it will behave consistently, not just through the first flip,
Yes, I
but
know. You can
for
bog
the
it
first
down.
10.
Yeah, you can bog it down, restrict its movement, and then predict its lack of movement. Yes. But I'm
It's
talking
not
about something that's
you're making
fluid
it an
here.
all no, you're making it an all or nothing. What I'm saying is that
No, it's
you
not
can
an
make it
all or nothing, guy.
so that it will go consistently through a certain number of flips before you can no longer predict what's going to happen. Okay? It's a spectrum. There is a spectrum of how predictable a double pendulum will be. There's a
Yeah,
spectrum of
if you
how
bog it
many
down and
flips.
you restrict its movement.
No, you're
If you make
saying
that
that
thing as balanced as you can, right? If balanced as you
nope, you're
can.
just not paying attention to
And
what I'm saying then.
I'm
Like
listening, but you're putting all these qualifiers in. I'm gonna modify this double pendulum to like make it unbalanced or imbalanced to the point where it's gonna do what I expect it to do because the weight distribution's all fucked up. That's all you're saying. I'm gonna fuck up the weight distribution and cause it to react a certain way to prevent it from having a free movement with
it's
proper
all free
balance. Well,
movement. It's
balance the
all free
thing,
movement. It's
let it
all free
spin,
movement.
and then predict
No,
it. And you're gonna be like, oh, I can't do
free
that.
movement. This is all free movement. It doesn't matter what the masses are. It's free movement. You
Yeah,
release
it does.
it.
It's
It is free
balance. The
movement.
balance guy.
No, it
We're
doesn't.
talking about the
That doesn't
balance
matter.
of it, and you're like, I'm gonna bog the bottom pot down.
It's free movement whether or not the two masses are the same mass, or one's twice as heavy as the other, or one's 3 times as heavy as the other. Okay, it's all free movement because it's freely swinging
Yeah, in
after
the
you
sense of
release
the
it.
joint,
Yes,
but not in the sense of the balance. You're restricting its movement through weight.
it's not a restriction. It just makes it more
Oh,
predictable.
so there's not more force acting on it?
Force isn't the same thing as a restriction. I mean, it's
Oh,
still
it's
free
not?
to swing. Yeah. I just wish that you'd actually watch the video that I showed, because what I showed was an animation of like 10 double pendulums that stay in sync for like 10 different flips before they desync from each other. I just think the concept of what I'm saying is getting completely lost here.
Yeah, and
That
what's the
it,
prediction on that? There is none.
so s- if it
That is my
consistently
point.
behaves this
And you
way,
tell
then
me
that's a
I'm like
prediction.
missing your point, yet you're missing my point.
So you can simulate it. You can make a simulation of a double pendulum that will
Of
track a
averages.
real that will track a real life double pendulum for some period of
Sure.
time.
Sure. All right,
That's
check
it.
this out, right? Say you took like a perfectly balanced pendulum. You dropped it from the same point 20 times in a row. Do you think it's going to
Mhm.
behave the same way every single time?
If these are double pendulums, uh, if you let them go back and forth for long enough, they will not behave the same way each time. But they
What about that
could
first
go.
flip? Do you think that
It's
first
not
flip's going to happen
right.
at the same time?
It could, depending on the weights. That's what I'm saying.
Do you,
Is that there are
do you think it's gonna?
combination.
Depending on the weights. Now the weights matter.
That's
Yeah,
what I've been saying the
exactly.
whole time. You're just not listening to me.
That's
That's what
what
I've
I've
been saying
been
the whole
pointing
time.
out. You're restricting its movement through weights to predict it. You're saying, I'm going to bog this thing down so it can't move freely because it's all imbalanced, and then I'm going to predict it. It's like, well, I'm
I don't
talking about
understand what the
something
point
that's
you're making.
balanced.
Okay, well, the solar system isn't balanced. The sun is not the same mass as the Earth. Like, the
Now we're
solar
back
system
onto
is
the solar
not.
system.
That was the point. I'm sorry that you're not seeing the connection between these two things here. If you make the masses of the double pendulum equal, then the chaos kicks in really rapidly, and it's hard to predict even the first flip. If there's a big difference in the masses
It's not
of
hard
things
to.
in
You
the
can't.
pendulum,
Don't say it's
no,
hard to. You
you
can't predict
you
it.
can
You can
you
guess.
you
If you can
can
predict it
predict.
once, you can predict it twice. If you can predict it twice, you could just keep predicting it.
Yep.
Okay, but you can't do that. So why are you saying it's hard to
Nope. You
predict?
can.
No, it can't be predicted.
Nope.
You can just guess.
It's not a guess.
Okay, then predict it. 10 times out of 10.
I will. I could show you a
Yeah.
setup of it.
Yeah, I would love to see you do that. Live stream it. I get a good chuckle out of that
Rigor.
one.
I almost brought my coworker in tonight. I was like, I kind of want you to see what's going on in here. Good thing I didn't. All you guys are doing is talking about swinging balls, just arguing again. He'd be like, "What the fuck am I listening to? Like, what?" I'm actually just happy I didn't bring him in.
What's
It
up,
is.
Beast?
I'll
They're
just say
trying to
about
wash
him.
away the end body
It-
problem
It is
and
not
act like,
true
it's not a problem. I
every
promise.
double pendulum is unpredictable at the first flip. You can set it up so that the double pendulum will be perfectly predictable for the first flip, the second flip, the third flip, the fourth flip. Eventually, it won't be predictable, but it's not true that it's immediately unpredictable.
He's easy.
Not if it's balanced. Only if you fucking bog it down and restrict its movement with weight.
Which is an
If you
accurate
balance it,
analogy.
if you balance it evenly, you're not predicting a damn thing.
You wait.
Well,
So
in the
you
solar
don't think
system,
the
it's not.
three-body problem is a problem, zzpop? What?
The three-body problem is not a problem for the solar system.
What? What are you talking about?
It is not a problem for the solar system, and I've been explaining this, and it seems to be going over. I think the whole pendulum thing was a complete waste.
It's going over your head, guy. You keep talking past the problem and say, if I modify this, I modify that, I create more influence here than there, and it's not a balanced system. Therefore,
I tried several times, but
Oh, wait. I got two questions for you. One, how is the solar system not like? What do you mean? How is it? What do you mean it's not affected by the three-body problem? And
So-
two, hold on. Second question: did you go by a different name? Because it kind of hit me the other day.
No,
where
I've
you
never had a
sound
different name. Nope.
okay. You sound like somebody that used to have like a dragon kind of avatar. I can't remember.
Nope,
Some
not
OG
me.
would know.
He sounds like Yasuke.
The
No.
n-body problem is chaos. Chaos means that if
You
you
changed the N, like the number. I mean,
N,
the
yes.
variable.
Instead of
Okay.
2, it could be 3, it could be 4, it could be 5, it could be n, it could be any number of bodies. That
Yeah,
any
even two
number.
bodies.
No, the two-body problem is 100% predictable, meaning that the orbits between any two things interacting with each other can just repeat on a completely predictable cycle forever.
why do you sneak that in though? 100%. No, it's either predictable or it's not, guy. Let's just leave it at
That's what I
that.
said.
Because I could flip a
you-
coin and be like, yeah, I'm 50% predictable.
Yeah,
Flip a coin.
you're gone. I'm sorry. You haven't followed me at all. So I'm going to try again with
No, you're
someone
just
here.
sneaking in. You're sneaking in words. That's all. You're
so
just trying to be sneaky here.
If you have two objects, they will form an orbit that will theoretically repeat forever. Okay, perfect cycles. That's what the theory says. If you have three objects, they will not produce any sort of perfect cycle of orbits. Okay? So no
Okay.
perfect cycle of orbits means that the system is not predictable. That into the far future, who knows what could happen? If you don't have stably, predictably repeating cycles, then eventually one might crash into another.
Then
So
you don't
what
have
the
a prediction. Yes,
right.
we get
So
it.
what the three-body problem is that the probability of a crash or something like that happening will go up.
It's crash
over
or
time.
expulsion. Yeah, it's
Right,
100%
the
crash or
probability-
expulsion.
Right. The probability of a crash or expulsion will keep climbing over time. However, this is the thing that not everyone here is getting. The rate at which it climbs is highly dependent on what the ratio of masses is between the three objects.
And the distance.
And their distances, yes. Because
Wait,
you can
how is the solar system? How is that not okay? Continue. Sorry.
Because he's acting like the
Not
sun's so
answering the
big,
question.
it stops all that.
No,
It's
it's
like,
not that
yeah,
it
okay,
stops.
guy.
It's not that it stops. But what can happen is that you can get something which are called pseudo cycles. Okay, a true cycle would be something that repeats perfectly every time. A pseudo cycle is something that almost looks like a cycle, but there's a slight deviation in it that accumulates over time. That like the objects are orbiting around each other, but they don't come back to exactly their original position after each cycle. Every
So what does
time
that
they
tell
go
you?
around,
That tells you
they
the
are
prediction was
slightly-
wrong. And you know that's not what's
No.
happening.
Um,
Let him finish.
yeah, so that is how you quantify chaos. So the quantification of chaos.
You're not
Hold on,
quantifying with
Here,
chaos.
let
the,
him at least finish.
He's
the
just sneaking in
definition.
so much shit. You're not
Let him finish,
quantifying
for
with
fuck's sake.
chaos,
You're being
guy.
impossible. You're being impossible, for fuck's sake. So
Well, you're being a weasel, guy. You're saying you quantify with
I'm gonna
chaos.
have
No,
to
you
shut you up.
don't.
You're. I think people are actually interested in what I mean by this, and you're not, and that's fine. But so something that has 0% chaos is something that would repeat the same cycle forever. And something that's 100% chaos will do no cycles. There will be no cyclic repetition of the behavior at all. But something that is in the middle, that is doing pseudo cycles, will have some number of cycles that repeat nearly the same before they eventually destabilize, before the slight drift, the slight shift from one cycle to the next accumulates enough to the
Hold on,
point
wait. Sorry.
that you get expulsion or that you get a collision, right?
Wouldn't that mean it's 100% then? No matter what? How do you have a
Wait.
percentage of chaos versus stability in
Is-
period?
As he's
Because
using chaos wrong.
well, the thing is, it's like if you have a chaotic system, okay, what are the odds of that? Initially stable system is what you're saying, and then something happens and an error accumulates over time, and then it
Right, the
becomes a
accumulation
chaotic
of error.
Okay, what are the odds of it after it becoming a chaotic system? Will it become stable again?
What are the
Never.
odds of it becoming stable
Never.
again?
Right. Yeah.
Ever,
That's not
ever,
true.
ever.
Chaotic things that are in chaos can then fall back into other stable patterns again. It's not
Yeah, that's
You're not going to be
ridiculous.
able to predict that. But the point of chaos is that anything that has most of the features of being a stable cycle will deteriorate eventually over time, but it could deteriorate very slowly. Like it could be a very slow deterioration. The amount of chaos is basically like for the orbit, right? If the orbit's perfectly
It's just
predictable,
probability,
then
right? It's
every
statistics.
orbit you come back to exactly the same starting place. And if there's a little chaos, it means every orbit you come back to slightly off from what your starting point had been for the last orbit. There is a
Yeah, but that's not how it
slight.
works.
What do you mean?
That's
Well,
not
I'm
how it
kind of
works.
confused. I'm kind of confused. So you're saying a small amount of chaos, but your explanation for this chaos, like for the double pendulum, for example, is like measurement error. So an error on the initial input, right? So that's not really chaos. It's just
Yeah,
there's
they're
stable
saying
interactions happening. It's just a measurement error. So it's not really
they
chaos.
use the word chaos to skirt around and like hide the fact that these are unobtainable measurements. Like that's what chaos literally means. It means there's measurements that need to be done, but we can't physically do them. So therefore, chaos, because there's variables we can't account for. And he just uses chaos as like some calculation. It's like what are you even talking about at that
But wait,
point?
what is
You're
it?
not
What is the
quantifying
crux of the
anything with
argument?
chaos, guy. It's not a formula.
But wait,
So
before this,
there's
what's
formulas for it.
is it?
Because you've got a range of uncertainty in your measurements of the initial positions, and you can compare that to the range of uncertainty in what the final positions will
Hey, you
be
call them averages.
after some amount of time. No, it's not an average. You're
Well,
talking
that's
about
how the math's
averaging.
done.
They say approximations, which is basically an average, dude.
Yeah.
Have either of the other two guys ever done this before? I suspect zzpop has actually
Have I looked
done
into
some of
this
this maths,
topic?
right?
Yes, very much so. Yes.
But have
And
you ever done it in practice, right?
I appeal to the guys with credentials on your side. They explain this to me, and I'm just
You're
going off of
appealing
what
to
they
your
have told me.
interpretation of this.
And they tell me like the 3-body problem or n-body problem cannot be solved, will not be solved. And there's so much more to it, and the benefits that they've learned from this being unsolvable. And I got guys in Discord sitting here telling me, "No, trust me, bro, we solved this."
I did
But you're
say we
not
solved
listening
it.
to
It's
what's
not.
being said, right?
Yeah.
No, wait, you're not saying we solved the 3-body problem.
No.
You're just saying it's not a
This-
problem for the solar
honestly,
system.
this
But
will be so clear for anyone who just looks at the video that
I
I
just want
shared on the double.
I did.
Yeah, so the point of these double pendulum videos is it shows a whole bunch of double pendulums stacked on top of each other, and they're in sync. They're as good as you can see with your eye. They're
But
in sync.
eventually
They're
they
doing
don't
all the
become.
same right, and then eventually they diverge from each other,
So
right?
that's what you're
So
claiming
you
the solar system is doing then by using that as a comparison. So what I'm trying to say is this idea that it's not a problem for the solar system is actually an incorrect statement. It is a problem.
no,
It's
but
only
what
a problem if you want to predict it infinitely into the
right,
future,
if you want
right?
to predict
No.
really
It's
far into
only
the
a
future.
problem if you want to make claims that this is reality and this is what's happening. Because once you say that, we're going to say, let's look at reality, put that first, and then put your theory second. And when
Yeah.
your theory doesn't match reality, we could be like, your theory's fucking wrong. You got a problem.
When
So you keep saying it's not a problem. I'm like, no, you actually do have a problem. You're like,
And,
it's not a problem. And I'm like,
and Rigor,
how do you not think it's a problem?
yeah, but Rigor, and just to be clear to both of you, it's the mass incorporation, right? Like where you're actually attributing mass to the celestial bodies, giving it
Yeah.
actual mass. That's
Yes.
what
It's
we're
the
talking about.
gravity. The
That's
gravity is what fucks everything up. And if they want to create a completely
Any force
predictable
would do
and
this.
stable system, they
not
just
necessarily.
manipulate the gravity along
You
No,
the
can do
this is
path.
generic
You can
forces.
do
No,
you
magnets
you can
have
do magnetism.
the three body problem exactly the same.
Yeah, but you can
But
have a repulsion and you can have attraction and repulsion in electromagnetism, right? You can have a
yes,
mass be extremely tiny but have a huge magnetic field around it. So there you can mess with those ratios, right? Like that is a problem for gravity though, with gravitation because
it's
no,
constant.
it's
the
still an
three body
n-body
problem.
problem, Beasticles. It's still an n-body problem. You've got the same thing you have to solve for.
Right, but you cannot solve it with only attraction is the point, which is mass attracting mass, which is why
No,
space-time curvature came into to being essentially because it's either the thing that is in question lengthening or shortening, or it's the field around it that is lengthening or shortening. That's how they do it. That's a Lorentz transformation in a nutshell.
I don't have time to get into all that, but I just want to say, some people found the idea of quantifying chaos to be absurd, but there was a really straightforward and simple explanation of it, which is that in these cases of the double pendulum, where like 1,000 identical double pendulum are in sync for a while, you could just count how many swings, how many flips until they diverge from each other, right? Do they all diverge and split from each other after one flip? Or can they do 100 flips before they split from each other? Like that is the measurement for how chaotic the system is.
Do you
How
describe the
long
chaos
it will.
theory?
Yeah, but the
You're a fan of it?
quantifying the chaos doesn't come before. It always comes after and says, "Oh, look, this is the amount of deviation that happened." So you're
Right.
saying I'm quantifying the chaos, not beforehand, not before the prediction. It's always after. You're like, "Oh, I failed miserably on my prediction. Let me quantify." And so you ain't quantifying the chaos. You're just saying, "What's the difference from my prediction to the observation?" And you call that quantifying chaos. Like, yeah, sure, okay,
It's an
fine. Call it
oxymoron, to
that.
be honest. If
No,
you
no, no.
quantify something, you're ordering it.
Or did I get it wrong?
These double pendulum. What these double pendulum videos are doing is they're doing a simulation of 1,000 identical double pendulums, and you're watching to see how long do all these simulations stay in sync with each other.
Yeah, I mean, it has nothing to do with reality, though.
Yeah,
No,
they
but
get
that
decently close when they insert large amounts of bias towards like one end of the pendulum.
right. Well, that was the
But the
other point I
second
was making.
second they balance that out, it's over.
It's
So
a
they
teeny
quantify how wrong they were in their prediction, and then they
Not
represent that,
beforehand.
or that's
Not
supposed to represent um, how
I don't
much
know.
they were off in measuring the initial conditions of
no,
the system.
no. You're
Yes.
completely confusing it. So the high mass pendulum scenario is just a different physical scenario. It has the same mathematical basis behind it.
Okay, but the cause
But
is a failure to measure properly the initial conditions of the system, whether that's like the object's mass or whatever is going on. It's an error in measurement, right?
So can I try and steelman zzpop's position?
Yeah.
So he's comparing so chaos is essentially describing the probability of something being predictable over time. And in the case of the solar system, we have a large dominant mass that essentially ensures that at least over observable periods of time, that we can provide a numerical solution to the n-body problem involved in the solar system, regardless of whether you use Newtonian physics or classical
Complete non sequitur, dude.
And then the
That's
pendulum
not a statement of
scenario.
zzpop. zzpop said it's not even a problem for the solar system. But
No,
yeah,
this is what
that's
I
not even
mean.
what I was asking
I meant on
anyway.
the human
I was
life
trying to
side.
clarify, like, so the failure, how off we are in our predictions, that's how we quantify chaos, and it just represents measurement error, pretty much, essentially.
So yeah, these are
That's what they
related
boil
ideas.
it down to. They say, "Oh, there must have been a measurement error."
Okay, so the better way of thinking about chaos is not measurement error, it's simulation stability. It is if you run identical versions of the same simulation, how long do those identical versions of the same simulation start off in sync before they eventually diverge and become different from each other? So
You're just changing what chaos
the
is.
more chaotic something is, the more precise your initial observations of the system need to be in order to make predictions go into the future. Like these are the same thing; these entail each other.
Right, but the cause is always attributed to measurement error. It's not attributed to the axioms of the system being incorrect or faulty, right? It's just the initial conditions. The system's highly sensitive to initial conditions.
Yes. Yes. So what it means for the system to be highly sensitive to initial conditions is yes, on the one hand, in the real physical world, if you want to predict it, the more sensitive it is to initial conditions, the more precise your initial measurements need to be. And an equivalent statement to that is that if you're running simulations in parallel to each other, the more sensitive they are to initial conditions, the quicker they will diverge from each other. Like these are the same idea
All
here.
right.
These are
So
both
nothing's wrong with the
manifestations.
axioms of the system, right?
Yeah, I didn't say anything was.
Right. Okay.
Isn't that what's called?
So
I'm
then
sorry.
what
Is
we're
that
quantifying is how off we are from our prediction, right? And that's it's just representing a measurement error.
It's honestly not useful at all
does
in
the starting
reality.
condition, is that
It
the
just
same as
always goes
what they
back to the
call
measurement, dude.
deterministic?
Always.
Hold on. Can you hear Stefan?
Yeah, but just you were talking about the starting condition. Is that what they call deterministic chaotic systems?
Initial
Yeah,
conditions.
that's retarded.
That's just like all the measurements, all the inputs into the system, and then you apply the axioms and you follow out the order of operations for the system to make predictions.
Deterministic chaos is an oxymoron, and it's
No, it's
illogical.
not. It's not. It's not. It's because the rules of the system can be deterministic. The chaos is sensitivity to initial conditions. That's the clearest way of saying
Measurement
it.
error.
Yeah. Well, it's sensitivity to measurement error in predictions. There's always going to be some amount of measurement error. The smaller you can make it, the more accurate your future predictions are. But the system itself has a sensitivity to those initial measurement errors, which
All right,
is
so there's no real chaos going on. We just can't measure the initial conditions properly to make correct predictions.
chaos.
Well, that's
is
what chaos means.
Yeah,
That's
it's
literally the definition of
future.
chaos. We can't measure what needs to be measured.
Well, chaos is how precise your measurements need to be in order to make predictions. Like the more chaotic it is, the faster you lose the ability to make predictions about it. Unless you go back and had a
The more
billion
what?
times better
The
measurement.
The more chaotic.
But that's
But it can
not.
never. You know what it can never be? It can never be an unknown variable, ever.
The thing
So,
is,
right?
I think you're using that term
Right?
incorrectly, ZZ Pop.
You
You're
can't
trying to
ever
say
have an
dynamic.
unknown variable affecting anything. Because if
it's
you
not
do find an
chaotic.
unknown variable, it throws chaos theory in the trash.
Okay. The chaos, it's not a feature, it's a feature of the physical thing. Like different physical things have different degrees of chaos. And the implication of something being more chaotic than something else means that it's less predictable, means that
Dude,
you
when you
need
use that
higher
word,
precision.
different degrees of chaos.
That's what
Yes,
yeah,
this is a
You know what that? You
completely
know what that's like saying? I have different degrees of measurements that I can't obtain.
no, that's you're confused as to what the word chaos means here.
No,
So why?
you
Hold
are.
on, wait.
I
Oh, wait.
No,
understand it very well.
no, you do not.
What's the okay? Wait, ZZ.
No, I don't. And what are you
Just
gonna
for
say chaos
clarification, come on,
means?
Rigor. Come on, bro.
It's like
Well, he's
he's
insulting
gonna.
me. I'm gonna get back. Yeah.
I just
People
want to
don't know
ask him a
things. It's
question.
not an insult.
Okay.
Yeah,
Can I
yeah.
ask
You're
something though? A
questioning my
clarifying
intelligence.
question.
Yeah. I'll just
Yeah.
do it right
ZZ.
back.
Yes.
Okay. What is the difference between chaos and uncertainties?
So you take
Is there a
measurements, there
difference?
is uncertainty in those measurements, right? You have an uncertainty about the measurement of the mass or the initial position or whatever of your object. And then you make a prediction about where the object will be at a future period of time. And your
Okay.
prediction has a range of uncertainty. So
How is
chaos
that
is
different than
the
chaos?
no. Chaos is the ratio between measurement uncertainty and prediction uncertainty. So a system is highly chaotic if a 1% uncertainty in the initial measurement leads to a 100% uncertainty in the final outcome. And a system is very non chaotic if a 1% uncertainty in the initial measurement only leads to a 2% uncertainty in the final outcome. It's about how much of an it's about how impactful your initial uncertainty is. It's about how much the initial uncertainty grows into a final uncertainty of the final prediction.
Wouldn't failed predict? Wouldn't failed predictions be how you get to your uncertainty level? Like, how would you have an uncertainty level without making
No,
failed
the
predictions?
uncertainty. So the uncertainty in your prediction is when you say like, I predict there will be this plus or minus that. So like, okay, let me think of an analogy of
So
like,
measurement error. That's what he was saying earlier. So it is a
well, there's
measurement
measurement error and there's prediction error. Okay, so like,
And how do you find that out? By the observation, realizing that it didn't match your prediction, and then you just go right back and say, well, that bit, we'll just say chaos. We'll just use the word
okay,
chaos instead of being
no.
honest and saying we can't measure it precisely enough.
No. So let me use an analogy with the stock market. Okay. Let's say I've got a theory and I think I can predict the value of the stock market in a year from now. And I predict that the stock market will go up 10% plus or minus 2%. I give a range of uncertainty in my prediction. That's what the prediction uncertainty is. It's me saying that I think that the value of the stock market will go up by this amount with this range of
Yeah, you get that afterwards though.
No. It's not something you get afterwards. It's part of the
you get
prediction
it
you make ahead
afterwards
of
through
time.
observation.
No.
Yes, and then you compare it and you say, moving forward, we know this is the level of uncertainty.
No, when
Because
you
this
make
is
a
what we expect.
prediction,
We expect this to move and deviate by
How's
X
that a
amount.
no? That's what you're saying.
when you make a prediction, you make your prediction with a degree of uncertainty. Like you do state that, like, because like you wouldn't predict something like 100% precisely because then you would never be right.
I would. If I let go of my mouse, it will hit my desk. I am 100% certain of that.
In how
Ready?
much time?
Listen. Boom, done.
No. That's
I'm
not a prediction.
100%
Give me
right.
how much time.
Prediction confirmed.
Oh my god, you're being so
gotta remember,
obnoxious.
can't
If a
be
I know I'm
doctor,
being obnoxious because you're double speaking.
no, I'm not. You just don't understand. I'm trying to teach you, but
Yeah,
you don't
right. I
No,
don't
no,
understand.
okay.
You're trying to teach me, but
We'll get
yet you're convoluting so much
Come on, maybe I
shit.
got
No, this is just your issue.
ZZ,
So
you
if a
said no.
doctor's
Hold on.
if a doctor's looking at a toddler
ZZ.
and says, "I predict that this toddler is going to grow
Get a bulldoze.
they're going to be this tall by the time they're 18,"
right? Is the doctor is going to give some like range of uncertainty there, you know? Like a doctor could be like, okay, these are the heights of the parents, and this is the height of the toddler at age 3. So I predict that the toddler will be 6 feet plus or minus 2 inches. Like, is this really such a hard concept here of
And then the
having a range of
doctor's going to
uncertainty
say
in the
this is
prediction?
height isn't something we can really predict. That's
Of
what the
course we
doctor's
can.
going to say. He's going to say we can't really predict it, but we can look at certain factors that affect height
Approximation.
and make a guess.
Right.
But
When you
often
make
it's completely wrong.
when you make a prediction and your prediction has a range, like I predict that this toddler,
Yeah, plus or
when
minus,
they're
we get it.
18, yeah, that is the range. Okay, good. So that's all I'm saying.
We've
Okay,
been getting it, dude.
But all that's done
okay. Well,
afterwards
no
by
one
comparing the result.
No, you make
Yeah.
the prediction
You just
clearly
say
not
no.
everyone's getting it.
But you quantify that. You quantify
Here,
the chaos factor by the experiment, by the observation,
No.
and you say no, we
CC,
don't.
you
We
say
actually
no,
factor
but
it.
you just said if
Fuck
I
outta here.
predict something a year from now, okay? Remember you were saying I have a range of uncertainty
Yes,
in my
the
prediction. Okay, now
Yes.
stop, pause. What he is saying is you don't know what the uncertainty is until it actually happens a year from now and say, huh, I was off by this much. That's how I know how chaotic I was in
No,
my prediction.
that's not what chaos means. So what you're talking
And what
about
does it
there is
mean,
the
dude? You're going all over the place.
inaccuracy. The chaos.
He's trying
I've
to put
said it.
chaos before
I've
everything and
said
act
it.
like it's
Chaos.
calculated before everything,
Chaos
which is
is
just not.
It is. Chaos is the ratio of the range of uncertainty in your prediction divided by the range of uncertainty in your initial measurements. That is what the
Determined by
definition.
trial and error.
No.
Oh well,
Okay,
then
how
you're
would
just
you
wrong.
determine
Of
it? Hold on, wait, pause.
model.
If that's a no, how do you determine it then?
It's a feature of the model. You determine it by running simulations, and you
Exactly.
see
Oh,
That's
stable the
trial and
now
error,
simulations are.
dude.
now
That's
it's by trial and error,
Hold on,
but
wait,
not
wait.
when I say it.
Simulations are trial and error, literally. You're simulating environment conditions. Like you're simulating something. That's
Yeah,
literally
no,
trial and error.
but not trial and error in the real world. Okay,
But now you're
like
trying to bring it to the real world. What?
no, I'm
We're
saying it's
trying to
not the
stick with
real
you
world.
and your simulations.
It's the
Dude,
simulations. Yes, the chaos is a feature of the simulation. Okay, if the simulations lead to wildly different results, then you say that the model is chaotic. And if the simulations all lead to the same result, then you say that the
Results.
model is
Right. But
not chaotic.
at the end of the day, you have a discrepancy, and that discrepancy dictates the level of chaos or the thing you want to refer to as chaos. Okay, no. Then how do you
That's not what
establish?
it is.
How do you establish that you were wrong?
You just said to yourself, you have to run simulations, look at the results before you assign a value to your uncertainty, right? You can't just
Yes,
assign uncertainty prior to it.
that's how you know what your predictive uncertainty is.
Right, so that's what we've been saying the whole
Through
time.
experimentation.
No, that's not what everyone's
That's what I
saying.
said.
People are all
By the
Yes,
end
you-
result.
Dude, I don't know if you understand what we're saying, but that's literally what we've been saying. I've agreed with Rigor and Locksmith, and then you've even agreed with us, and then say no, and then continue to describe something that isn't different than what we've been saying.
Chaos, it's not about if your prediction in the real world was true or false.
No one said that.
That's a statement. Well, some people are, but that would be about how accurate the model is. And then, of course, you can revise and say, okay, whether or not the model was accurate. Chaos is for a model. When you're running simulations, so using a model to make predictions, what the range of those predictions is, and more specifically, how big the range of predictions is, given how much range you put into the initial conditions.
Okay, let me try like this, right? So how would you ever know if your chaotic prediction was correct if you didn't test it?
No, you do test it, and then you find out if
then
your
guess
model's
what?
accurate or not. That's a
Then
separate
guess
step.
what? That's how you establish the fucking variables. Or no,
No.
the deviation.
That's trial and
It's
error.
through
Uncertainty value.
experimentation, guys. It's trial and error. I'm waiting for the example where you can predict the chaos before doing anything, and then confirm you were right about the chaotic interference or whatever, however the fuck you want to use the
No,
word.
you do
without
not,
ever
you do not
confirming it.
predict chaos. Okay.
But that's just what I
So you
said
don't put
earlier.
it
You
first.
run tests. You see how off you were from your predictions, right? You compare the results, just like you were saying, and then that is how you get your chaos value or your
You
uncertainty
don't
value,
predict chaos. He
which
said
which
it. You don't
is
predict
how you get the
chaos.
chaos
So if you don't
ratio.
predict chaos, you don't put chaos before the
Why are we?
experiment.
Okay, are we talking about a closed system?
I'm just talking about like a mathematical system and that's
A
Yes.
sensitive
closed
to
system, right?
Yes.
Deterministic.
yeah.
Yes. Chaos is a feature of a deterministic system.
Right. So how are you
and
saying? Okay, so here's my question: how is the solar system considered a closed system?
well, it's not, but you could treat it
It's
as
treated like
such.
one.
Yeah, because I mean, how much interference is it experiencing from the outside?
So you could treat
No,
the
you
Earth
have to treat it like one.
as a closed system as well, right?
You have
Like
to,
with
or it doesn't
like with
work.
like weather predictions, et cetera, et cetera.
I mean, it's receiving heat from the sun, so no.
So but that factor, that's nothing external. Like it's treating it as though the heat's already there. You know what I mean? There's no like
So
external factor. It's still a closed system. All right, the heat from the sun. That's the explanation of where this heat came from. But the heat is literally just a variable in a closed system. And just
well,
like
if
any
you if
other
you if you
prediction
include the whole thing, yeah. I
like
mean,
kinematic predictions or dynamic predictions or force prediction, whatever the case may be, you have to have an initial state, right? You have to have something to compare whatever you're looking at or observing or measuring to in order to know how much the thing moved, gained, lost, et cetera, et cetera. You need something to refer to, right? You would have to. And like what you're saying is this deterministic chaos theory, that's your reference point, right? It's like this is all the rules in this system, and let's see what happens. And you rub your hands together and you do it 20 more times and see where you went wrong.
I know what you mean by see where you went wrong.
In your prediction.
So, like, I think that there's two things getting conflated here. There is when you compare the real world to your prediction, and when you compare multiple runs of your prediction to each other. Because if your prediction is coming out of a simulation, the simulation could generate different results each time you run the simulation. So, what I've been saying, and I think some people get what I mean and some people don't, is that your prediction uncertainty, it's not the difference between the real world and your prediction, it's the range of predictions you've made. It is how big the range of predictions that came out of your simulation were. Like whether or not a given
You're
theory
not even saying
accurately
anything, dude.
models
You're not even
reality
saying
is,
anything anymore.
if you think I'm not saying anything, then that just means you're not paying any attention to
Well,
what I'm
kind of
saying.
like
I
it
am.
kind of
You're
sounds
just
like you're
avoiding
saying.
what B says. You
Kind of sounds
completely
like
avoid what B asks, and then you go on to some fucking rambling shit.
you're saying there's no actual chaos in the physical world. It's just part of a conceptual framework when you're
Yeah, I
working
mean
with
the
these
chaos
systems.
is right. The chaos is a feature of models we are using, and to the extent to which you would say it's part of the real world is if you think those models are reflective of reality, right? It's like
Sure.
the assessment you're making is you're saying that this model is chaotic, and then it's a separate question of okay, do I also have evidence that this model is a reflection of reality? And these are two separate questions.
Chaotic in relation to what? Reality. The
No,
behavior.
do people not understand why this is exhausting? Because I've been so clear here.
Well, then
The
you're just
key,
saying, oh, within this simulation that isn't accurate to reality, I have this
it could
non-factor
be. It
experiment
could
bullshit
be
math that
accurate to
nobody gives a
reality.
fuck about because
These
it
are
doesn't pertain to
completely different
reality in the
questions.
first place.
No, but
These are
hold on,
completely
CZ.
different
We're
questions.
talking about reality. You're talking about, I'm going to compare my
Yeah,
prediction to a
no,
simulation. That doesn't
get what you're-
represent reality.
Let me steel man him real quick. Let me steel man you real quick, zzpop. The problem is we care about reality, and what you're saying is two different things. You're saying you're comparing model to model to model to model, right? But in order to determine like which model is better than the other one,
No, not different models of each other. Runs of a simulation of the same model again and
okay,
again.
okay. Right. Okay. So then eventually you still have to compare
Yeah, and
your
yes,
runs
yes,
to
yeah,
reality.
reality. Yes, but that's not where you determine if something is chaotic. That's where you determine if it is accurate to reality. These are just completely logically distinct.
No, that's what you would call chaotic if it doesn't match reality.
No, you would just say it's inaccurate.
Well, no, you would call it chaotic because that's what you're doing with the
No.
fucking double
So
pendulum, and you're
obviously
doing it with the
people
cosmos.
don't understand so obviously some people here don't understand what I'm saying. What I'm saying is that accuracy versus inaccuracy is how well the simulation prediction matches reality. Chaos is how consistently the simulation prediction matches other runs of the simulation prediction.
That's not even, dude. That's just such bullshit.
What is bullshit? This is just definitional.
Well, I could just
So you-
well anybody could present a
Okay.
model and it could be it could fail
Yeah,
the
it could be-
simulation, 4 times out of 10, and you could just cough that up to it's a chaotic system, and we just don't have the instruments required to properly measure the initial conditions, right? And then
So
just
if
every
it,
system is valid at that point.
so right,
every
so
model is just a
if a
facsimile anyway.
simulation is so chaotic that it does completely different things every single time you run it, then there's no way to ever say that it's accurate.
Accurate to
Because
what?
it's to
Hold on, wait.
reality. To
Accurate.
reality.
Oh,
Okay,
now we're
we
back to
are
reality.
comparing it to
Before we were,
reality. You just said you don't have
before
to.
it was only
No, no.
chaos if it's a model. Oh,
Yes,
what happened
chaos is
there?
a feature. Chaos is a feature of the model, and then the
Not
model can be
just the
compared to
model.
reality.
Not just the model.
It's like a
I
mech
get-
suit.
I
You could
kinda
put
get what
any
you're
old.
saying, Z, but like, how useful is this? Honestly, like, it's not. Like,
What
you
do
can
you mean
compare
how
mod-
useful it is? Okay, so again, imagine this. You are trying to make a prediction about the future, like a prediction about weather or a prediction about the stock market, and you have a simulation. And you don't just make one prediction, you run the simulation
market,
1,000 times. Okay? Now, the simulation gives you different possible results, but it might very often give you a particular result, right? Your simulation could say that it predicts that the weather tomorrow will be 70 degrees, but sometimes the simulation jumps up to 80 degrees, sometimes it jumps down to 60 degrees, right? So the simulation has a median answer, an average answer that
Yeah.
it gives, and
100
then
runs,
it's got
you
a
get an average,
range.
you get an
Right,
approximation.
and then
Yes, we get that.
right,
Yeah.
and then it's got the range of uncertainty. Okay, and then tomorrow comes along and you check the weather, and now you see, is the real world weather the same as what the simulation's average prediction was? That's accuracy. Okay, so the accuracy is how well it matches reality. The chaos is how consistently the simulation was sticking to the same story when you ran it 1,000 times.
That's just stress testing. That's just like stress
Nah, I get
testing
what
your
he's
fucking
saying.
model. And you're
Yeah.
saying
Yeah.
like the chaos only applies to the model, but guess what? It doesn't. That's just you trying to say that. You're saying chaos is established only through the model. No, it's established through reality as well.
Okay,
It's
the
both.
reason that you
But just
no,
because
the
you want to say we only do it, we only refer to chaos in these models, like that's just not true, guy. No matter how many times you repeat yourself, no matter how many analogies you throw out there, it's just never going to be true.
the reason that we refer to chaos as a feature of the model, okay, is because if I am trying to predict the weather tomorrow, I could run 1,000,000 copies of the simulation that tries to predict the weather tomorrow. But when tomorrow rolls around, there's only one data point. I only get to do the
Okay.
experiment of checking the weather tomorrow a single time. So it doesn't
That's fine.
make sense.
I'm not saying you can't test it in a model. You're saying it can only be tested in a model. I'm saying no, chaos is tested real world and in the models.
Yeah, what's the difference
Don't
between
just apply it
backtesting?
to the model. It's because that's highly inaccurate and very misleading.
It's not
Well,
misleading because I don't get to run the experiment of what will be the temperature on August 26, 2026 more than once. I only ever get to run that experiment a singular time. There will only
Yet
ever
not
be
every
one data
experiment,
point.
every experiment with chaos, right, with a chaotic factor or a chaos factor needs 6-month window. Some you could just do like 100 in a row in a matter of 5 minutes. So why do I need a model for that? I don't. I could just test it in reality and compare it to that. And you're saying I can't do it. I have to build a simulation, create a model, but get all the averages and then compare the chaos to the average. Like, what the fuck you on about, guy?
No,
I
that's
just
what
built
you
What
do.
would
real
you
world
deduce from that
examples.
model?
Yeah,
So,
like
so if you did your 100, oh, sorry, you go.
like I don't understand what's so difficult about this concept. Like, take an election. The election's only going to happen a
You
single
applying
time.
it only
There
to a
will
model. That's the only difficult part here.
there will
You saying
there
I
will
can't apply it to real world and it's not applied to real world. That's the
so
problem. That's the point of
I,
contention. I
I'm gonna try.
disagree
I
that
got to
it's
go to bed, but I'm just
exclusive
gonna
to
try
the model.
one last time to get
well,
this
the date
idea.
isn't the date isn't necessarily like a key
No,
value.
it
Really, it's
very
just like the conditions of the system are the key values, right? So
no,
it's not
it very often
variability.
is. Like, think of like think of sports game prediction or like election prediction. You're trying to predict the outcome of an event that's only ever going to happen a single time. Okay. The event itself in reality will only ever happen one singular time. Okay.
No,
In
we're
that
applying a
case, yes, you would use
deterministic
a model.
system to a set of initial values, right? So there's no real difference between back testing, via
Trial and
simulation,
error.
a thousand simulations, or just, back testing over 1,000 days and recording results.
Here's the thing, zzpop. You could reverse it if it was actually useful, right? You could basically say that because of these weather conditions or whatever conditions, whatever system you're talking about, a closed system, because of these conditions, this will happen in the future. Period.
Mhm.
Like, that's it. If you're wrong, your model is wrong.
Yeah, you could probably potentially work out some stuff. Most definitely, you could use a model based on some of your predictions, and you could be like, "Let me create this model. I'll build this environment, put all the known variables into play, and then just run it over and over and over and over. Take the average and play around and be like, well, this is my expected outcome." But you'll never figure out the chaotic nature of that system until you compare it to reality.
Yeah, you
At the
have
end
to.
of
Then
the
you've
day, no
just
matter
not
what, you're
understood.
gonna need reality to something to happen in reality to see how far you deviated from that thing in reality.
Nope, that's
Then
you've
you're
just
not
you're
comparing it to reality.
yeah, I mean, you're just persistently not paying attention to the distinction between
That's
chaos
not
and
a
accuracy.
response. That's just no, I don't want to respond to what you're saying.
No, I've explained this so many times. I don't know why you're not understanding it. I'll try
But
one more
at
time
the end of
and
the day, what do? You talk about something that happens in reality, and then you skip the part where you compare all your
I
math
haven't no, I
and all your
haven't skipped it.
predictions
I
to
haven't
that
skipped
point
anything.
to confirm your chaos.
Well, I think I
No,
got it.
that's
Chaos is when you're wrong
chaos.
in the simulation. Accuracy is when you're wrong in the real world.
It's not wrong. It's just variance in the simulation. Like,
Oh.
let me can I just use
I,
the example of the recent
The
election, right?
prediction's
Okay.
not wrong. It just wasn't accurate.
Everyone
Varied.
oh my god, is it crazy. Everyone was trying to predict the Trump versus Kamala election, right? And people were running simulations on their computers of what was going to happen. So somebody might run a simulation a million times, and if the simulation always came up Kamala or always came up Trump, then that is not a chaotic simulation because the simulation is delivering the same answer every time. If the simulation is coming up with Trump half the time and Kamala half the time, then it's a highly chaotic simulation because it's coming up
Okay,
with
okay.
different
Oh, wow,
answers.
wow, big
And that's
deal. You establish
completely
chaos or no
right.
chaos.
Right. And it's
Wow,
that's a
okay.
feature of
It's
the
yeah,
model. And then
yeah.
the
But we're talking about
accuracy. is a different idea. The accuracy is whether or not
He's just
the
playing
Bro,
a
but you
result.
have no idea. You have no idea how what that model means nothing. Nothing until that vote happens and you get the results. That
he's making a
model is like a little
semantic argument
fucking
against you, dude.
fantasy land thing you're doing in your brain and pertains to absolutely nothing in real world
You've
until
contributed so
someone
much to
gets a.
this. Thank you.
I
Very
have.
productive
I know I
comment.
have.
Yeah,
You can
that's
stay
wonderful.
mad. I don't
Anyway,
care.
I think that
You double
others have
speak your way through
understood.
this.
Oh, you're great. Anyway, I think that others have understood the idea here that a model that 80% of the time predicted Trump would win and a model that 70% of the time predicted Trump would win were both accurate models, but one of them was more chaotic than the other. The accuracy is whether or not the dominant result, the most common result coming out of the simulation, matches reality. The chaos is how much variance there is within the model itself, of how big the spread of simulation results were between different possible outcomes. So these are just simply two different variables. Chaos and accuracy are just
What if it has
distinctly
the same
different
outcome
ideas.
over and over and over and over again?
The
Would you
level
consider
of
that to be
convolution.
0% chaos?
Yes, if the outcome is exactly the same every time, it's 0% chaos. Exactly.
And then would you consider that model to be accurate to reality? If
It's not
if it matches
0%, it's
reality, then it would be
deterministic,
accurate.
guy.
You just
It's just
shush.
deterministic. Don't
Yes.
shush me,
So,
you little fucking
so
bitch. It's a
a
deterministic. You're saying if it's deterministic, it has no chaos.
an election prediction
You're like,
model
oh, it has zero
that
chaos.
100% of the time output that Trump would win is accurate and not chaotic. And one that 100% of the time output that Kamala would win is inaccurate and also not chaotic. And one that predicted
Right.
Trump would
I get
win
what you're saying.
60% of the time is accurate and
You see what I'm saying?
chaotic. Yeah, it's just.
Oh, wait. Rigor, you see what he's saying, though?
Yeah,
No,
but
we're
it
not.
has nothing to do with the convo at large. Nothing. It's
I
just a complete, hey,
agree.
this is chaos. It has nothing to do with what we're talking about. He just went on a complete non sequitur, started talking about
He made
like
a
fact
semantic
is, oh, I
argument
could
against you the
pigeonhole
whole
some
time,
chaos.
yeah.
It's not
I could just
semantical
talk about
argument.
chaos within
I
this
needed to
non-factor
I need to
model.
clarify what I meant, because now when it comes to the n-body simulation, different n-body simulations have different degrees of chaos. So all 3-body or above simulations are chaotic, meaning that if you run multiple copies of a 3-body simulation, you will get different outcomes between the multiple copies of the simulation, but they are not all equally chaotic to each other. Okay, depending on what the masses of the
Who is
3
saying
objects
that they
are.
are? Like who you
Depending
arguing with, guy?
depending
We're
on
talking
depending
about
on
reality. You're talking about models and comparing models to
right.
models.
So
We're comparing
depending
fucking models to reality.
okay.
And you're
So
getting like you're going down these fucking rabbit holes of
no,
nonsense
you're
to
not
avoid
following. You're not following. I'm sorry, you're
the
not
main
following.
point of
So
fucking contention here.
So if you run a 3-body simulation and the 3 planets all have the same amount of mass, those will be highly chaotic simulations, meaning that as you repeatedly run the simulation, you will get completely different results every time. However, if one of the masses is much, 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 much bigger than the other two, then you will get a very low amount of chaos. And what that means is that 99% of the simulations will turn out identical to each other.
That's
They
not
will
even
be the
true.
same as each other.
That's not even true. You're just lying. A very low, maybe initially, but that chaos is going to grow within that system until you hit 100% certainty where they collide or get expelled.
Right, but you can
So what the
track
fuck
how
are you even saying, guy?
What if
You
you
just
add
snuck
in the
that in. Like one's going to have a low amount of chaos. No, they're both going to hit 100%,
no, but
guy.
you can no,
Be
but
honest about it.
if you add in
One
secular
might hit 100%
frequencies,
faster, but guess what?
yeah, well, that's the relevant measure because it's you're running the simulation for a fixed period of time. That's another variable here. So, like one of the variables is the masses of the planets within the simulation, and another variable is how long you run the simulation for. It is true that if you run the simulations for longer, the chaos will always go up. Okay, so the longer the simulation's running for, the greater the chaos will be. But there are
I just said
plenty
that,
of
dude. I just
yes.
fucking said that. I don't know
Anyway,
why you're
but
repeating it.
what if you
Like
then
you're
add
arguing with me,
in
but you're repeating what I said.
What if you then add in the secular frequency in the orbits, in the three-body problem?
Secular frequency?
Like pulsate it? You're saying like
No,
manipulate it?
No.
What would the frequency be if not variables?
Well, it's time steps and so on and so forth. It seems to, well,
Well,
I just
yeah.
have a quick glance at it, and it seems that it doesn't make it completely correct, but it makes the prediction much more accurate.
Well, if you manipulate time, you're saying? Well, yeah, of course. You can manipulate time and do whatever you want with it, right? You can freeze
It
it
has
and
to
then
do with time steps.
Yeah, you say within this little window, I was good, match my prediction, then reset it, right? Act like whatever, it didn't continue on, just reset it and go and be like, well, it worked for another. And then if it doesn't, ignore it, reset it back, and then just do like little time sections. Yeah, that's how you get your stable model. And that's the only way to do it. You got to manipulate something. You go back in time, skip periods of time. You take time chunks and like, weave them together. That's how it's done.
All right. All three body systems have some degree of chaos, but some have very low chaos, meaning that you could run 1,000,000 initially identical copies of those simulations for a prolonged period of time and watch thousands of nearly identical orbital cycles go by before any noticeable difference between the simulations begins to appear.
Yeah, I haven't seen one of those. I've heard people talk about them, but I've never seen one of those.
Yeah,
I've just heard so
well,
many
next
claims
time I'll show
about
you
this.
some.
This is done. This is like they do this all the time. There's so many, and it's like, yeah, I've yet to see one. The most popular ones online don't do that. They put disclaimers in how they get it stable.
All right, I'm going to go to sleep now.
Well, every time chaos comes up, it's always doublespeak. Acting like it's not being compared to something, dude. Then how do you know it's chaotic? Like, what the fuck are you on about?
Yeah, what's the point of it if it's just a label?
And when you run you talked, Rigor, about an experiment before you do something 100 times in reality. How are you determining whether or not that is chaotic? What is it you're doing? What are you measuring? What are you testing the outcome against if you don't have a
Come in
model?
that good. I didn't hear like the whole beginning of what you said.
Sorry about that. So can you hear me now?
Yeah, a little bit better. Go ahead. I turned you up a bunch.
So when you have you talked before about running an experiment 100 times to determine whether or not a system was chaotic. What are you looking at in that experiment?
Well, I
And
look
how
at
are
it
you
like this.
determining?
I look
So
at
you're
it
going
like
to have a
this.
model, right? You need a model to say that, yes, this is what we predict.
I wouldn't say you need the model. You don't need the model. You don't need the model if you say the math, sure, right? But I don't think you need the simulation to, like say I said, all right, I don't think you need the simulation first. I think you could do it. There will be many cases in which you could just say, this is my prediction. When the pendulum swings to the highest peak or the apex, I will just say, I predict it to flip right at that point, and I could just observe it. I could be like, well, it didn't do it that time. Now I can adjust it, so let it drop from a different point, and then see if there's anywhere I could put this to make it flip there. Right? I could do something like that. I could be like, well, is there a way to accomplish this? And I can make a bunch of predictions on it. I don't need to create a model or a simulation to do that. It's like a theory. I don't need to
By
go to a model
predicting,
for a theory if I can demonstrate it in real life. I just
but
demonstrate it in real life.
by predicting something, you inherently create a model, right?
Well,
Yeah,
I
but
mean, that's a little
ZB
bit.
told
That's a
us.
bit. It
Well,
feels
ZZ told
convoluted
us
when you say
chaos
that.
is just a different label for when you're dealing with simulations. The failed predictions, he called them variations of the simulation, right? That's all that chaos is when you're dealing with simulation. If you're doing real world tests, it would just be failed predictions, accuracy of the model or predictions.
Yeah, it's like, what would be more valuable? Creating a model, creating a simulation, and doing all this stuff within that, when you could just go to reality, that's something like a simple little setup, and just test it one for one. Like right there, skip that whole step of the model. You just don't need it. You don't always need it. Sometimes it will be highly beneficial to use a model. I agree.
But if you're looking at any natural system, right, what does your prediction mean if you don't have a model? You can't predict
Well, you
anything
would.
without.
I
Your
would
theory
like,
is a model, right?
but I could make the prediction, right? And I can see that it's
Based on
wrong.
what? Based on what? What are you
Like based
predicting?
on math,
Logic,
based
Okay,
on a
so
math.
theory, just based
you've
on a
got a
theory.
model.
Like
So you have a
here,
model.
I'll give you an example, right? I take this little double pendulum. I say if I hold it up 3 inches, let it swing, I predict, for whatever reason, my hypothesis is when it hits the apex, it's going to do a little flip, right? I could just think that in my brain for whatever reason based on nothing, and I could test that in real time, in real life. I don't need a
Yeah, you
model. I
don't
don't
need a
have to create an
computer.
entire model for that. And I can
You
find
don't
out
need a
I'm just
computer
completely wrong.
simulator.
Like I'd be like,
And
I'm just wrong. Every prediction I made is wrong, and I never made a model. I just did it. And then if it is right, I'm going to be like, holy shit, why is this right? I'll write down, I'll know how I did things to repeat it, and then be like, all right, see if I can build a formula based on this, and then create a model and see if that model matches the observation.
Yeah. And I mean, they were testing models way before they had computer simulators, so you don't need a computer simulator to test a model or a system.
yeah, but all models are going to have this behavior. Right? It's not just restricted to computer simulation.
I'm sorry?
That a model, if a model has some non-linearity or something like that, its outcome may not be deterministic. So, like in real life, you might find that your system is very sensitive, which is what I think zzpop was trying to say, that in real life you might have some real life process that a small variation to the initial conditions results in a big variation in real life, right? And that's what he was trying to talk about. He talked
Well,
about
it's a
chaotic
Yeah,
system.
deterministic system, though.
but that's the point where I say, if it's that sensitive, your prediction's probably wrong. You might just be either missing a variable there, or you just got the math wrong.
So what if it's
And you're
not
like, but
sensitive?
no, I don't want to give up the math. So what I'm going to do is insert chaos and make claims to impossible measurements or unobtainable measurements. It's like, yeah,
What
there's
if your
some
system
validity
is
to that,
stable?
but I think it's just taken way too far and used as a crutch or a fix, a band-aid type thing.
If it's not sensitive to initial conditions, then it's just wrong. Because we have a supposedly deterministic system. The only explanation provided is that it's highly sensitive to the initial conditions.
What system you're talking about here? Anything just in general? Or?
Well, if it's not the initial conditions and the measurement errors, then the axioms of the system and assumptions are wrong.
Or it's just limited, right? They could be, it's like you're on the right track. You got a lot right. There's a ton of utility in going along with this. But to say this is the absolute truth of how things work, I'm going to be like, well, You definitely ain't got it figured out. You either got it figured out and there's unobtainable measurements, or you got something wrong and you missed the variable, or some of the math is off somewhere. We need to look at it a different way, potentially. Don't know.
What if it's never right? What if your prediction is never correct? Ever?
Never
Yeah.
ever correct. It's not a prediction.
Okay.
It's just
So
a
we have a lot of
guess.
models here that have no predictive value, right?
Yeah, I got a whole lot.
Flat Earth is one, 0 predictive value there. Right? Doesn't have any
Flat Earth, globe,
any
name
utility.
it. Concave, convex, donut, any shape you want. They got a lot of holes. Every model has holes in it. We could play pretend like they don't, but they all do.
Yeah. I
So
think
what does that
nobody.
tell me? None of them represent reality.
Well, will we ever? But you're saying we can never represent reality, right?
No, it's not what I said. That's you
No, it
strawmanning
is.
me. I said the
No,
current
that's
models
exactly what
we
you said.
have. I said the current, what we have now. I'm not saying we will never know, or we can never know. Just saying what we have now, they all got holes in them. We don't have all the answers, so like, why are we pretending like we do?
Will we ever know all the answers? I don't think we will. We'll know some, right?
Well, it depends
Without
what
a
it
doubt.
is.
And like the shape of the Earth is something we can know.
Yeah, yeah. If I could go up and I could like get that third person view, I'd come back down and I'd tell you.
You don't need to know.
Wait, don't
Or I could
Globers
just
say you
trust
can't be
people.
certain about anything? You can't even be certain water exists?
No, that's not what they say at all. Because ultimately, this conversation is about rejecting huge body of science because it doesn't predict everything perfectly all the time.
Well, what do they use
Oh,
chaos?
that's a
What
straw
do they
man.
like? What do they use chaos theory to explain? Do they like theorize or speculate?
A
You know,
lot in physics. A whole shitload in physics.
they use it for like
What's
every like failed prediction is chaos.
shit, I don't know. But it's like basically these highly complex systems all have chaos, a variable. They throw in like, oh, there's a little bit of chaos. It's a little bit chaotic. The more complex it gets, the more chaotic it can potentially get. From what I've read about it.
And what was your definition of chaos again?
Unpredictable. Yeah.
My definition of chaos is simple: unobtainable measurements. I'll simplify it. It's about as simple as I can put it. Unobtainable measurements.
Failed predictions, unobtainable initial measurements.
Yeah, because it's like the starting conditions need to be so precise that just being like a thousandth or like 20 decimal points to the right off on your measurement could lead to catastrophic failure. It's like, well, if that's the case and we can't get those 20 decimal points, then what does that mean? It's a measurement we can't obtain.
What about ones that we can obtain?
Then it's deterministic.
But what if we can obtain it, but there's still uncertainty in the outcome?
Then you didn't obtain it. Because you just call it chaotic. You just
Is it
call it a
because of the
chaotic
model?
system. If it's
Is it
not
because of the
chaotic, it's
model?
deterministic.
I think there'd be
That's
very
basically
few
how it
true
works.
deterministic systems, right, in that situation.
Yeah, a deterministic system will always be predictable. That's just kind of the way it works. In a
By
chaotic
definition.
system, yeah, in a chaotic system will
I
just
can't
have.
take it anymore. I've got to. If zzpop's not
Sure.
here, let me just try my own take on it. It'll be very simple. Chaos is a property of fully deterministic systems, systems for which the motion is entirely determined by the laws that govern it. Some
Entirely.
systems left entirely determined with no
There's your doublespeak.
randomness.
So supposedly
So
determined.
and the simplest example
That's
I've
begging
put.
the question.
Let me. Well, I'm not going to Rigor.
It can't.
You can interrupt me as well. I'm just going to get out a couple things, and then you can go on with your nonsense, your arrogant ignorance.
Oh, you poor thing.
A deterministic system can't have any chaos by definition.
Deterministic chaos is the thing we're talking about here. The only interesting
No, we're
thing
not.
about chaos is the chaos that occurs in deterministic systems, systems for which the motion of a system is entirely determined for all time with no randomness by the laws that govern it.
Right.
Now
So you
that
just convoluted deterministic and chaotic. That's all you did there.
so
You tried to
and
sneak it in. You
and the
say
good
deterministic
example,
chaos. Oh, you're
the
not done? You still
example.
not done? Go ahead.
No, I'm just not going to respond to your arrogant ignorance. If you don't want to hear
You just
me, I'll
what are you
stop talking.
ultimately saying? What are you ultimately saying? We can
So,
predict that this isn't predictable. Wow.
so
Yeah,
the
a
best.
deterministic system by definition is predictable, right?
That's
A
right. So
chaotic deterministic system is an oxymoron.
the best example of it of deterministic chaos is the double pendulum, and I put a video and a link to a place where you can make your own simulations. In this case, it takes 8 double pendulums, all set to almost exactly the same initial. Basically, well, you can set it to any angles you want. And then you release them. They're set to almost exactly the same initial condition. And if those conditions are such that the pendulums aren't held out very far, if they're like 20 degrees or 30 degrees from vertical, then you don't get chaos. The pendulums, they're different because they started differently, but they don't diverge into what's called deterministic chaos. The video that I put shows an example where they do diverge into deterministic chaos. You start them all at unidentifiably different initial conditions. They're conditions that you would never, if you actually did the experiment, you would never be able to do it twice with exactly the same initial conditions. And for that reason, you're guaranteed that down the line, the motion each time will be entirely different after some time, depending on how different the initial conditions are. And that's what's called deterministic chaos.
What deterministic chaos is saying the only thing we can predict is that this will be unpredictable.
No, it's
That's
not
what
just that.
deterministic chaos means. You can convolute as much as you want, try and sneak the word deterministic in there and act like you're saying something else. But that's the definition of deterministic chaos. We can predict that this will be unpredictable.
That's not the definition. The definition of deterministic chaos is a system, a dynamical system whose motion is entirely determined for all time with no randomness, but that displays extreme sensitivity to initial conditions. That's it.
No
That's
randomness. So
deterministic
why is there
chaos.
That is correct.
variation? Why is
What
there
Super John is
variation?
saying is 100% correct, by the way.
Well, I mean, if it's deterministic, that means, deterministic by definition, you'd be able to predict it, right?
No.
But he's saying what I
No,
said.
not necessarily.
Yeah.
It just
Okay,
means
so
that
then
there's
it's
no
not
stochastic
deterministic.
element in the system. Being
No,
chaotic doesn't necessarily mean that the system needs to be stochastic. There's a difference. Deterministic
Yeah.
systems can still be chaotic.
That's right. You can't predict it only because you can't predict the motion in a real experiment because you can't set the initial conditions to
So then it's
infinite
not
precision.
deterministic.
Right,
It's
there we go.
deterministic.
Infinite precision, unobtainable measurements once again.
Just because you can't set the system to infinite precision has nothing to do with the fact that when you let the system go, its motion is entirely determined for all time with no randomness by the laws that govern it.
Bro, zzpop already let the cat out of the bag. You have to run simulations, look at the results of the simulations, see how many times your predictions varied from the results, right? To get your
No,
uncertainty factor.
zzpop was
From
wrong
there,
about
you
that.
get your chaos ratio, and that's how much chaos the system
No,
has, right?
zzpop
That's how you
was wrong
determine if
about
it's
that. And I'm
which
sorry,
part
he was
exactly was he
wrong
wrong about.
about that. He,
So
he
how
was
do you
wrong
determine
in
your
talk.
uncertainty? Wait, how do you determine your uncertainty value?
So he was wrong in talking about systems as being described by some percentage chaotic. A system is either chaotic or it isn't. There's no percentage chaos, and you don't run
Yeah,
it
yeah,
Well, that
yeah.
wasn't
through
my
You didn't
question.
as
under
a
see
function.
if you think that, you misunderstood exactly what he was talking about.
No, I
You
didn't.
missing his point
No,
because you're arguing a straw
I've
man right now.
worked in deterministic chaos.
You're arguing a
I
straw
don't
man to
think
ZZ
ZZ Pop
Pop's
has.
position.
Yeah, buddy, that's not exactly what I asked you, right? I was asking you, how do we determine this uncertainty value? Because if there's no uncertainty
There's
value,
a
it's not a chaotic
very
system, right?
look up.
We to classify it as a chaotic system, we have to determine the uncertainty value. How
So
we do
let me.
that is by running simulations, looking at the results, and seeing how, how often we varied from our predictions, right? That's how we got the uncertainty value. That's how we got the chaos ratio. That's how we classify it as a chaotic system.
No, that's not the definition of a chaos. There's
I
a
didn't,
difference
I didn't, that
between
wasn't a definition. You're right. That was
there's
a
a
function of a chaotic system and how we
there's a
determine the uncertainty value and how we get to the chaotic
uncertainty and
system
chaos
classification.
are two very different things. You can have uncertainty has nothing to do with chaos. Chaos, by definition, is just you can have a chaotic system as long as uh, like like a saddle point is a chaotic system because any deviation from that point means that you're going to go either up or down a hill.
It's a horrible
Uncertainty,
definition, bro.
Yeah,
I use the
uncertainty.
examples. I use the example of shooting marbles through a. Just imagine having a horizontal surface with a bunch of dimples, a bunch of bumps on it, and you shoot marbles through this surface. Each marble's gonna hit like 100 bumps on its way through, and you try to shoot two marbles in a row that follow the same path. You won't be able to do that. The reason you won't be able to do that is because the dynamics of that system is chaotic. It's an example of what's called Hamiltonian
no,
chaos.
because you can't measure precisely enough to hit it in the exact
Exactly.
same position with the exact same inertia, right?
Exactly.
So, right, so
Exactly.
it's a problem of the initial conditions, right?
Right.
Not any amount of chaos, right?
No,
So you're saying what
no,
we're
no,
saying.
no. I'm sorry. It's not because there are other surfaces you could shoot that marble through, like a gully, in which it wouldn't matter how bad your aim was, the marble would follow the same path.
But if you
So
shoot it
No, it
the
wouldn't.
exact same,
No, it fucking wouldn't. It would
not the
not.
same
It would
path,
not
right? Not the
deflect at every point. You just make
it
shit up,
wouldn't
guy. You just
it wouldn't
lie
turn
and lie and
into
lie and
oh
try and
Jesus.
sneak all
It
kinds of.
wouldn't
See, this
turn
is why we don't get
into
along because you do things like this.
no, we don't get along because of your arrogant
No,
ignorance.
mostly because you're monologuing, you're double speaking, and you're intentionally misleading people. Because you
So the
just tried to
difference
sneak something through. I call you on it, and you're like, "Oh, I got caught. I'll concede now."
the difference between the gully and the hilly, the bumpy surface is that in the gully case, the motion does not diverge exponentially from the initial thing. In the bumpy case, the further you go through that bump, the more the less uh, the less certain you can be about the previous marble following the other one. Like it's like with
Difficult.
Yeah,
double
but you're not
pendulum
arguing
too.
with anybody, dude. You're just saying what fucking Locksmith just said.
Yeah.
Long-winded
No,
version.
no, I'm not. The
I got a
difference is
question
it's
though.
not
Wait,
about
can
it's
you have
not
a chaotic
just
system that makes only correct predictions? Or
no.
is it
Well,
it's defined by its
I don't know what you
unpredictability?
mean.
You need
You
failed predictions to
can't.
have a chaotic system, or else it wouldn't be
No,
chaotic.
it's not about failed predictions. The point is a chaotic system is a system for which even the most infinitesimally different initial push, initial placement, initial conditions, we
You're
call
repeating
them,
yourself.
even the most even infinitesimal difference will lead to completely different trajectories down the
Right,
line.
so
That's
unobtainable
not the
measurements.
case.
We've covered
So
this.
it's just what I said. I mean,
I
if you're
know 4
satisfied with
times.
it,
4
okay.
times already, guy. We don't need to hear you repeat yourself like 4 times in a row. We already covered the unobtainable measurements.
You can definitely obtain measurements in a chaotic system. That makes zero sense. Just because a
But
system is
not
just
to the
because
level of precision that's needed.
that you can apply that for non-chaotic systems too. What you're
You
saying
don't see
applies to
how
non-chaotic systems as much as chaotic. The only difference between a chaotic and non-chaotic system is just how sensitive you are to just the initial conditions. It's like
That's
you
right.
could
No.
have you could
It's
let me finish. You
that's
could
what we're
have
saying now.
you could have a pendulum that is within plus or minus 20 degrees that's not near the top, and that's not a chaotic system. You still don't have infinite precision. There's no the idea of a chaotic system and the idea of uncertainty are two very different things. You're not going to have
okay. I'm
infinite
not
certainty.
arguing against that. I'm saying that your initial conditions need to be so precise to the point that you can't obtain them, because those variables, starting conditions, are so impactful that it could become catastrophic.
In
And
real
obtain
life,
them in what
yes.
sense? I mean,
Okay,
once
that's what I'm
again,
saying.
let's just be sure we understand. The only point here is what's a chaotic system. Chaotic system is like any other system, one that is completely determined for all time by the laws that govern it.
We're
And
having
that
we're
in
having
And
an
the
like the
and
initial
same
that let me
conditions.
conversation we
finish.
just
Let me
had with like a
finish.
lower version
Just
of
like
like
every
somebody
other
talking
That's
about it.
system.
where it diverts from typical
Jesus
deterministic
Christ.
systems. It's just not governed by its axioms and its rules, right? It's
Jesus
governed by its initial
fucking
conditions
Christ.
and its
Let me
sensitivity to the
finish.
initial conditions. So you're wrong there. You keep trying to conflate deterministic
Jesus fucking
systems and
Christ.
chaotic
Let
systems,
me
but they're clearly an
finish.
oxymoron.
Okay.
You're looping, brother. You've been looping
I'm
for
gonna
like 20 minutes.
start. This is very simple. The only difference between a chaotic dynamical system and a non-chaotic dynamical system is sensitive dependence on initial
That's
Bro,
what
this
conditions.
we
is the fifth
said.
time. Fifth time. You think
Both
you're arguing with us? You think you're arguing with us? You present it like you're arguing with us,
both
but you're
are
saying what we're saying.
both
Right.
Why do you
are
keep repeating us?
both
You did it
are
5 times now,
both
dude.
And we had
that's
to
the
argue
thing
with you
you
to get to
keep
this level
the
that we're
thing
at right
you
now. You
keep
wouldn't even concede that
saying
they're sensitive to the
the
initial
thing
conditions. You were
you
just
keep
completely
wanting to
deterministic.
be true. It's the deterministic part. It's a system for which the motion is completely determined for all time with no randomness.
Yeah, you're holding to your axioms. You're getting failed predictions. You're saying there's nothing wrong with our axioms. There must be something wrong with the initial values that we've provided into the system, the initial conditions.
Pretty
Yeah,
Yeah.
much.
from my understanding, deterministic chaos is you don't know the actual starting condition. That's it.
Yeah. Unobtainable
It's not that you
measurements.
don't know them, it's that the system has sensitive dependence on them, right? I mean,
Yeah,
you
yeah,
might
yeah.
know them, you can know them as accurately as you want.
Oh, say it again.
It'll never be
Say it again. Say
accurate
it for the
enough.
6th time, please.
But
Well,
if we did know them,
if
but
you
if
would
we did
just
know the exact
agree,
values and it is a
so
deterministic systems,
so
we would make
rigor
the correct
rigor.
predictions. We wouldn't have any
Do you
chaos.
understand now? Locksmith, shut the fuck up. Rigor,
You
do
shut
you
Bro,
the
I would
fuck
slap
up.
the
understand
Who are
fuck
you
now?
out of you.
talking to, guy? Who do
I'm
you think you
talking
are,
to
bro? You come in
rigor.
here, you fucking act like a
I'm
cunt, and then
talking.
you start telling people to shut the fuck up.
I'm
Dude,
John, this is
talking
you're like a
embarrassing,
to.
bro.
retard version of zzpop.
Okay, so rigor, do you agree then that that the chaos we're talking about is in systems for which the motion of the system is completely determined for all time with no randomness by the laws that govern the system?
If you hold to the assumption that your axioms are true, even if you get a failed prediction, you don't have to change your axioms. You can attribute it to chaos, right? And the initial conditions being wrong, right?
Question for rigor.
Well, that was directed at you.
You got your answer.
Is that your
Someone's
answer?
butt hurt. I think someone's butt hurt rigor because they don't like a certain type of accent and they don't think that it's fair that someone with your accent can be more clever than them.
Well, I think it goes back to the other server because he got clipped calling relativity a toy model. And Briggs
No,
clipped him
Relativity
on that
is a toy
server, and now we
model.
play that soundbite every time he starts talking about relativity and double speaking. He got caught like 3 times
Relativity
double speaking on
is a
relativity,
toy
and
model.
then they soundbited him, and he's admitting relativity is just a toy model. It's pretend. It's
Relativity
make
is
believe.
just a toy model. It
wait,
exists
say it one
only in
more
our
time.
brains.
Let's get a new clip update.
Well, I don't know why you think somehow that's
Dawn blew him
embarrassing
out,
to me.
dude.
It's the
Dawn
truth.
blew him out hard in the
Relativity
relativity
is
debate,
a
and I was
toy
championing
model that
Dawn.
lives only in
Wait,
It
you
our
was
said
so
brains.
blah?
loud.
You said blah blew him out?
No, Dawn.
Oh,
DAWN. Oh, he caught him double speaking like 3 times, bro. It was
Where's the
brutal.
Just
double speak?
curious. Super John.
Relativity is
John, you
a
got
toy
clipped up.
model that lives only in our heads. Where's the double speak? Where did I double speak?
It doesn't apply to reality. Only in our
Oh,
heads.
no, I'm saying during
Didn't
the
say that
debate,
it didn't
Dawn
apply
called
to
you out 3
reality.
times for it. It was
You
fucking
said
For
only in
crazy.
our
what?
heads. That would mean not,
Well,
outside of
called
our
me
heads, right?
out for what, Rigor?
Because you were saying things like that, and then you were saying, yes, space and time do curve in
I
reality.
did not. It's exactly what I did not say. I
You
pointed out
see,
that
that's what I mean. It's like you just lie. It's like,
Are
dude,
you saying that?
I was there.
find a clip. Find a clip of
Yes,
me
that's what's
saying.
happening.
Find a clip of me saying space and time really do curve. What
When
I
you're on the
always
soundboard.
say. What I always say is that space and that space time is a thing, is an element of a model that lives only in our heads. I don't know if thing called space time. I don't know
But
if it curves.
that's the fabric that curves in relativity. So
In relativity, yes, but
Right.
relativity
So when we
is a
talk
toy
about reality
model
and then
that
you invoke
lives only
relativity
in
and
our
tell me
brain.
space and time is bending,
So what
there's
you're
a
saying is
problem
that
there.
relativity is a conceptual model, basically.
Relativity is a toy model that lives only in our brains, and it makes
only in our brain.
predictions only in our brains.
So it doesn't
And
So
that
apply to
does it
reality.
pertain to reality?
and that model makes predictions that are absolutely true in the model. Now the question is, do those predicted things actually happen in the real world? That's the science part.
Right.
When
That's the
you
question.
have
Do
a
you think
model,
space and
you
time is
have a
bending?
toy. Shut the fuck up while I'm
Yeah, no, for
talking.
real.
You have a
Dude, you're just
toy model.
monologuing, guy.
Okay.
I know
I
we're
can
You're
expected
trying
to
to
stop
sit
get
through all
to
talking.
these like
you're trying to
I'm
get to
just
the
boring
meat and
sorry.
monologues.
potatoes.
I'm just kind of curious. Super John, where did you say that you actually worked in? You said some dynamic systems or something.
Well, I was a professor of physics. I don't know what you mean. One of the areas that I worked in was
He
chaos,
taught high
when
school
chaos
math.
theory first came out.
That's why it's so
It's
embarrassing.
interesting. I'll let you know. I actually work in control theory, so but
Okay.
I'm an engineer, not a yeah. So
Do you think
that's
it's a
kind of
So
it's
toy
you're
kind of
model
weird.
too?
so I
Do you think
assume
it's a
you
toy model,
understand
Thrill?
deterministic chaos.
Yeah.
Yeah, yeah. Thrill is relativity a toy model.
Uh, I mean, based off. So just to backtrack a bit, like the idea of space time. So first of all, I'm not a physicist, so I'm not the one you should be asking. But from what I understand, the idea of space time is just this abstract notion that exists in equations that has predictive power in the real world. Now, if you want to say there's no such thing as space time, it's all fairy tale, that's fine. But then you have to replace it with a model that can actually make predictions. And until you can do that, it's
Relativity.
like anyone's game.
Well, you don't have to
Classical
replace
mechanics.
it because the toy model called relativity, as far as we know, has never failed to make correct predictions. And that is to say that the things that do happen in the model, I can prove that space-time does this or that light does this or that in the model. Now, the only question is, does it do that in reality? And that's why we make observations.
Dude, I
Every
could prove time
time,
travel's
every
real in the
time
model.
we've made a prediction of something that should be observed, if if reality did observe the toy model, every time we've actually made that measurement, it's turned out to be true. That gives us some faith that the model is on to something. It doesn't mean that space-time exists. It doesn't mean that it curves.
Yeah,
It
even with your
just
model
means
guy,
that the
you ever
model
gonna
is
land
on
this
to
plane,
something.
bro? Even in the model, I could prove time travel is real. With what is it, closed time curve loop or whatever it is?
Yep, that's
It's
right.
like, okay, where's the predictive capability in there? If the model's real, model's reality, go ahead, go time travel.
Yeah, no, that's right. In the toy model, uh, it appears there's nothing to prevent people from going on closed time like loops. Now, we haven't been able to do that. We'd like to, right? People are trying to do things like that. That's a potential flaw in the model. It does predict that you can do that. We haven't been able to do that, but that's not because we've done
Because the
it
model,
and it
because that
hasn't
part of the
worked.
model's wrong.
Well, that part of the model may be wrong, right? I mean,
No,
if we
it
ever
definitely
had the
is.
ability to test that, then we could see if it's true or not. There's a lot of people that think there may be other things that come into play because they just don't like it, right? People don't like the idea of closed time like loops, which do exist in the model.
No, because it's incoherent.
It's
It doesn't make
absurd.
any sense.
Right. Yeah, physicists agree with you on that.
So when we start talking about reality and we're like, oh, yeah, do you think space and time is curving? And when you're like, yeah, that's what's happening. And
Well,
then you're
you've
like,
never
well, it's
heard
just
me
a toy
say that.
model. Yeah, I have multiple times, guy.
Well, now you're the one that's lying.
Yeah,
You
yeah.
will
And
not
I heard
find
you
a
talk
clip of
about
me
how there's
saying
like
that.
what was it? What were you trying to describe? How there's like a circle, a flat circle that curves onto itself, and there's another dimension, and that blah blah blah. Yep, yep. I heard you talk about reality like that too.
No, you'll never hear me say something like that.
You and Omni. Yep. Comical. So you don't believe in relativity? That's your new stance?
Okay, I think I've had enough of Rigor's dishonest, arrogant
I'm asking you.
ignorance.
Do you think relativity, general relativity, represents reality?
I don't. GPS
I
clocks directly refute relativity's
well,
strong equivalency principle.
yeah, so what I know is that every prediction of relativity that we've been able to test has been confirmed.
Well,
I'm
GPS
just
clocks actually
That
refute
wasn't the question, guy.
relativity's
so what exactly with
strong.
GPS clocks? Like how exactly do GPS
Well,
clocks refute
relativity's
that?
strong equivalency principle states that uniform gravitational field effects and
Hmm.
uniform acceleration effects are going to be physically indistinguishable. So now, when we look at the case of GPS clocks, we see that uh, the higher you go in the gravity well, so the more potential you have, the faster the frequency of the clocks are going to run. The lower down in potential, they're going to go slower. And then also, right, so there's a distinct effect for the uniform gravitational field.
It's not
And then
uniform.
simultaneously, there's a distinct correction that has to be made for the uniform acceleration or the velocity component. So how the faster you go, the slower the clock is going to run. The slower you go, the faster it's going to run. So you have to account for both of those cases
Yeah,
simultaneously.
that's
That
exactly
refutes
what we
no.
have to use relativity to account for the difference in clocks. That's something that's predicted by relativity.
No,
That's
because
something
we
that's
use
determined.
distinctly different correction formulas simultaneously.
That's why
Relativity says both of
GPS.
those cases, the
Jesus
uniform
locksmith.
gravitational field effects and the uniform acceleration effects, are going to be physically indistinguishable. GPS
No,
clock shows that we have to correct for both of those cases
we have to
simultaneously
correct
and
for both of
distinctly. That
them
refutes relativity's strong
simultaneously.
equivalency principle.
In GPS, we have to correct for both of those effects simultaneously, or the system wouldn't work. That's right.
And distinctly, that refutes relativity's strong equivalency principle, which says both of those cases should be physically indistinguishable.
No, it's just not true. I don't even know why you say
Well, if you
that.
can't put it together, right? I can't, you got to piece it together. Sit there, take a
The
second. Hi, Phil,
reason
let's check in with you.
the reason we make the corrections in GPS is because relativity says you have to. That's why we do it.
Buddy, do you understand the difference? Uniform gravitational
Not
field effects
uniform.
and uniform acceleration effects, right?
It's not. It's not.
Relativity. What is strong?
It's
What is the
not
strong equivalency principle of
uniform.
relativity state? Wait,
It's
you don't have to
not
talk through me. You don't have to
uniform.
chant through me,
It's
buddy.
not uniform.
I'm sorry.
You keep saying uniform. There's no uniform gravity involved. PS satellite.
So
There's
Earth doesn't
gravity
have a
of the
uniform
Earth.
gravitation. It doesn't have a
It's
uniform
not.
gravitational field. There's not a
It's
It
not.
gravity
does
It's
not
well.
not.
have
You
a.
don't
How
raise
many
in.
times do I have to say it? It's not uniform. Jesus.
Okay,
If it
okay,
was
whether it
uniform,
is,
Earth would be a
it is
point
uniform.
mass.
And you got the inverse square law. Yeah, so the gravitational time dilation and velocity, combined. And they are both independently measured and accounted for. And the proof is it works.
That refutes relativity's strong equivalency principle, which states
But it
both of those
works.
cases, the
It's just
potential,
not
the
true.
effects from the increase or decrease in potential, and the effects from uniform acceleration, the velocity component, and relativity, those are physically indistinguishable.
Let's
GPS
just
Did you
say
clock
do the
you're
shows
math?
that
Did
ignorant.
you
they're
do the
not
math?
physically indistinguishable. You have to apply distinctly different corrections simultaneously.
Yes, and you do. You apply
And
both
that refutes
corrections
relativity. Thank you.
simultaneously. Yeah, and then and then you say it refutes relativity because of your arrogant ignorance.
It is the issue that gravitation time dilation and velocity acceleration both create time dilations? Is there a problem that the effect on time dilation can be had by two different phenomena? Is that your problem?
Yeah, you're required to make distinctly different corrections in both cases when relativity strong equivalency principle states that both cases should be physically indistinguishable. So you're
I don't.
applying distinctly
By
different
saying
formulas for both
indistinguishable,
cases simultaneously. That's the
He's
but
got
major
by
this
problem.
saying
talking point that he doesn't even understand. I don't understand it. I
by
don't think
say,
he does
That you
either.
don't understand it,
okay,
you're an idiot.
by saying they're indistinguishable, you're just admitting gravitational does affect time, and acceleration all and velocity also affects time.
No, you're not tracking. I'm saying they're distinguishable. Relativity says they should be indistinguishable.
Which
We
just
know
means
they're
that they're the
distinguishable
same.
because GPS clocks require you to make corrections simultaneously.
Yeah, by being
You just
indistinguishable,
don't
meaning
understand
yes,
relativity.
they're both time dilations.
How's
Yes,
that,
but
Satra? What exactly don't I
both
understand about
effects
relativity?
both effects are in
Like,
time dilation by two different phenomena.
In the general theory of relativity, the time on the satellite is simply calculated according to its motion and position. It's not even really viewed.
Buddy, you're not tracking
Activity.
again. We're talking about the GPS clocks, not the position of
You're
the satellites. You
interrupting.
gotta
You're
track. You
interrupting.
gotta, I don't know what you gotta,
You're
maybe have some
interrupting.
coffee or
You're
something.
interrupting. In the GPS system, general relativity simply says that the time, that the way in which the clock runs on the GPS satellite depends on where it is and how it's. And those get, you can think of those as being an altitude thing and a speed thing, but general relativity just says here's how fast this clock is going to run because of it's moving. That's
No,
all general
no, relatively
relativity
strong
says.
equivalency
Don't
principle
tell
says
me
that,
no. You don't know
no.
what the fuck you're talking about.
No,
What do
relatively
you've
strong
never
equivalency principle says
tell
we
me,
wouldn't be able to distinguish uniform
tell me
acceleration, so
about the
just
general
straight up
relativity
uniform
class you took.
acceleration,
Tell me
from the
tell me
effects
the
due to a
tell me
uniform
where you took
gravitational
your
field,
general
right? So your
relativity class.
potential within that field.
Tell me
Relativity
where
says
you
you won't be
took
able to
your,
distinguish
no,
from
that's
those
just
two
not
cases.
true. It's just not true.
Wait,
Now
it's
tell
just
me
not
where you
true?
took your general
You're just
relativity
asserting
class.
that. You haven't even
No,
been tracking the
you're
whole
just
conversation. You're
asserting
just,
that, and it's not true.
Well, and
Where
it
no.
did you take your general relativity class?
and by indistinguishable just means that yeah, it's both time dilation. Yes, it's time dilation of gravitational and time dilation by velocity. They're indistinguishable, but they have two causes.
And as I said, in
Hey,
general
wait, they're
relativity,
indistinguishable, but they have two causes.
all you
No,
Yeah,
do in general
they're
relativity,
actually clearly distinguishable and require two distinctly different correction
the
formulas to be
rate at
applied
which a clock
simultaneously,
runs, the rate
right?
at which a
So
clock runs
that's not,
depends
so that's
on where
physically
it is and
distinguishable.
how
That
fast
refutes
it's
what
moving.
relativity predicts,
The
right?
rate at which a clock runs in relativity depends on where it is and what its velocity is.
No,
Now, if you want to
no.
think,
We say
if
where
you
it
want
is
to,
within the gravity well, so it's potential
if you
within the gravity well,
shut the fuck
right?
up, shut the
You shut
fuck
the
up.
fuck up, you
If
fat
you
bitch.
know where, all you need to
You
know
guys
is
just
Look,
where it is and how
just reset
fast
and
it's
go.
moving. If you want to think of that as being two corrections, fine. But general relativity just says
it's not where it
here's the
is. It's
rate.
not if it's in Maryland,
General
then it has
general
different
relativity
effects.
simply tells you how fast the clock will run. Period. It tells you that based on where it is and how fast it's moving.
Wait. Can we just get to this part? So, what is relativity strong equivalency principle? What does that postulate? What does it state? What are the implications of it? Go ahead.
Now, you tell me.
Well, I've been saying you've hand waved it and you said it's just not true, but it
You
says that
so you keep saying it has to do
the
with
effects from
uniform
uniform
gravity.
gravitational fields, right? And the effects from uniform acceleration will be physically indistinguishable. That's relativity strong equivalency principle.
Okay, and that's true.
What
So what?
now it's true.
No, I mean that is true,
Now it's
but
true. Okay, so now that's true. Now we look at GPS satellites
the strong
for uniform
equivalence
gravitational
principle,
field effects and uniform acceleration,
there
applying
is
distinctly
no
different corrections
uniform
simultaneously,
gravitational
that
field.
refutes
You
what
keep
relativity says.
you keep referring to a uniform gravitational field that does not exist. We don't have a uniform gravitational field.
We don't
So
have a uniform gravitational field. Well, because the example that's always given when we're talking about relativity strong equivalency principle is a rocket uniformly accelerating, and someone just a lab just on Earth within the
Right.
uniform gravitational field.
And you
So
can
I don't
so
know where you got your
because
relativity
so
education, but maybe you need a refresher. Maybe you need to
tell
take
me
5 and just regroup.
why that example violates the strong equivalence principle. Why is it that an accelerating rocket in outer space and a person standing on the ground violate the
All right, you're not
conditions
here. I'm gonna
of the
hold your hand.
strong
I gotta
equivalence
spoon feed you
principle?
everything. It's ridiculous. Okay, so yeah, that's the example that's usually given. The example
Tell
that
me,
I'm giving that refutes
I understand
relativity,
that.
contain
I
yourself.
understand that.
Please
I
control your
understand that.
impulses, buddy.
I'm asking you
John, you
to
Control your
spiral
tell
so
impulses.
me
hard when someone chants through you or
I'm
interrupts you for a
asking
millisecond.
you,
And all
I'm
you
asking
fucking
you
do
to
is
explain
chant
to
through somebody while
me.
they're talking. And you're doing
Control
it
your
to me when I'm
impulses.
pointing it out. Just
All
stop
right,
so
could
being
you
a
guys?
dick.
Can everyone just hold on? Can everyone just reset? Sometimes it turns into like a traffic jam with the interruptions, and people get interrupted, then feel like they have to interrupt back. Can we just reset? Try to let everyone go one at a time so we can hear
Yeah, I
what
gave
people.
it.
just as a quick question, Locksmith. So how exactly does time dilation due to Earth's gravity or velocity, how does that break the equivalence principle? I'm just curious.
Right. Okay. So we went over the standard example given for relativity strong equivalency principle. A rocket ship going straight up, that's experiencing effects due to uniform acceleration. And then somebody standing on Earth or a lab on Earth is experiencing effects due to uniform gravitation or its potential within that well, right? So that's the classic example. Now, it says those two cases are physically indistinguishable, right? So now when we look at GPS clocks, we see for the uniform acceleration, they have to make one distinct correction. And for the uniform gravitational effects, the potential within the gravity well, they have to make a distinct correction simultaneously.
That
So
was
that refutes.
so garbled up. I can't believe it. First of all, it's not uniform gravity for the the 20th,
But you just
30th
agreed
time.
to it. I just gave the example that they give. A
I
lab on
know.
Earth
Okay, it's
is
my
the
turn
example they
now.
give for something
My
experiencing uniform
turn
gravitational
now.
field effects.
It's my turn now. Okay, and
But
I
you're
asked
looping
you.
again. You're just
It's
gonna do the
my
same loop. And I
turn
wasn't even
now.
it's actually not your turn because I was talking to side throw, so just take a second, buddy.
Tell me when you're done.
Side throw. Do you have a response? We're making two distinct correction.
Shut the fuck
Um,
up.
bro, nobody's
Okay.
talking to you.
Okay, look. So I asked you when you
No,
said,
not okay.
okay,
Nothing.
shut the fuck up. It's
No.
my
Or
turn
what?
now.
Or
Okay,
what?
tell me when you're finished.
Okay. How about never? Just like delete your account. How about that? I'll send you a letter in the mail or some shit. But I'm talking to side thrill, right? Because he asked me how it refutes relativity, right? Relativity says both of those cases should be physically indistinguishable. When we look at GPS clocks, we see both of those cases have to be simultaneously and distinctly accounted for. Yeah.
So that you're saying the fact that there's time dilation in both cases, it refutes the equivalence principle? I'm not really tracking.
Distinctly,
There's a time
right?
dilation.
Distinctly different time dilation effects that you have to correct for simultaneously.
There's a time dilation that occurs from the velocity, and then there's a time dilation that occurs from your distance from like some gravitational well. I think
Right, the
those are the two
potential.
cases that I'm familiar with.
You're
How does
right.
that how does that how does that mean
Right.
that how does that
Relativity says both of those cases would be indistinguishable, right? So when we
and
look
they
at
are
GPS
indistinguishable.
clocks, they must correct for both of those cases simultaneously with distinctly
One
different
correction
formulas
is
accounting for
one
different proportional relationships.
well, one correction is distance from a potential, and the other correction is for how fast you're going. That's a
Right.
time correction. I don't like
Right. So if you're up a certain distance within the gravity well, like a satellite in orbit, or at a certain distance in the gravity well, you have to correct for those effects, your potential in the gravity well, along with your velocity, right? So you have to correct for those cases simultaneously with distinctly different formulas. Relativity says both those cases should be physically indistinguishable.
relativity tells you how much that correction should be, which is what we apply. I'm really not tracking here. If it wasn't for relativity, we wouldn't be making those corrections.
Yeah, it's just gobbledygook. I mean, he clearly doesn't have the slightest idea what the fuck he's talking about.
No. So no. You can't have relativity saying that these effects are going to be physically indistinguishable, right? But then at the same time, we see with GPS clock that both of these cases are not being treated as physically indistinguishable. They're treated distinctly different and use different corrections simultaneously.
I confess, I don't even understand the argument. Yes,
But that's
relativity
been clear from the
says
beginning.
that
Like,
you
so you could
have
just stay where you're at in the not understanding zone
relative.
and just
Listen,
let everybody else who
I'm
understands just
talking
converse.
now. I'm
No, you're
talking
not
now.
understanding. You're just not
All right, can we
understanding.
just let
talking
John
now.
have a chance? Because the audio chaos is like worse than like I don't know. It's hard to hear. So
Relativity says that you have to make a correct. You can think of it this way. Good way. It says there's a correction because of its altitude in the gravitational field, which is not uniform, and there's a correction that you have to make because of its speed relative to observers on the Earth. And they do make those corrections. And if they didn't make those corrections, the system would work. Relativity says do it. They do it, and it works
No,
because they
relativity
do it.
does not say they would be physically distinguishable, though. It says they would be physically indistinguishable.
I don't
So
even
how
know
are
what
we
that
making
means.
distinct corrections for both of these cases
I don't
simultaneously?
even know what that means.
Which
They
part?
are
English. We're speaking
they
English.
are
Which part
two
don't you understand?
corrections.
So
Relativity says you have to make both corrections, and you
No, it
do.
doesn't.
Yes, it does.
You
You
just
just
said it
No.
does. You just said
You
it does.
just said it does. You
Yeah.
just asserted it. But I'm telling you, why did they give the example of the rocket ship for uniform acceleration and a lab on Earth for
I'm just
uniform
gonna.
gravitational field
what
effects?
does
I'm,
that have to do with it?
Well,
so I'm just gonna.
You said Earth is a lab on Earth wouldn't be experiencing uniform gravitational field effects.
That's
What would
right.
happen
It
if
There's a
has
few
the
things wrong with.
yeah? What would happen if the GPS satellite was stationary or just like a geostationary satellite?
yeah,
What
then
kind of
you'd only
correction would
have
you?
to do
Yeah.
then you'd only
Then
do the altitude correction. Yeah.
yes.
Yeah,
You're still
geostationary still has
moving.
a significant speed.
Yeah,
That's
you're still
And
true.
moving.
it has a gravity potential, a height
Yeah,
within the
yeah.
gravity
So
Well,
well.
yeah,
Right.
so there's a net time dilation from those two components.
well, let me raise an open question right here. So if I'm in a rocket, right, accelerating at 1g, and let's say there's a 100-meter difference from like from the nose of the rocket and like the bottom of the rocket, versus if I'm on Earth and there's a 100-meter difference, right? Do you think that wouldn't the effects of time dilation, doesn't general relativity predict that the effects of time dilation should be the same for both cases?
There would
So
be the clocks in the nose
At
would
the
run
nose and the
faster.
aft of the rocket,
yeah,
there's going to
Clocks
be
in the nose
Doppler
would run
effects.
faster.
Yeah, if it's not a significant difference in the gravity
Right.
potential, there's not going to be
That's right.
very observable effects.
That's right. But I mean, relativity does say that the clock in the nose will run faster than the clock in the tail.
right. So doesn't that answer your question, Locksmith, that like there's still consistency in time dilation even with the whole like I'm just trying to understand where your confusion is in like the equivalence principle. I'm saying that like even with the equivalence principle, no matter how you slice it, it's still consistent with say time dilation. So I'm trying to understand where the confusion here is.
Well, okay, so so the physically indistinguishable part, right? These effects should be physically indistinguishable, but we see both cases require distinctly different correction formulas, and they have different proportional relationships, right? So they're completely distinguishable and simultaneously have to be accounted for. So a satellite in orbit, it has to make a correction for its height within the gravity well and for its velocity.
Yes. And
Yeah, yeah. There's a net. There's a
And
net from
relativity
those
says
two
both
effects,
those cases should be physically indistinguishable.
well,
which
I don't
means
even know what
that
you
only
mean by
means
Oh
that.
my
in both
gosh.
case that only means in both cases it's time dilation. Yeah, you if you just have a time dilation, you wouldn't know if that's a velocity time dilation or a gravitational time dilation. Yeah, that's
Yes, we
indistinguishable.
do,
But since
because
we
we
know
correct
both
for
are
both of
recurring,
those
and
cases
since
distinctly
I was
different.
talking, and since we know both are recurring, and there's a net time dilation, yeah, the math works.
I
No,
actually
it does work. Yeah.
And it's only valid for a local system as well.
I'm actually
Yeah.
starting to like in the equivalence principle example, if the rocket started going really fast, let's say it's going 1G for like a year or something, right? Then I think you would still have an additional correction coming from the fact that you're like approaching the speed of light or whatever as like a limiting case. So I'm pretty sure that you still have that correction from time dilation. It's just the velocity correction, you still have to apply it. It's just that the equivalence principle example I'm giving over here, like you're assuming that you're starting at like rest and you have zero velocity, rocket starts off accelerating 1G at that moment in time. The time correction, the time dilation is same as on Earth. And then once you start, gaining velocity, then you still have to make that correction in the rocket. So it's still consistent. I'm not sure why you think it's inconsistent.
I'm not saying, well, I'm saying relativity is, the equivalency principle is refuted. If we have both of these effects should be physically indistinguishable, but we have to correct for
What
them.
does that mean? I mean,
No,
what,
yeah.
I don't know if you like which part don't you understand?
I don't
It's just something that
understand why
Alan
you're
said
getting
that he's
so hung up
repeating. He
on it.
doesn't know what it means. He's never
I
going to be
don't
able to
think
answer that
I think it's
question.
just a talking point. Yeah. I mean, yes, it's true. You can think of them as two different corrections, although general relativity just says it's one correction that depends on where you are and how fast you're going.
That's
But
the
you can think of it as two.
refutation.
The
You just
point
said it right there.
is,
You just admitted it. Relativity says there's one
okay,
correction. GPS
that's right.
clocks is what I've been saying all night.
And we
You
make
are
one
required to make two
correction. No,
distinctly
we
different
make
corrections
no, we make
simultaneously.
that's
Therefore,
not
they're
true.
physically distinguishable. Please
We
track
make
with us.
one correction to GPS clocks. We make one correction. The net
No,
correction
no, that's where you're
required.
wrong.
No,
That's the whole contention. That's the whole refutation that
that's
you're just
simply not
not
true.
listening
Well,
to.
we know that they run fast because of altitude and they run slow because of speed. The altitude dependence is a little worse than the speed.
Well, those corrections
They
are
do run
distinctly.
fast. They run fast by less than they would if they weren't moving. We figure out both things, we add them up, and we make one correction. The correction that is the net correction required because of the two effects. What don't you understand about that?
We
Is
say
he just
we make
arguing
one
that
correction.
like you have
We
to
apply
apply
two
two
distinctly
separate
different
corrections,
corrections.
like one at a time, and because you're doing them both at the same time, it must be wrong? Or, like I literally do not
Well, if they're
understand this
physically
argument.
indistinguishable, how are we able to distinguish the
What
two
the
different?
Literally just explain how they're distinguishable, dude.
Okay,
Well,
that's a
the
problem. That's a problem for relativity strong equivalency principle. I don't know if you've been living under a rock or
again,
just
Jesus
joined the
Christ, you
combo.
just keep saying these words.
Have I been living
What are
under?
you
Usually
talking
people
about?
don't say living under a rock when they're talking about relativity, by the way. But like,
Well, okay, maybe not at your level, but like I talk with
okay,
PhDs and
okay.
physicists, all
If you,
type of
like
high
literally,
level
you have a
yeah,
PhD in
intellectuals.
the chat,
yeah,
bro. Like,
Yeah,
if
you're just not at that level, buddy.
yeah, if
no,
you observe a
I'm
time,
definitely not at the level of PhDs in physics. That's
You
true.
don't really have anything to add to the convo, so you just bow out.
yeah, if you encounter a time dilation and that's all the information you have, it is indistinguishable from a gravitational dilation or a velocity dilation. Yes, that aspect is indistinguishable. But we have both components; they get added together, and then we end up with a net time dilation.
So,
Yeah,
so John just said they're indistinguishable. Mortimer just said, "Oh, of course they're distinguishable. It's obviously
well,
I don't know. I don't know.
the causes are distinguishable, but it's just time dilation that you don't know its source just on that. But we have
Yes, you do
gravitation
know its
and we
source
have
because you apply
velocity.
different corrections
For
simultaneously. So you
But
fuck's
you
do.
add them
sake.
You
together,
know
yeah,
which
because they're
effect is
both
coming
time.
from which source
They're
Is
both
simultaneously.
yeah,
there
but they're
is there anybody in here who's going to step up and say they agree
You're
with
just talking all
Locksmith?
over yourself.
They
You got your
understand what
wires
he's
crossed or
saying?
something.
Does
well, but
anybody in this room understand what Locksmith is saying? Can
well
anybody steel man
the
him?
the point
My
being the
Anybody?
point being that both of those corrections are time dilation, and they can be added together, and you get a net.
Right. So how can we tell one time dilation from the other?
Really,
Why do we need to apply
seriously,
We don't
can
distinctly
have
I
to.
different
just
We know.
corrections for
We
both
don't have to.
cases?
We know there's two.
Because they're due to two different phenomena. One
Oh, so
is
they're physically distinguished. We can
gravity.
physically
One is
distinguish the
gravity. The other one is
phenomena.
speed. Or yeah,
Wow.
can I
yeah.
get
So we can physically
anybody?
distinguish
Is
it. Okay.
there anybody in this room, anybody who can
Bro, we
stand
don't
on what Locksmith is talking
Uh,
about?
go
Anybody?
ahead. Yeah, I'd love to hear
If
that.
not, I'm moving on.
Gonna say
Yeah,
my guess is in the kind of like the rocket ship versus lab picture that he saw. Um, I guess my assumption here is that like he's asking why aren't you accounting for the velocity time dilation in the rocket ship example and not accounting for the velocity time dilation on the lab, so therefore they're different or something.
No, that's a horrible. That's not a steel man, brother.
Okay,
I'm
so
saying it's
I don't understand
relatively
what you're
says that
saying.
both of these cases are physically indistinguishable. Why does GPS clock show that they are actually physically distinguishable and require distinctly different corrections, right? In order for clocks to run properly.
It
Okay,
goes.
Yeah,
It goes back to
moving on.
indistinguishable when it comes to acceleration.
I'm
well.
sorry, what was that?
The point being, if they're in both of those causes, the result is a time dilation. That the time dilation from velocity and the time dilation from gravitation are both units of time. So yes, they are indistinguishable. But we know that there are two sources, and we have correct separate formulary for each. And since they both return corrections to time, they can be added together, and you get a net.
And at what situation would they be indistinguishable? That would be you would need like a uniform acceleration, and you also would need a uniform force of gravity, which we do not have.
And the non-uniformity of gravity is given its position in the gravity well. So yeah, you got the inverse square law, and the gravitational potential of the orbits of the GPS satellites is well monitored, is well known, and their velocity is well monitored, is well known, and they calculate the correction for the gravitation, they calculate the correction for the for the velocity, they add them together, and they get a net. They
Yeah,
can
that's a
add them together.
problem.
They
They
can
shouldn't be
add them
able to
together.
distinguish
No, they can
between the
add.
two.
Hold on. They can add them together because they're indistinguishable. Because they're both just units of time.
They're indistinguishable, but we can identify each one and add them and get a
No, we
net from them.
identify. We identify
No,
their
if we're gonna
sources.
add them together, we have to be able to distinguish them,
No,
right?
where
Physically,
I
yeah. Or else,
the but
if they're indistinguishable, what are you adding together?
the time dilation of one is identical to the time dilation of the other, but they have
No,
two
it's
different
not.
sources. They have two different sources, and
Yeah, just bow out. Yeah, that's a problem for relativity. Relativity
no, it's a
says both
problem for
those
you.
cases should be physically indistinguishable. GPS clock
But
shows
that's not what it's saying
they
should physically.
require two distinctly
What
different corrections
what they're
simultaneously.
what they're saying should be indistinguishable is that 1 g of acceleration should be indistinguishable to uh, just one unit of force of gravity on Earth. Like it's indistinguishable to be under Earth's gravitational fields versus accelerating 1 g in a rocket. Those are the two indistinguishable things.
Oh, they're
So
Yeah,
saying
they
if you
have.
were in a blind lab on an accelerating rocket versus just a blind lab just sitting on Earth, you wouldn't be able to tell the difference between the two cases, right?
That is not what you were
Yes, it
proposing.
is, bro. That's the mainstream example for the equivalency principle.
No,
The uniform
sorry.
acceleration from the rocket and just a lab just in the gravity well chilling, those effects, those are physically indistinguishable, right?
Yeah, as long as the acceleration is exactly as the gravitational force on the surface of the Earth. As soon as you
Well,
move away,
yeah,
as soon as
in
you
the
move
moving
away from the surface,
in
yeah,
the moving in the moving clock, there's going to be a different time dilation than the stationary laboratory clock because
yeah.
one's moving and one's moving relative to Earth, and one is not moving relative to Earth.
One caveat with that equivalence principle thing is that there's no difference between being in the accelerating rocket and being on the surface of the Earth, as long as you don't do experiments that extend too far vertically or to the side, because it's not a uniform field. It's only uniform within an infinitesimal volume. Or maybe if you don't look too hard, maybe you can extend that to a room-sized volume. Maybe you can extend it to a warehouse-sized volume. But the point is, Earth's field is not uniform. It is uniform enough for that equivalence principle to be applied, pretty well. I mean, it's a good example, but it has nothing to do
Way bigger
with
than a football
GPS
field.
satellites and time dilation. It has
No, it
literally
does. It's
nothing to do
relevant
with
because
that.
that's why they brought up the rocket example, right?
No, that's not why they brought it up. The gravitational, first of all, the speed thing really has nothing to do with it, because that doesn't even do with gravity at all. The gravitational part of it is a result of the height. It's not a result of the strength of the field. It's a result of the altitude and the strength of the field. So the equivalence principle itself has really nothing to do with either of those things.
My guess is that's probably where he's getting confused, because that's like, oh, well, why doesn't the equivalence principle also include the effect of time dilation from velocity? Because the rocket is moving, so there should be an additional effect or something. So in that
Yep.
sense,
Well,
technically,
the rocket example is more complicated than a satellite example.
No. The rocket example is the standard one they give. The GPS example refutes
Oh, but
relativity. They don't.
yeah, but the fact that it's a standard when they give doesn't change what he's just said. In the satellite example, you do not have a gravitational field being felt, right? In the rocket, in the equivalence principle example,
If it
it's the
wasn't
fact that in
complex, you
that
simpletons would
accelerating
already
rocket,
grasp it by now.
you feel like you do on Earth, but on a GPS satellite, there is no gravitational field in the frame of the rocket. So there's nothing to be equivalent to. The gravitational field is zero in the frame of the rocket, frame of the
And
GPS
Zero.
GPS satellites have a very constant speed and a very constant gravitational potential, given their
Mm-hmm.
24,000 kilometers out and 8,000 miles an hour orbital speed. It has very little changes in diurnal. So yeah, one, gravitation causes time dilation and velocity causes time dilation. That's indistinguishable in the result, because I have two time dilations. They're different values, but it's still a time dilation can be added together and you get a net.
Buddy, they have to pre-calibrate the clocks for the velocity that it's going to be operating at and the potential that it's going to be operating at. All right.
Well, they
So
monitor the
they
clocks.
apply for those corrections distinctly and simultaneously.
They monitor the clocks, and in the ephemeris that you receive from the satellites, you get clock corrections as part of the encoded data from the satellites.
What's your point?
The point is, it works because there's a net from both of those causes.
You're saying both of those. That means they're physically distinguishable. Then.
Well, the causes are.
Well, the values are, or else you wouldn't have two different values there.
Well, no. Gravitational dilation is one value, and the velocity dilation is another value. But they're both time dilations, and they can be added together, and you get a net.
So the sources are distinguishable, the values are distinguishable, the proportional relationships are distinguishable. How is it not distinguishable?
I have no idea why you're going on with such gibberish.
You can't follow along. You're saying they're distinguished, they're undistinguishable, yet we can identify both of them separately and add them together to get a net value.
The
But then you're also
indistinguishable,
saying they're not.
the indistinguishable part is
You're just
the
like caught in
output.
an absurd like loop right now.
No, the indistinguishable part is the output. It's a time dilation. One is like 4 microseconds, and one is
That's a
20
label.
microseconds.
That's
You can
just a
add them
label.
together.
You're just
Hey, I'd like to
labeling that. We have
suggest,
two
because it's
distinctly
really
different
obvious
effects.
to me, it's really obvious to me that nobody in this room can steel man what Locksmith is saying. I
That's
suggest
bad.
that we
That's
all
bad. That's really
stop
bad, though, John. You should
talking
be
to
able to
him.
easily steal man.
So I
That's
mean, I
bad.
just
Could it could
I
it
have
be
I
could
have
it be
moved
that
on. Can we all just move on? This is
Bro,
ridiculous.
if you can't steel man him, it
Nobody
means you don't
can steel
understand
man
what he's
him.
saying. That's not like a
So steel
rebuttal to
man
his
him. Okay, then
position.
steel man
It's
him.
like saying
could I
Steel
I'm
try?
not
man
arguing with
him.
him. I'm not choosing to argue with him. I don't have to
Well, and
understand his
I'm
position.
suggesting
I
that
don't have to pay
nobody
attention to
should.
what he's saying because I'm not sitting here holding down the mic button.
Let me just
But if you
beg
Could it
don't
be
my
that what it's
understand
fellow.
what
trying
he's
to
saying,
Let me
say?
just
try
let me
to
just beg my
understand what he
fellow
says
folks.
before you argue with it.
Stop
And please stop
arguing with
chanting through me, you
Locksmith.
fucking cocksucker.
So just
I
please
think what
stop
it's trying
arguing
to
with
say
him.
is that since it's so-called indistinguishable, it doesn't work. Sort
No.
of. No?
I'm saying it works because it's distinguishable, and that refutes relativity.
How do you
Which
refute
says both of those
relativity for
cases
that?
should be indistinguishable. It's not that hard of a train to follow.
No, that's only applies for a local area with
Yeah,
constant
the
gravity
local, right? The
and
GPS.
constant acceleration. Well, just think about the example. If you were in a rocket and you were moving like half the speed of light away from Earth, and then you stop, and then you compare the time dilation between the time on Earth and you in the rocket. There's no gravitational effect on you in that. So when you do the calculations, you leave the gravitational time dilation effect out of it.
I'm not sure I follow. We're looking at the accumulated data from the GPS clock, which all that data is recorded and accumulated locally, live as it occurs.
Yeah, and you do know, like they did like one experiment where they had two atomic clocks and they lifted one only 1 feet up and they could measure the time dilation. That's due
Okay.
to gravity and not speed.
Okay, that's one of that's. I mean, it's kind of relevant. Can you like tie it in, like or you know,
Yes, because that's due only to the change in the gravitational force or
the
effect.
potential or
But
the height
yeah,
within the well, right?
yeah. But if you remove gravity, and let's say we have a spaceship outside of the solar system where gravity is very weak, and you travel at a high speed, you will have a time dilation, which you would calculate then without gravity, and the result would come out correctly. Two effects giving the same result.
The same result. I mean, Shuba was saying there's two effects, and you add it together to get a net result. Is that what
Yeah,
you're saying?
one time dilation is due to the gravitational field. The other one is due to speed relative between the observer and the object. And it's like, yeah, they both produce apples, and you can add the apples.
Yeah, but then we look at GPS clocks. They're being corrected for simultaneously with different formulas.
Yes, they are, because two different effects.
But that's what relativity says. Those effects should be physically indistinguishable.
No, it doesn't.
Oh.
Because the equivalent principle only applies for a small local system where the gravitational field and the acceleration is exactly the same.
Yeah, the GPS clock would be the local environment where all the data is accumulated and recorded live, right? So it's all being accumulated and recorded live locally.
And the gravitational field acting on the GPS is what compared to an atomic clock down on the surface of the Earth?
No, you could just look at the accumulated data. So, okay,
No,
at
no,
this
no, no.
time,
Answer
at
the
this
question. Just,
velocity,
yeah, hang on.
the clock is running this speed, right? So you don't have to beam it back and worry about, data transmission and stuff like that. You can just look at the accumulated data.
Yeah, but you do agree that the time dilation effect due to the gravitational field will vary if you're down at the surface or you're high up
Yeah,
above the
that's the
surface.
potential. Right, that's the
Yeah,
uniform gravitational effects. It varies due to potential, like you're saying, how high you are within the gravity well. Yeah.
yeah, and that would give you a time dilation. Yes.
Yes.
And if you move at a high speed,
The higher
would
you
that
go,
give
the
a
faster it's gonna go. The lower you are,
no,
it's
no, no? Forget that. It's just an
oh,
example out in outer space. If you
mhm,
were in a rocket moving very fast, would that
mhm.
create, without any gravitational field acting on you, would that affect the time dilation?
Yeah. The faster you go, the slower the clock is gonna
Okay,
run.
so you're two different phenomena, both resulting in time dilation. I don't see
Mhm.
what your problem is.
I mean, it introduces a lot of problems. I mean, it refutes the equivalency principle, which says those cases should be physically indistinguishable. They're clearly not. Um, I mean, if you look at
No, again,
falling light,
again,
a
Well,
falling light, if light's coming down and it's falling, it would have um, it would be going slower because of its velocity, and then it would also be going slower based on its decreasing its gravity potential. Right, so that's double
light
slow.
would change speed.
But that's, I mean, that's what I'm saying. That's how it's a problem for relativity.
It's the whole point of
No,
relativity.
the whole point of relativity is that the speed of light is constant.
Okay, buddy, if light is decreasing in gravitational potential, right,
Except it doesn't.
it's gonna have those time dilation effects, right? And if it's going
No,
down, it has a velocity, it's gonna have distinctly different and added set of uniform acceleration effects.
no,
This is a problem.
Light
This is-
doesn't
like,
experience
like,
time
like this. Yeah.
dilation
No.
because light doesn't experience time.
But what it does is that
Wait,
it
what?
could be red or blue shifted due to gravity. But that's just changing the energy of it.
Yeah, but
In the light's reference frame, it doesn't experience time. In someone outside of light's reference frame, you could be you could be doing whatever, and the whole point of general relativity is to fix that to the speed of light, regardless of what frame you're in.
Mm.
The whole reason why everyone else is experiencing all these time and length dilations is because light is fixed regardless of what frame you're in.
yeah, I don't know. I
It
feel like
is.
that's a faulty assumption. Even zzpop, he doesn't like that axiom of relativity.
So what you're trying to say is that the speed of light will change in a gravitational field.
The speed of light changes a lot of places.
No, it doesn't.
Most, yeah, due to the medium that it's in, for sure.
The speed of light inside the medium is the speed of light. It's just that it bounces between the electrons.
Yeah.
That's why it takes longer for the light to go like through a glass, but the speed of light inside is the same as it is outside.
Well, if you look at Fresnel's drag and like experiments like that, you see that the moving water actually drags the light with it, so it slows it down. So it's not just uh, you know, c. It's c plus v, the velocity of the medium. So you're wrong. Yeah, sure, but I don't get how you don't see it. Like You know, if we have a satellite at a certain gravitational potential, it's going to have to correct for the time dilation effects due to the potential and its velocity simultaneously. So if we
Yeah.
slow down our velocity, the potential correction is still just going to be the same correction, but the velocity correction has to change, right? Both cases are physically distinguishable. I don't. Yeah.
Yeah, what you just said is perfectly reasonable. Right. We know the velocity, and that returns a dilation. We know the gravitational potential, that returns a dilation, and they're both in units of time. They can be added together to get a net. And if one component changes, then you're adding, a different value to the previous static value. So what?
I don't know. Like we both agree they're distinguishable because they would have to be distinguishable for you to add them together and get a net, right?
No, they have distinguishable sources, but they're
And
both in the
values.
same they're both in the same units.
Distinguishable sources and values.
Well,
That's more
output.
distinguishable than
Yeah,
not
but
distinguishable. And we're
but the,
able to identify them and add them together to get a net. That's pretty distinguishable to me.
there could be a
I think it's
combination
coming
of
from the
gravitation. You can have a combination of gravitation and velocity, which cancels it out to zero. Yeah. So what?
What?
this is
Okay.
I think the confusion here might become the fact that like if you have a lab on Earth, right, you're doing experiments. What the equivalence principle is saying is that like the experiments will be exactly the same uh, in the inside of the rocket. So inside in the reference frame of the rocket, the
Mm-hmm.
experiments will be exactly the same as a reference frame inside of a lab.
Mm-hmm.
Like whatever experiments you run inside of the rocket, to that observer, it's physically indistinguishable to whatever you do inside of a lab on Earth. Like if you want to count for time dilation on Earth, you would go, you go, 100 meters up, you'll notice a time dilation on Earth. You go 100
Mm-hmm.
meters up, you will notice a time dilation in the rocket because of the fact that it's accelerating. The
Wait.
velocity
Mhm.
correction that you're talking about is when you're outside of that frame.
But the GPS clock shows that both of those, no, well, locally, even on, I'm going to tie it into the rocket, but it shows that both of those cases, we have to correct for them distinctly. So in the rocket, which is uniformly accelerating and is experiencing effects from the gravitational field, we would have to correct for those distinctly as well.
Not if you're an observer inside of the GPS satellite and you don't care about in your like your whole world is inside of the GPS satellite, then
Yeah.
you don't care, then you're going to have the exact same like outputs of the experiment as to what's on Earth. The velocity correction is only coming into account when you're trying to communicate in two different frames of reference, a frame of reference on Earth versus a frame of reference in the
No.
rocket.
No, that's why I wanted to make that clear that you can just look at the accumulated data that's being recorded locally within the GPS clock, right? Live data, live accumulated data. You can look at that data. You don't have to worry about beaming it back and worry about you know, the the transfer there. You can just look at the accumulated data local
Right.
to the GPS clock.
And
And what it shows you is that in both cases, uniform gravitational field effects and uniform acceleration effects, you have to correct and apply for those simultaneously with two distinctly different corrections.
because well, all that the clock data from the GPS is showing is like just how those atoms are, how fast those atoms vibrate, per second is telling you one tick of GPS time. That's if you don't know what reference frame you're in, you're not going to know how to apply a correction. that the GPS data isn't telling you anything unless you know the context from an outsider observer.